documentary.
Nah, they can't do it. The contract too solid. Unless they're, I don't know. Never know.
I mean, I don't think they're gonna make a Netflix documentary, but the fact that like whatever we're expecting to see, if we don't see it, then
Oh no, I just had my hand up and I was asking when if hers was up before mine, so I thought there was
go for it. Yeah, this is like open. This is like open discussion. I see Lynn too, but yeah, you guys could go ahead.
No, you go ahead, Sacred. I didn't know you were about to talk.
I forgot exactly what I was about to say. I think I was gonna say something about like a lot of the Gilberts are just like denying or just ignoring all the work that Joe Hamby's putting in. Like I said in the beginning, it's one thing to argue the mechanics behind some of the way that it's being modeled and the phenomena itself, but you can't say it's impossible anymore. So shout out to Joe for helping out with that. So like again, this doesn't really seem like a problem.
I get what Miles was saying though. I definitely think they're itching the quote unquote they, whoever was paying Duffy's debt and orchestrated all this. I think they are looking for another quote unquote hit piece, even though they know things are a little different. Sorry, Jaren, it's not 2014. You know, the contract a little different. It's a little thicker, but they are looking for another gotcha. Like Miles is kind of saying, they're looking for another hit piece in a way. I don't think they need to put Witz's face in it though. They don't need to have the flat earther this time. They just need the narrative to go around that they went to Antarctica to prove that Earth is a globe, and then they'll just push that to continue the next 10 years, you know?
And then we'll just keep asking them, well, why the hell you had to fake 10 years worth of Antarctic 24-hour sun videos if it was here the whole time? Cap ass globe earthers.
I do like
Okay,
that. That does make sense. Sorry, go ahead.
I have a request from the flat earth community because I've been looking for this video forever. So basically there's a cool flat earth video and it plays this song Jericho in the back and it's like really catchy and I've been looking for it forever. Wait, let me play a second of it. Y'all know this song?
Sorry, go ahead.
You know what I'm talking about. Okay. So there's a cool like flat earth video with all this different evidence they put together with that song in the background. And I thought I had it saved, but now it's gone. And I'm freaking like looking everywhere. And I'm just wondering if anybody knows what I'm talking about. If you do, just like drop it or tag me or something. I'll be so thankful. That's it.
I'll probably find it for you. Some way, somehow.
Shucks, if we're talking about flat earthers and lost like videos and stuff like that, one of the first videos I watched was from this guy. He had like his name has something to do with like a duck or something like that, and he was one of the most like informational dudes, just giving it to you as straight as possible. And when I first saw these videos, that's what changed my whole perspective in like 2014, 2015, and I haven't been able to find this guy. Do you guys know what I'm talking about?
So you haven't been able to find the sky?
No, this guy, the guy who I'm talking about, who made these videos back in like 2014, 2015. He was like one of the first flat earthers I had ever seen on YouTube.
It could be ODD, could be Airy Bay.
No, it wasn't those guys.
Could be...
Those were like the big names. He was like super, like, I don't want to say underground, but like in regards to like the flat earth like community, he was like one of the underground voices. And then he disappeared.
I don't know, man. Need a little bit more of a description that may happen more often than you think.
He looking like a man?
Yeah, right.
Did you guys ever watch Robert Bassano?
Hold on, real quick, Miles, because I forgot last week. Lynn wanted to ask which is something that she keep on missing him just by like a fraction of a interferometric wavelength.
Fraction of an arc second.
Fraction of an arc second. But he is listening, Lynn. I don't know if you wanted to still say what you wanted to say while we still kind of have him within our conscious realm.
Oh, I hope he's asleep. He sounded so tired. No, I wanted to ask him, I wanted to tell him, first of all, that what he said last week really moved me, and it gave me more confidence in his trip and everything. And I was going to ask him where I could donate. And then kind of find he really needed it, so I was able to donate earlier this week, and he acknowledged that. So what I raised my hand for was we lived in Alaska, and I don't know if it's the same shade of blue, but I think it is, or if it's like the same.
Hey, you said you live in Alaska?
We did for 14 years, yes.
Oh wow, I didn't know
And
that.
so, yeah, so yeah, our kids were mostly raised there. The glacier ice is that same shade of blue or very similar. And my oldest daughter, every summer of college, her best friend's dad, Stan Stevens, had a boat that he took people out on cruises to the Portage Glacier, and then they went to this island where he had a camp set up, and he fed them, an Alaskan, meal, that kind of thing. And then all their water, their iced tea and whatever, had the glacier ice broken up in it instead of ice cubes. So, but I don't know if it was the same consistency, because I've heard kind of almost magic things about the ice from the ice wall. So, but I just thought I'd throw that in, that the Alaskan glacier ice was similar anyway.
The Alaskan bullworm. If you know, you know.
Only blue ice I know is from Breaking Bad. My bad. That's.
What about Waterboy?
Adam Sandler.
Is that
Yeah.
was that a movie about a man who put water in a telescope to measure a star's zenith angle?
Oh man, no, but close enough. We could go with that.
Dude, it's echoing again. Rest in pieces, man.
Yeah, I hear all you echoing. Is that what happens when the feds have it on a back recording and they forgot to turn the mic off?
I don't know. I thought it was me, and I kept trying to fix it, so I restarted a couple times, and then it was fine for a while, and then now it's just insane.
It's Elon.
It's unlucky.
Hey, we got to be nice to Elon, man. He shut us down last week.
Dude, it's like a slight echo where it's like not enough to like ruin the stream, but it's enough to where once you notice it, it's like a laugh track. You just start to hate it. You can't unhear it.
Dude, is your CERN physicist bestie gonna come in and talk to us about the two different ways in which his
I'm talking about some asymmetrical diagram, lad.
Yeah, and also the relativistic correction math comes out to negligible number, lad. Yeah.
Negligible number, lad. That sounds like a superhero.
2 10 millionths of an arc second, lad.
Yeah, so you never know.
I have a feeling he's not wanting to talk much about this one, even though he wrote an 8-page paper of nonsense about it.
Well, to be fair, I did ask him to write the 8-page paper. I was like, yo, bro, hit us up with the 8-pager. Like, don't threaten me with a good time.
He had the light both bending and not bending at the same time. He's like, it depends which frame you're calculating from, is which whether it bends or not. It's like, bro,
was it really an 8-page paper?
Well, I mean, 8 pages of whatever he typed, but
oh my goodness,
bro. And in the end, the conclusion, I don't know. Alan probably has a pic somewhere. In the conclusion, bro, he draws 2 diagrams, one from the water stationary frame and one from the star stationary frame. And like in one frame, the light just goes straight and lands straight, and the other frame, the light goes at an angle and gets refracted and changes angle. And it's like, you're trying to say it's just a matter of perspective from which frame you want to calculate. No, dog. There's only one objective reality. Like, only one thing happens in real life. You don't have something, you can't have the light both simultaneously bending and not bending at the same time. So
Well,
yeah,
why not? It's physics.
You can't even have additional horizontal velocity vectors because otherwise there's no aberration in air either. Like, it's so ass backwards what they've had to do to try and explain this that it's kind of funny.
Call it the Ferg fantasy.
well, also that one, Ferg, is that his name? Ferguson, Fergie, Ferg, whatever.
Fergie Ferg.
Anyway,
Fergalicious.
he
F to the E
tried
to
to
the
say,
R to the G to the...
he tried to say that you are forgetting that when the light enters the water, it's not just its vertical velocity that slows down, but its horizontal velocity too. Dude, if the Earth is the thing that's moving, it's irrelevant, right, that you are slowing, the light velocity in one direction and the other direction down too, because the only thing that matters is how long it takes the light to get to the bottom of the telescope. Because the Earth is the thing that's shifting, not the light. The light doesn't have any, extra velocity component sideways or whatever. The light shoots in a straight line. And when the Earth shifts, the only thing that matters is the amount of time that the light's in transit in the telescope. That's all that matters. So the horizontal velocity, right, slowing down or not, is not going to affect how long it takes the light to get from the top of the telescope to the bottom. And the light doesn't even, it only has a horizontal velocity if you're trying to, map a coordinate system in which it's moving at like an angle. But either way, it doesn't affect the time from top to bottom of the telescope. So his whole explanation is super silly. He's treating it as if the light is the thing that's moving, right? As if the light is like coming in sideways and getting slowed down sideways. And so you have to think of it like that, but that would mean that he's doing it inside of a stationary Earth system. So I don't even think he really realizes.
You know what's hilarious? Did you guys think that light is like a bullet shot from a rifle, a single photon? You guys are unbelievable in the way you think about basic things in physics. You've never like.
No, we specifically don't think that. We specifically don't think that.
Yeah. So if the way you reason suggests that two people on two different locations on Earth wouldn't be able to see a star because the star somehow knows that you're there and shoots you just for you, just a little photon for that location in space that you receive. You literally last week said that it's like rifle shooting bullets. I mean, it's unbelievable.
Except for when
This
it
is
comes back from
basic
the
stuff.
moon, Alan.
Yeah, this is
Except when they
basic
get
stuff.
that one photon back from the moon.
The fact that a light source shoots photons 360 degrees in every direction, and you receive the photon that follows the path of least time, like you have never thought through this. It's continue.
It's very nice to be told, so vehemently and authoritatively by another human being what we have and have not ever thought of. I did not know that.
Well, this is the fun of listening to you.
First of all, Peter.
Hey,
do not interrupt when he's talking. And second of all, it's a straw man of our position. We've never taken that position. The ballistic theory is actually your guys' theory. We don't believe in photons or ballistic quantized energy chunks. That's a you guys' position. So anyway, continue on, Pizio.
Please refrain from interrupting. Wait till he responds and he'll pass the mic back. Go ahead, Pizio.
No worries. So I'm getting ready to post in here the relevant math for our buddy Peter here. But I was going to say it's so nice to be told, what we haven't ever thought of, as if this man has some type of omniscient scrying mirror that he can look into the minds of everyone in this room. Peter, the mathematics for stellar aberration to this day in the modern 2024 scientific consensus model dictate that the angle, the tangent theta, equals V over C. That is how you get the angle of stellar aberration. There's only two variables. One is Earth's velocity, and the other is the starlight and the telescope velocity.
It's translational V. Just for clarification. Sorry, Pizzo. Translational V over C. Yeah.
Correct. Which at zenith it would be horizontal. But anyways, when you change either the V or the C, the angle changes. Since we can't just make the Earth stop in your model, we can't just say, hey, Earth, will you slow down for us so we can do an experiment? Since we can't do that, the only variable you can manipulate is the C. So when your homie puts water in the telescope and it slows down to 75% of its normal speed, 3/4 of the normal speed, that angle should change to 4/3 of the normal angle. Well, homie did put water in the telescope, and guess what, Peter? The angle did not change. There is no explanation in your paradigm for this. It just doesn't exist. I mean, if you have an explanation, I'd love to hear it, but I'm going to go ahead and post the math here in the jumbo for you. Heliocentrism is dead, bro. Water in a telescope, just like Newton's bucket, water in a bucket.
Yeah, so Pete, you could speak to that, or you can give your own interpretation of what he said in regards to Airy's failure in this telescope aberration and filling the telescope with water. He responds.
Yeah, I would love to. Yeah, I would love to. So first of all, I don't have to strum at anything. Every day, every time you open your mouth, you invite me on a trip inside of your brain, and that's just, it's precious. Secondly, here heliocentrism died around the time Galileo discovered relative motion. It just took a few hundred years for Einstein to connect the dots together, but that's okay. Nobody is heliocentric today, but you guys. You guys are like the only heliocentrists.
No, Adam, you focus on answering the question, Pete.
Heliocentric is an ad-hom. You guys are the only heliocentrists out there. So carry the torch. Carry the torch of heliocentrism.
Focusing on the person and not the actual argument.
That's it. That's all I have to say. That's all.
This
is not an argument.
Well, you didn't address what he said. We're talking about the actual experiment, and all you did was
nothing to address.
You're hot, Mike and Pizio.
Oh, sorry.
What do you mean there's nothing to address? You didn't hear anything that he said? Steelman, what he said.
This is not a discussion about science. This is a discussion about cognitive limitations. So it has to be personal.
Received. Steelman, what he said.
I will not.
Why not?
Because it's too silly.
So it's
inconsistent.
So you're in a room with a bunch of people you think are idiots, and you don't want to engage intellectually. You just want to talk trash and run.
Okay, I'll engage intellectually. Stellar aberration. I'm steelmanning based on what I heard last week or 2 weeks ago, maybe.
About what you heard just now.
It's hard to tell. Yeah. So stellar aberration is like when you run into rain, the Earth is moving. It's going to come at you at an angle, correct?
Okay.
Yeah, I heard you say that 2 weeks ago, or one of you, so I know it's correct. Well, same thing happens when the rain moves and you're not running. There you go. That's the Steelman.
Okay. Now, what happens when we slow the rain down?
In what sense?
Well,
you still wouldn't be able to tell if you're running slower or the wind is blowing the rain slower.
Okay. So check it out.
Okay. Relative motion. 1600s.
Yeah.
Please don't interrupt, Peter.
It's difficult for him. So, if you have this tube, let's call the tube a telescope. We'll just name this tube. We'll call it a telescope. Don't worry about what a telescope is. Just think of it like a tube. Okay. When you drop your raindrop, let's change the raindrop to a marble, something that can actually go through water, right? So when we drop the marble into the telescope, into the tube, let's say the tube is moving, right? Tube is pointed straight up at the sky, okay? I'm sliding this tube across the table, and I'm going to time it. I want to time it perfectly so that I'm going to drop the marble a little bit ahead of the tube, but by the time the tube arrives, right, that marble's gonna land straight in the center of the tube, okay? Land straight in the center. Now I'm gonna do it again, right? But I'm gonna fill the tube with water first so that it slows the marble down while the tube is sliding. Now it's gonna take that tube or that marble longer to get to the bottom of the tube, so that tube has that much more time to slide out from under the marble. You think that marble's still going to land in the same spot it would have in the beginning with a higher speed?
Can I respond now? All right, because you ended with a question mark. This is precious what you just said. So you're still imagining that you're dropping a marble instead of thinking that there's millions of marbles falling into the tube, dispersed, not following the same path, millions. And because of the motion or whatever you're doing, you're just going to catch a different marble. You're still thinking it's a single marble, that the star loves you, and she sent you a one precious marble of light. It doesn't even matter if it's a particle or not. One precious little ping, little laser shot, you imagine the star sent you. And because of your movement or whatever, relative movement, you're catching it off. Instead of knowing, if you looked into optics at all, that there's millions, there's different rays of light, if you don't want to think about photons, different rays of light shooting in all directions, whether you're standing on Earth, whether you're standing on Venus, all right? You're still seeing the star. How? Because there's trillions of marbles coming from the star. And you also have never thought through basic Galilean relativity of motion, where you cannot distinguish, unless you know something extra, if you're moving or the other thing is moving relative to you. If all you're doing is looking at the object, you don't know anything about the setup, you don't know anything about other forces at play, you don't know anything. You just have an observation, an optical observation, that you cannot distinguish which part is moving. It's still beyond your grasp.
Hold on, Pete. What are the two things that would be moving? That's relative to each other.
It doesn't. One thing can be moving, both can be moving. That's the whole point.
What is it? What is it? What is it exactly? What are the two things?
You do not know what is moving.
What though? Is it the light relative to the Earth?
There is no way to determine which of the two objects, the star or the Earth, is moving in relation to one another if all you're doing is observing optically. There's no way.
So what you're saying is no way to know that when the light hits the water and slows down, we don't know if it's the light slowing down or some reason the water is causing the Earth to slow down, because those are the two relative motions. You're saying that when the light hits the water and slows down while we continue to move due to relative motion, we can't determine that water either causes the light to slow down or the Earth to slow down in that moment. That's what your position is?
The water is causing the Earth to slow down?
Those are the two relative motions.
First of all, you cannot reason about the light as a single projectile or a single ray, because that's not true.
Answer the question. What are the two things that are moving relative to each other?
I cannot answer the question when you formulate it this way, because it's nonsensical. It's nonsensical.
What are the two things that are moving relative to each other, Pete?
Everything's moving relative to each other.
What are the two things that you're talking about? You said two.
This is what I'm talking about. Everything. You guys believe that there's a single select motion in the world.
Is the light one of them?
Well, let me address that first, okay?
Just say yes or no.
Let me address this first. There's no yes or no.
Never answer questions, y'all.
There is no yes or no. I will address your question. Just let me say two sentences.
I thought I maybe three.
Peter, that's right. My bad. I did jump in. Hold on. I didn't mean to.
Getting excited.
No. I did jump in. I let Piezo finish, and then you could just Peter. My bad, Peter.
I thought he did finish.
No. I think that he had a question for you.
Yeah, I hadn't responded to your original nonsense. Sorry, not to insult you, but you're being very direct right now, so I have to kind of call you out. If you are saying that just because there's more than one photon, we can't treat a calculation for every photon, okay, and if you think that makes a difference for some reason, if you think that, there's trillions of omnidirectional photons flying around, and that's why there's no angle change, and there wouldn't be any angle change in air either, dog. You can't have it both ways. Either there's supposed to be an angle change or there's not. So
dog,
if there is...
Let me explain.
Hold on, dog.
Okay, dog. Go ahead.
So if there is an angle change, right, then you have a basis for using the aberration formula. And if there's not an angle change, then we should always see stars in their true position all the time, and stellar aberration doesn't exist. So you have to pick a position first,
I will.
stick with it, and then address it within the context of one of those two positions. So either A, whether it's one photon or many, doesn't matter because it's still about the relative velocities, or B, none of it matters, stellar aberration doesn't exist.
Okay, cool. So I will address it, dog. So let's forget about relativity and all that nonsense. Okay, let's just use primitive intuitive logic. If I were standing far away from you, let's say I'm the star, and I shot a single ray of light, let's say a photon, just indulge me for a second that it's a projectile, right, of light. And I shot it at where your location was at that time. And we're going to assume, ignore relativity. And I targeted at you and I shot it. And then while the photon is flying, you moved to the side. All right, you moved. You know what would happen? You would not see me at all. You would not receive the photon because the photon would fall at a location where you're no longer there. So tube or no tube, dog, you would not receive the photon, you wouldn't see the star, if that's how light worked. Now, if I sprayed, I'm almost there, if I sprayed a whole bunch of photons like a shotgun, 360, in a big cone, let's say, in your direction, then when you move, the other photon will reach you, not the one that was in a straight line before you moved, but another photon adjacent to it is going to hit your tube, and that's why you're going to perceive me as being at a different location than I was geometrically when I shot those photons. This is the mistake. This is the number one mistake you guys make. You don't realize that you just see a different photon than you would see if you were not moving. Okay? Now, the second thing you guys don't understand has nothing to do with Einsteinian relativity, we're talking basics here, is that exactly the same thing would happen if I were moving and I shot the photon at a different point in time, basically. So you can't, but the photon that you would receive while I'm moving would be the one from a different position if I were shooting single photons, like you're saying. So you're, this is beyond just, it's not a shame that you don't understand any of this, because these are things that require some thinking. Okay?
Hold on, one second.
No, I'm almost done. No, don't interrupt, dog.
Yeah, please.
So what is a shame? What is a shame?
Listen, Peter, if you're gonna gaslight or make comments like that, don't waste our time, because we have actual rebuttals to what you're saying, and it takes a lot of time for you to get through that. So it would be beneficial.
I'm almost done.
Let's just hard cap assume that for the future of the conversation, we're retarded, we don't know what we're talking about, and we're uneducated. And that'll save time moving forward. So if that was the end, so if the multi-directional photon was the end of your argument, then we can move forward. Then we can move forward. If there's additional argumentation, please put it forward. Go ahead.
Yes, there's one more statement, dog, that I'd like to make. So I struggle with many things in physics. It's I do have my own cognitive limitations, and I'm often humbled by realizing how I misunderstood something at a certain foundational level. However, what I do not do, I'm talking about myself, is use my limited knowledge to debunk the knowledge of humankind, because I'm not delusional. Thank you.
Okay, so there's a lot to unpack there, but I'm going to try. So first of all, you started by kind of muddying the waters and trying to make it as if we didn't understand the difference between kinematics and dynamics, and stating a moot point that you wouldn't be able to know which one was moving because all you have is relative motion without introducing something else, without having something else if all you have is the two objects. Well, we do have something else. It's called water. That's what the water's for, to introduce that dynamic asymmetry into the system, right? You got water on one end of the system, but not on the other. So, relative to the midpoint, there's an asymmetry there introduced. But the other thing, right? Your position, because I asked you, I said there's two points you can make. There's two positions you can take, and you said you were going to answer it, and you didn't. But I mean, technically, you answered it by way of what you said. So just to be clear, from your position, there would be no aberration, right? Since you say all you're doing is catching the next photon in the stream from behind it, so you're still seeing the same thing. It's just you think it's in a different position because you moved. Well, if that was the case, then stellar aberration wouldn't even exist. We wouldn't even be talking about this right now. So that's not really a defensible position either. Also, that is not the steel man of anything in any consensus paradigm related to stellar aberration or Airy's experiment. That's just something that you made up, to be clear for everyone who's listening. And maybe that makes sense to you, but it doesn't. I posted it in the Jumbotron. Please go look at it if you haven't. It's from 12 minutes ago. I tagged you in it just to make sure you'd see it. But for everyone else who's listening, there's 4 pictures in the Jumbotron breaking down the math, both with the classic formula and then with the relativistic correction added. Okay. This is the formula for stellar aberration, which is what I brought up in the beginning. You didn't address this at all. You just kind of talked in a circle about your many photons theory. And, like I said, if that's your explanation, then stellar aberration wouldn't even exist. You wouldn't have an angle change at all. It would just always be where it is. But this formula shows, as I was saying, that the aberration angle is based on the ratio of the velocity of the two objects. In this case, the velocity of the Earth and the velocity of the light inside the telescope. And it's based on a time of flight principle. So the velocity equals distance over time. So the distance covered by the Earth in the time it takes for the photon to travel through the telescope will be greater if the water is slowing it down. Since the distance is greater, the angle would be greater. That's the prediction of the math. And then the same thing happens in the relativistic formula, and the relativistic and classical calculations only differ by 2 10 millionths of 1 arc second, which isn't even a real number. It's zero. It's a zero difference. They're exactly the same. So there should have been, roughly a 7 to 8 arc second change in the position of the star once water was introduced. It did not change. It was like less than 1 arc second if you count it as anything at all. So there is no answer in your model for an Earth that's moving. However, in our model, since the Earth is stationary, the light's already coming in at that angle because that light's actually being fired from a star that's up in the sky, and so it's already in flight. It can't be changed once it's in flight, except by the ether wind, of course. And it's already blowing in to the telescope at that angle. So when you introduce water, right, all you're doing is increasing the time it takes for the light to move through the tube. But since the tube's not changing its position, the light's always going to land in the same spot in the bottom anyway. So the two outcomes are dynamically different if the telescope's moving and if it's not. You are able to tell a difference because of the water. So that's our position.
Is that it? Was that it, dog? Okay, so from this,
yeah, homie,
I pick 2 things that I want to address respectfully, dog. Number 1, it is absurd to suggest that.
Hey, Pete, real quick. 2 minutes because I do want to get to the hands.
Okay.
And then we'll double back to this.
30 seconds. First of all, it is hilarious to suggest that water is introduced as some kind of third reference point because the water moves with the tube. So the joke's on you. 2, it is incorrect for you to say that I said there is no stellar aberration. By the way, even per your own logic, the only reason why we know there's stellar aberration is because we change our relative motion through the year. We move in 2 opposite directions. Whatever is moving, the Earth or the star, through the year, it changes directions. It is trivial to understand that if the motion was constant, you wouldn't know there's an aberration because how would you know what the true position of the star is? How would you know if all you're receiving is light at a constant angle due to constant velocity that's not changing. The vector is not changing. How would you know the true location of the star? Is there an almanac that God gave you that tells you where the star is geometrically and you're comparing it against your measurement and you're detecting aberration? You expose yourself in your own diatribe. You expose the fact you don't even understand that stellar aberration is only observed as a comparison through the year between observed positions of the star. Do you not understand this? How would you otherwise know the true position? Tell me this. I'll stop my rant. If you could please tell me if one of the objects, the star or the Earth, moved with a constant velocity vector that's not changing direction, how would an observer be able to identify aberration versus what reference? Thank you.
Okay, I gotta answer this real quick, Sacred.
No. He asked you a question, so I'm gonna let you answer, and then we'll go to Taylor, and then we'll go to.
All right. So, what's funny is I think it's interesting that he actually did bring up some good points. It's actually points that we bring up. So, first off, we are actually already granting you guys a lot when we talk about the quote unquote true position of the star. In order to even engage in this conversation whatsoever, one has to grant the true position to begin with. Otherwise, what are we referencing? Right. So, but that's a separate conversation. Yeah, no,
Please don't.
I'm getting to that. I know. But the true positions are said to be calculated based on the first cusp of Aries on the equinox. They take the positions of the stars, and then they're able to measure it throughout the year and then it comes back around, of course, and see its relative change. Right. This is plotted in an astronomical almanac, which is recorded for posterity, and then everyone in the world is able to reference it. Now, Airy did take his measurements throughout the year. If you go read the paper, you'll see that he takes his measurements and averages them throughout an entire year, and also references them with respect to the almanac that we're talking about. And he finds that when water is introduced, it does not change the angle. And it should, because the angle can be predicted based on the aberration formula, based on the relative velocities of the Earth
Hey,
and
Pizzo.
the light in the telescope.
One
So
sec
it's
there,
still the same
Pizzo.
position.
One sec there, Pizzo. No, in the 4-pager where Airy uses his water telescope and conducts this experiment, he does not take measurements for 6 months or all year or anything of the sort. He takes measurements for about a week span of time at each equinox in a single year. That's what the 4-pager is about. Those are the only times he took measurements for this experiment with his telescope.
Yeah, February 28th, March.
No, not February, March 20th.
I'm reading the dates off the page right now. It's February 28th, March 1, 3, 4, 16, 17, 21, basically through the 27th, and then August 29th, all the way through September, and then up through October the 6th.
Right.
So he's got
all the way
about
to March 27th. So he was
a couple weeks before the equinox.
A week after the equinox, a couple weeks before the equinox, and a week after the equinox. That's what he did each time. Not 6 months during. You know what I'm saying? It's
okay.
Not
it's
quite.
not every day for a year. That's not okay. Yeah.
it's
Thanks for the
not
correction.
any of that. That's just what I wanted to point out. Me too. It's only a 4-pager, man. But just saying, the focus here is at the equinox. This is what the whole point is about.
Right. Well, I mean, that's how the first cusp of Aries is measured, but that's what he's comparing to because that's where the nautical almanac of the skies derive from. Anyway, he didn't just take his measurement at one point in time. He took it and averaged it at different points in time in the year with proximity to the equinoxes. But anyways, that being said, the point being that he's still referencing what everybody references. If you even believe in true positions of a star, which you kind of have to in your position, otherwise astronomy doesn't even mean anything, that there should be an aberration angle in air, and there should be another aberration in angle once we introduce water, because the second component of the equation, the velocity of the light traveling, has changed. we know, based on your paradigm, that that formula is said to be true, because stellar aberration for a zenith position is about 20.4 arc seconds, and that matches the velocity of the Earth that it's said to be over the velocity of light. So once we change the velocity of light, Peter, as in this post, that I'm sure once we get to the hands, you'll have time to look through it. It's in the jumbo. It's the most recent one. You're tagged. Look at the math. You can see that the arc second angle would have to change from 20 point something to 27 point something. And that's with both relativity and classical. Talk about the math, because there is a calculation, and unless you can answer the calculation, you don't really have a position. That's it.
Nice. So look, I want to go to Taylor, but I think Proud wanted to chime in. Proud, did you want to say something?
Yeah, I actually just wanted to ask Peter something for clarity. I think he can hear. You hear me, right, Peter?
Yeah, I can.
Okay, cool. So you're saying that we're treating the light in the telescope as a single proton, one marble. But, for clarity, would you want us to, like, imagine the phenomena as light being, like, coming in from all angles, basically? Light is omnipresent. The light through the telescope, we're viewing the phenomena as light coming through the telescope at all angles. And if so, if we're supposed to view it like that instead of like the single photon, does that change the claim of light being parallel?
No, that's a different thing that I'm describing. So, with parallel or not parallel, one thing is true. When a source of light, unless it's a device such as a laser, when it emits light in all directions. So you need to think about light as a kind of a cone approaching you. What is often misunderstood when we talk about refraction, Snell's law, whatever, stellar aberration, is that when you introduce a medium or motion, it's not like you're running away from a specific piece of light. Yes, you are. Like, if you were not moving, you would catch one photon. If you're moving, you're going to catch a different photon because the source is emitting a cone of light. If the source was a very focused beam and I pointed it at a location and you were moving, you would never see that beam. It would never enter your telescope because your telescope would have moved. So every time you introduce something that, let's say, messes with your intuition of like a straight line, light being a straight line, that thing just means you're going to get a different portion of the light than you would otherwise. Like, think about it. Why is a person on another continent being able to see the same star? Clearly, they are at a different location than you. Stars don't send personal photons meant just for you. They don't even know you exist. They blast these things into space, and you're going to catch the one that you're going to catch. And for this very reason, if there was no change through the year in the relative motion between us and the star, I'm not even arguing the Earth is orbiting or not. Here's what we know. If the only reasoning you do is, I observe a star through the year, I know nothing about the Earth. I'm observing the star. One portion of the year, it's at one angle. Another portion of the year, it's at a different angle. That's interesting. The second thing that is interesting is the periodicity of this phenomenon, meaning if I do this over 2 years, 3 years, I see that this angle changes, fluctuates between these two values through the year. So there must be a certain regularity. Either I am moving in somewhat of a circle, or maybe the star is moving in a circle. But you see this periodicity, you know there's a change in the vector of the relative motion. Otherwise, you wouldn't know. What he just described as the true location of a star, that's not the true geometric location. It's the light that we catch. The star is always even in your own model, if the star is moving, which it is moving also in our model, everything's moving, There is not a single true location. What we
Okay.
are doing is we're measuring changes to apparent position to a certain degree of accuracy. If we were infinitely precise, the star would never be in the same position. Because per your own model, it's moving, it's wobbling, it's doing God knows what.
Peter.
Oh, 1 second, Piezo. I did
I'll
want
take that as a compliment.
I did want Joe to jump in. Can you hold that thought just for 1 second? I know you want to get to it, but Joseph was a patient. Joseph, did you want to chime in real quick?
Yeah, not anymore. I've got no desire to. Okay,
Suck the life right out of you, did he?
Understand,
No worries, dude.
Don't worry, it happens, dog. It happens.
I'll address the foundation of it all, though. Like what I was thinking was his foundation in the very beginning is so flawed. It's not even funny. He basically, if I heard him correctly, he said we can't tell what's moving. But then you're going to tell me the Earth is moving. That's a really odd position, my man.
I would not tell you this based on just this observation. I stated it very clearly. If the only thing we were doing is observing this change in position, apparent position of the star, we would never be able to tell if we're moving, if it's moving. I didn't even mention gravity. I didn't even mention the sun. I didn't even mention orbits. If you deny yourself...
claim, though, Pete, but a positive claim is that
there isn't actually.
The motion of the Earth is causing aberration. That's not one of your arguments.
Okay. That wouldn't be precise. No astrophysicist would tell you that the only thing that's moving in that system is the Earth.
Trust me, you're not an astrophysicist, but I'm gonna ask Franco. He right here. I'm gonna ask him. Go ahead. I'm listening.
Okay, I'm gonna ask Franco.
Matter of fact, Joe, were you done? I don't know if you were done.
Well, why don't I ask? Let's have some Glover on Glover violence. You guys will love this. Franco, in your understanding, is there any physicist in the world who would suggest that the Earth is moving and any star that we look at is not moving?
Hold on.
Hey, real quick before we get to that though. Pizio, you had something that you wanted to say before we moved on after the explanation that was given to Proud, which is just a reiteration of not addressing the fact that if there's omnidirectional photons that you're just going to come into, you wouldn't have aberration to begin with. Because like that is the key pivotal thing here that's not being addressed, and to like ignore that and then just repeat yourself isn't like, that's not an answer. That's why we're introducing the water. That was the whole purpose of it. This was supposed to be stellar aberration was supposed to be a mutually exclusive proof of heliocentrism. But then they started.
How about we worry about water later?
Nah, man. We're literally Peter right now. No. Peter, if you can't get past this, then there's nothing really to discuss. It can't get any simpler than starlight, a zenith telescope, and water. Like if we can't get past that, bro, then like maybe you should, I don't know, do something else with your time.
Well, maybe there is something simpler. How about relative motion per Galileo? That's way simpler.
No,
and you don't get
Peter,
it, so there's no point discussing further.
You're changing it to a completely different topic. You're just going in a circle, repeating yourself about stuff that we already know, everyone agrees on. If all you have is relative motion and two observers and nothing in the system that's an asymmetry that you can reference, no, you can't tell what's moving. That's why you pour the water in the telescope, my brother, because that slows the light down, and then one of the two variables in your equation changes. Namely, the c velocity becomes 0.75 c, and then your tangent theta angle has to increase. But that's not what happened when Airy poured water in his telescope. It didn't change. And you can't address that, and you won't address that because you know that there's no answer. So all you do is obfuscate in a giant circle and try to hog all the mic time until everyone's so confused and tired they don't want to talk to you anymore.
Maybe you should consider that Mr. Airy understood relativity of motion and you don't.
What kind of answer is that, dude? You guys always say
you should consider that maybe
I'm
you're
talking now.
misunderstanding something
You guys always say, oh, You, dude, you have no math to back up what you're saying. We've got the relativistic calculations for the differences between the two. We've done everything possible. We've got Snell's. We've read all the papers. We've read the follow-up papers. We're trying to discuss water in a telescope, and all you can do is gaslight and obfuscate, Peter.
Well, if me telling you the honest truth, dog to dog, is offending you and gaslighting you, then I cannot help you.
No, you're just not.
You haven't given a substantive answer to what's being discussed. What
Not a
you
single
said
question.
Because you're building your position on the entire pile of misunderstandings and hilarious misconceptions.
You can't answer one question.
Your position, you're arguing it incoherently. You're arguing that you believe in stellar aberration, but you're also believing that the light comes in omnidirectionally and that you're going to just move into the other photon that will replace it. Then you wouldn't have stellar aberration. So you can't have both.
Yes, you would.
No.
Yes, you would, because the photon is a different path, a different line from the source to you, of course.
Nope.
See, you don't even get this. This is not even about cosmology. You don't even understand that an object emits light in all directions, and if you're in a different position, you perceive it at a different angle because you received a different photon.
Pause. We need to okay, you've said this like 4 times. Let's address it so you don't keep bringing it up. The way that they measured this, Peter, right? Each star has its own angular size, just like the sun does. The sun is about half a degree. A star is tiny, though, by comparison, like really, really tiny. They took a crisscross shaped micrometer slit where they were able to measure down to the millionths of a degree, right? They had slits in there that you had to look through a telescope basically to see the slits, okay? And they were able to measure the leftmost boundary and the rightmost boundary of the star each time they took a measurement. And then they would reference the center point as the point of the location. So once you move, right, it doesn't matter whether you think that you're seeing the star from here, here. You have the full picture of the star measured from both boundaries and the position taken at the center each time. And then they would rotate the telescope 180 degrees and retake the measurement just to make sure it agreed and didn't change. And then they'd write their results down. He goes through this methodology in his paper. And there's a Royal Observatory documentation showing the telescope and the methodology of the apparatus as well. It's all in Alan's presentation, and it's on his website and his Obsidian database that I linked to you. You can see all of this. So your argument about omnidirectional and seeing the change but not realizing it because you've moved, that doesn't make any sense. As Alan said already, if it takes away aberration in water, it would take away aberration in air too. You can't have it both ways. So your argument is literally not a point about anything. You just don't understand the point of Airy's experiment.
Do you understand that you could model aberration by looking at a building and moving laterally in relation to the building and measuring different angles to the building?
Hey Peter, does light slow down in water, yes or no?
Technically it doesn't. It moves with the speed of c between the particles in the water.
All right, I'm glad you said that. I put a video up in the Jumbo you can take a look at. This woman has a laser meter and she has a cup. She shoots it into a cup of air. It gives a distance based on the timing, based off of the speed of light. And when she introduces water, it registers a different distance to the tune of 30%.
Yeah, that's in water.
Stop. Whether or not you believe in if the water or if the light in the water is taking a different path due to the molecular structure and bouncing around due to re-emitting from an interaction with electrons or whatever, either way you dice it, there's still a timing difference that is interpreted as C plus or minus V. So it doesn't matter if you want to say that it's technically this or that, there's still a timing difference, and that is the key pivotal factor here. So is there a timing difference in light when it goes through a medium?
There is, and the reason why you like to talk about the water is because you like to obfuscate the fact that you don't understand the principle behind aberration in the first place.
Okay, stop. Hold on one second. You said yes, and you agreed to the timing difference. Okay, great, fantastic. So now we can introduce a medium to a telescope, which will cause a dynamic asymmetry in the system, right? So now it's not just, oh, we can't tell relative motion. Now there's going to be a timing difference. So as the light's coming in, the Earth's going to be allowed to move further out from underneath it, which is going to create a bigger deviation in the angle. And that's
From
not what
underneath it. You're still thinking a marble, huh?
Nope. Dude, if there's no light, or if it comes in omnidirectional, there's no aberration to begin with. So you don't even know what you believe in. You currently believe in a photon, which is a quantized chunk, which is literally equivalent to a marble. So like you're while trying to.
So is there one photon? Is there one photon flying from the star, one stream of photons, or a cone of photons
Every
hitting
photon would
different
slow
locations?
down. You would slow down every photon, so it doesn't matter.
Right, but you're still thinking there's a marble, there's a single precious piece of light that was sent to you, and
Peter,
you're
we could
running
take
away
a
from it.
photograph. We could take a photograph at an instant in time. Okay, it'll show the same thing. When we
What would really help you guys if you considered
Peter,
this whole aberration
please
thing
do not
outside
interrupt.
of the context of the Earth?
Peter, please do not interrupt.
Yeah, he's just going to go on and ramble.
The thing that you've been doing the entire time, talking more than anybody. When you take this position where you have acknowledged, yes, there's a timing difference. It takes longer for the light to get through the water. And then you also say, yes, the Earth is moving, right? The fact that the Earth is moving out from the light is the cause of aberration in the first place. If you deny that, then you don't believe in aberration. That is the mainstream position. Literally, the cause of aberration is because during the time it takes for the light to reach the eyepiece in the telescope, the Earth shifts out from under the light stream based on the amount of time.
So then you should see no light.
No, Peter, it doesn't shift enough to take it completely out. Light moves really, really fast. Light moves really fast. It only shifts by a matter of arc seconds.
How about the guy that's standing 50 feet to my left? He's not seeing the star, right? Because the photon didn't hit it.
Peter, we're talking about a fraction of a fraction of a fraction of a second.
So what if I have two telescopes, 50 feet apart?
Hold on, brother. The cause, this is in your paradigm, and I know you're not going to disagree with this, why you keep trying to obfuscate. In your paradigm, the cause of aberration is the motion of the Earth moving out from under the stream of light during the time of flight.
No.
If you alter,
that's just wrong.
Then why is the velocity of the Earth even a variable in the equation, Peter?
So first of all, there are two problems
Peter,
with the
Peter.
Well,
I'm not.
You're strawmanning me. Strawman fallacy.
I'm not
oh my God.
strawmanning you.
What kind of space is this when you guys allow strawmanning?
Oh my gosh. Every single person in this space has access to a keyboard and a mouse right now and can literally type, what is the cause of stellar aberration? Pick your favorite search engine. Pick your favorite physics textbook. Pick your favorite source of mainstream authority. They will all tell you it's due to the motion of the Earth, Peter. You are simply wrong if you deny that.
Okay, can I present my case?
Now, hold on.
I will deny it because I'm a truth seeker. I'm a critical
interrupted
thinker.
me so many times.
Appeal to authority.
You're making a 30-second clip take 5 minutes. Just hold on for a second.
Appeal to authority.
Anyways, during this time of flight, right, however much time the Earth has to move, the further it gets to move and the bigger the angle. You already acknowledged that there would be a timing difference. Because of the water, the time will be greater to reach the end of the telescope. Since the time is greater, the distance traveled by the Earth is greater, therefore the angle must be greater. That is that simple. It is the simplest logic you can get in this situation, but the only problem for you is that's not what was observed. You know what? If Airy had observed the angle change, like the math dictates, you would totally be taking that position right now and be like, oh yeah, perfectly matches, stellar aberration, proof of heliocentrism, blah, 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 blah. That's exactly what you would be saying. But because that's not what happened, you have to take this nonsensical position, throw in a bunch of non sequiturs and rabbit trail everyone for an hour.
Okay, so now I present my position. Okay, cool. So first of all, it is not. You're presenting a fifth grade level of explanation of stellar aberration. If you were going to get precise, no physicist would ever say the Earth is moving, nothing else is moving. Everything's moving. So the star is moving, the Earth is moving. There are different degrees to which these things matter, but technically everything is moving. So strike one, Bullshit. Nobody says, oh, just because the Earth is moving. Second of all, this whole
Actually,
premise
Peter,
of like,
it's the
this whole
wiki
premise,
definition.
yeah,
It's in
sure,
your
sure.
favor. Look up
I'm a critical
Wikipedia, just
thinker.
type
Appeal to
aberration, and
authority.
read the first 3
Appeal to authority.
sentences.
Appeal
No,
to
you
authority.
just
Yo,
you
dude, you got
just said
30
it,
seconds.
dumbass.
Wikipedia's not a
Hold on,
source.
hold on.
Wikipedia's not a source.
Hold on. Peter, you got 30 seconds, and I do want to hear from Franco because he actually does have a credential, so we want to actually hear what they're saying in mainstream science. So you got 30 seconds, Peter.
Sounds good. More than I need. The second thing you're constantly repeating is we are running away from underneath the photons. That is absurd. If that were true, then 2 telescopes 50 feet apart, one would see a star, the other one wouldn't. Because, oh my God, it didn't catch the magical photon that the star sends that you must catch. This is like, just think about it. There's a cone of light, and if you're here, you're going to catch, you're going to catch one ray. If you're 50 feet away, you're going to catch another ray. That's why you see things at a different angle. Dummy. You don't have to move. You can just.
Thank you.
I wanted
And
Peter. I don't know why he fucked up for himself. I wanted him to ask Franco the question that he had for him.
yeah, that's what I was gonna get to.
Okay, the question to Franco is this. Franco, in your professional knowledge, is there any physicist in this world that would suggest that the Earth is moving and the star is not moving, or vice versa, as opposed to say everything is moving?
That's not what we want you to ask him. We want you to ask him if the Earth's motion is causing aberration.
Every motion is causing aberration. The Earth motion is the one that we can recognize the most because it's periodic and and that the star, relatively speaking, is not moving, or not moving much, not moving enough to affect our measurements if we do them like close to one another.
That was totally unintelligible.
Man, rest in pieces, dude.
Dude, I mean, I put it in the jumbo for you, straight off Wikipedia. I really don't know what more to say.
They scared to claim motion now, y'all.
Dude, this is like when Shane went to a debate over maps, and dude was like, "We've never claimed that maps prove the shape of the Earth. That's absurd." You guys in the okay? So stop, please. Peter? You're kind of like done here. Like you don't have to chime in anymore, dude. And then dude's like, "Oh yeah, it's proof, but it's also simultaneously not proof." Nice, dude. Well-rounded position.
Franco, let's ask you this question instead. How about this? In Airy's failure, is it accepted mainstream science that Earth's motion is causing aberration? And then you got the floor to say what you want us to say.
It is Earth's motion with respect to the star. Yes, with respect to the with respect to the star, relative motion. If I can say something, but what I wanted to say is, please, as I made some calculations. I showed the math, irrespective of what Airy says, what Wikipedia says, etc. I did my own calculations based on what I know and what I think is the current understanding of how light propagates and how you change that when changing frames of reference. And in my calculations, everything is perfectly compatible with what I think was measured, meaning that the angle didn't change when you tilted the telescope. And the difference with respect to what Piazza says, and I sent the slides to him as well, but he hasn't responded yet, is that the formula that he's quoting always is not the right one, because this formula with composition of velocities predicting that when you change the medium, the velocity, the angle, when you increase the refraction index, then the angle increases, is not right, because if you do it with wave propagation in a medium, then what you observe when you transform properly is that what is expected is that the angle is reduced by a factor equal to the refraction index. And the calculations are shown in my slides, and the calculations show that it's exactly they exactly lead to Snell's law in both this is for a limit where the velocity is small and the angles are small, that Snell's law is obeyed in both frames, both the frame where the star is not moving and the Earth is, and the telescope is, and in the frame where the telescope is stationary. They both obey Snell's law, which is precisely what is expected in physics, because the two frames are not distinguishable, meaning the telescope does not know what originates the light. The telescope just sees light coming from one direction, and then it reacts according to Snell's law. You don't know where the light does not have a label on it saying I'm coming from this or that. It just arrives and then it bends according to Snell's law. So if it's coming perpendicularly to the water surface, it will not be deflected. That's in the calculations. So please object to the calculations specifically.
Yeah, so I put a link in the jumbo to where the calculations were addressed, and you have your diagram shows two different outcomes, and it's not symmetrical. And like we were saying earlier, if you try to add a horizontal velocity component to a photon during transformation, but still keep the Earth in motion to predict that there's no angle change, you're going to have no, like that, you would have to apply the same thing in air and there would be no aberration then. So you have an asymmetrical use of Lorentz symmetry, which is, not valid. So your relativistic application isn't valid. And then the diagrams you drew are two different outcomes. So those are two different frames that are easily distinguishable. One gives the angle that would be caused when you change, and the other one would be caused, if there's no motion. So those look super distinguishable, and we use the proper special relativity application, not a West Coast custom build that you came up with yourself to try and make this work out. And even in doing so, you violated Lorentz symmetry.
No, sorry. What did I violate? As I said, when you answered this in a comment, I said, please don't just say things and highlighting things. Please be specific.
Yeah,
where did I go?
I got you.
Tell me which equation is wrong. Which equation is wrong? And
okay, when you make the Earth stationary and you transpose the velocity of the Earth to the horizontal component of the photon, you're also, because if you're making this predict that there's no angle change. Well, dynamically, you have to keep the motion of the Earth to do that. So you're not doing a symmetrical transformation that's meaningful. You're just role playing. You're just playing fuck around to be short.
Sorry, which equation are you talking about?
The equation that you used to explain the transformation of the velocity of the Earth to the velocity of the photon. It's in the diagram. Oh, shoot. And what slide is that? 1 second. It's in the second slide down. The one that it says not symmetrical, and it has two different outcomes at the bottom.
Yeah, I don't understand the objection, because that's should we go through all the equations one by one?
Yeah,
because that's what one does. Yeah.
No,
So
Franco.
Yeah.
Really quickly, specifically on that page, do you see the picture he's talking about where it says not symmetrical?
I'm looking at my own slides now.
It's right at the top.
Remember,
Franco, it's right at the top. It's posted to the nest. It says, "See ya Friday." If you look up at the tweet up at the top, all the way to the left. Posted by Alan. Shared by Alan.
I remember. I have to find them, but
it's in the purple pill right now at the top of the chat.
Check your noties.
Check them noties. I like it, Sacred.
Oh, I can't find it on my computer, but okay. But I remember. Yeah, it's my
Starts with
fourth side or
it
something.
starts with equation 7 on it, where it says "and in water always from equation 7." That's what we're looking at.
Yeah, when it says theta 1 equals minus beta and sine theta 2 equals minus beta over n. Is that what? Is that one?
Yeah. So you have the aberration you have the aberration angle in vacuum, right?
Yeah.
Sine theta
Yeah.
1, and then you have the aberration angle in water, sine theta 2.
Sine theta 2. Yeah.
Yeah. So those two, sine theta 1 and sine theta 2, are not equal to each other.
Yeah, because one is in air and the other one is water. It's
correct. That's our position. There should be a different angle in water, and there wasn't.
No, yeah, but then what are the two related by? Snell's law, meaning if the angle in air with respect to the water is theta 1, then theta 2 is the same angle divided by n, which is for small angle is exactly Snell's law. And that's my claim. It obeys Snell's law in both frames.
So 3/4 or 4/3 of the angle, right?
3/4.
Okay. So there would be an angle change from what it was before to 3/4 of what it was before, right?
No, it means it means that
if
you follow the calculations, it means that Snell's law is obeyed in both frames. Now,
can you just answer my question? I mean, you give your explanation. But it is still a binary answer. Either it changes or it doesn't. You said it goes from the standard angle to 3/4 of the angle, right? Once water is introduced.
Yeah, if the water is parallel to the velocity, yes.
Okay. Yeah, and then if it's not parallel, it's going to be some tiny small angle correction. That's
that's explained in the following slide.
Right, but we're treating that as negligible for the general purposes of the standard
it's not
right?
Exactly negligible. It's not exactly negligible because what you do. Right. Okay.
But I'm talking about for the standard angle though, because the relative correction for that tiny non-normal angle of incidence is going to be a separate calculation. It's going to be really small. But
it's the same. Okay, so because it's the same angle we're talking about. Yeah. Okay.
Yeah. So, but this standard angle here though that we're talking about, this page where it says not symmetrical sine theta 1, sine theta 2, that angle though will change because of the introduction of water, right? It'll be one is the standard angle and the other one's 3/4.
These are the sine theta 1 and sine theta 2 are precisely the two angles that one is in air, say, or vacuum, and the other one is in water.
Oh, okay, and they're different angles, right? One is 3/4 of the other.
Yes, and they obey Snell's law. Yeah.
Okay, so then if you're saying that yes, you're agreeing with us, then that means if I introduce water, I should then get a different angle. That's what you're saying.
I'm saying that in water, if light is coming vertically, the picture on the bottom right is light is coming down vertically in a frame where water is moving horizontally. Then in a water's frame where the water is stationary, then you will have an aberration angle for the light in vacuum, which is the orange line, which is coming down at an angle which is theta 1, which is governed by it's the sign of the angle is minus beta, and then you have that in water the angle will be different, different aberration angle, and it will be less. Will be smaller than the angle in vacuum, not bigger, and then they will obey exactly Snell's law. You compute it with a transformation of frames with Lorentz transformation in my case, and then you check that they obey Snell's law, which is very interesting. And that's my prediction. Okay.
So if you're saying that they obey Snell's law, right?
Yeah.
Well, does Snell's law predict the exact same angle in air as it does in water? Yes or no?
No, it obeys Snell's law. The ratio of the two is
okay, Franco. So you're actually agreeing with us without realizing it, and I think maybe there's a disconnect here. See, we're agreeing that the introduction of water, for multiple reasons, you're like, trying to break them down piece by piece. We've done that, but we're speaking in general right now because the conclusion's still the same between what you're saying and what we're saying. When you introduce water, for a variety of reasons, one of them being, the refractive index, the second being the actual time of flight of the light from one end of the telescope to the other due to the water. For both of those reasons, there would be a different angle with the water than there would be without the water. We're both agreeing on that right now. So do you know where our disagreement lies?
Where does it?
Our
Where?
disagreement. Yeah, so
Yeah.
we've established where our agreement is. Our disagreement is in the fact that if we go to test this, we should obviously see that the introduction of that water will produce the required angle change given by this math. But that's our whole point, is when Airy did do this. And when Airy did this, the introduction of the water did not physically produce any angle change. He had the same exact sine theta 2 angle in water as he did the sine theta 1 angle in air. And
So he
that's the
disproved Snell's
problem.
law. He disproves Snell's law, meaning that even his optics will not work because the optics, the lenses, are based on Snell's law. He disproved it? No,
No,
because
he
what he
disproved the
did.
motion of the Earth,
No,
Franco.
no, because what he did, this is in the following slide. What he did is to tilt the telescope
He
such
didn't
that.
tilt it. No, he didn't. He didn't tilt it. It was a zenith mount telescope. It was zenith mounted with two
Okay,
spirit levels. It never left
so he
vertical.
didn't. But okay, so he was in a situation where the theta one angle was 0.
No, the star is not at 90. It's at like 89 degrees, 58 arc minutes, and like 80, 40 arc seconds. It's like 80 arc seconds off of zenith, right? And then this telescope, between 80 and
Is
120.
the telescope vertical or not?
The telescope is vertical, but the star is not perfectly at the zenith. It's slightly off of zenith. So there's a very small
So,
angle.
so if water is perfectly horizontal, meaning that
It
its
is.
proportional to water is vertical, is the zenith,
Yes.
and then the light comes at an angle which is not 0 with respect to the zenith, then it should be refracted with Snell's law. And if it doesn't, he has proven that Snell's law is wrong, which is not the case to my knowledge.
There was a very small angle change between no water and water. It was like less than 1 arc second though. But the required angle change
0.8.
based on the
It's not the required the angles change, because the required angles change is that the predicted is the one from zenith of the star divided by 4/3, meaning 3/4 of that angle, not 4/3 as expected by I don't know who.
Okay, either way, it didn't get there. It didn't get there either way. 4/3 or 3/4, neither one of those happened.
So he proved that the Snell's law is wrong, and
No,
that
he proved that the Earth's not moving.
no, because the prediction I'm talking about has nothing to do with the Earth moving. It's to do with Snell's law. I'm saying that if it's coming down with an arc second with respect to the zenith, it should go in water with an arc second divided by 4/3, meaning 3/4 of an arc second. If it didn't measure this, then it disproves Snell's law, because this is Snell's law. The Earth motion has only determined what theta 1 is. Theta 2 is determined by Snell's law. And if you my calculations show that if you do it with aberration, it predicts exactly the same thing. So we can forget that now we have predicted it using aberration, and we predict it using Snell's law. And if it didn't find this, then it disproves Snell's law.
Well,
which is,
I mean,
to my knowledge, is not disproven.
Yeah, so to be clear though, right, there's another component that you're forgetting. We agree that Snell's law would introduce some angle, right? It wouldn't be 0, it would be some small angle, because even though the star was extremely close to zenith, it was still slightly off. So that's a slight angle. So there should be a slight Snell correction. But there's also the matter of the fact that there's an ether wind. And so as the starlight's going down the telescope, right, it has more time to be traveling down the telescope. As the telescope is vertical and the starlight's moving, it has a longer there's a longer length of the telescope than there is a width. So as it travels down the telescope and it's blown by the ether wind with the differential timing introduced by the water, that ether wind motion will offset the Snell's law refraction angle, and so it will reduce it. But that's what I'm saying. He didn't get a 0. He got like a 0.8. He got a very small number that wasn't 0, but it wasn't anywhere close to what it should have been based on the aberration formula. He treated it as 0. They write it off as basically 0, but it's not. It's kind of the same thing that happened with Michelson Morley, right? They got 6 to 8 kilometers a second, supposed to be 30, but treated it as 0.
Usually there are measurement errors and things like this, but what I wanted to show here is two things. One, that the tangent formula that you're using and quoting every time is not right. It's not the right one. It's the other way around. It should not be the refraction index, but the 1 over the refraction index. And then that when you do the calculation properly of how light propagates, then you find that for small angles you have that when it changes medium from air or vacuum to a different medium, then it obeys Snell's law in both frames, and then you should do the calculations with that. So if the telescope is not tilted and the light is coming at an angle, then it will proceed at a different angle, obeying Snell's law. And if it comes down perpendicularly, so if you've tilted for some reason because you expect an angle, you tilt the telescope in order to match the angle and in order to have it come down normally with respect to the water surface in your frame, in the telescope's frame, then it will not be tilted because the aberrations angle are changed in such a way that they compensate, and then you make the calculations properly. You will see that even if you do it with the aberration angle and then rotate it back, you find that it will stay, it will proceed undeviated in the telescope's frame if you tilt it. If you don't tilt it, it just deviates by a smaller angle, and the smaller angle is dictated by Snell's law. So everything is consistent, and you have the calculations. Sorry, but I think my calculations are correct.
Yeah, but you're saying in the telescope's frame you're saying only Snell's law, right? But you would only have Snell's law if the Earth is stationary. If you're treating the Earth as stationary, and the thing is there, because of the water, the motion of the Earth is dynamically different in the two systems. It wouldn't be symmetrical. The water introduces an asymmetry that would cause one result in one case, but a different result in the other.
Well, ask me, Franco, do you agree with that? Do you agree that the dynamics of the motion of the Earth would not be symmetrical when water is introduced?
I don't understand the claim, really. I don't understand what symmetry people are talking
about. This is what I'm saying, because we explain it and he not really internalizing like what you mean. Even though like the causal claim is that the motion of the Earth under the starlight is causing aberration. So when you introduce water, right, the starlight's quote unquote in your paradigm slows down, causing the motion of the Earth to move under it. So even with your refraction corrections, there's still that one component of the Earth moving under the starlight, and it's taking a longer time for that to happen because the starlight is being impeded through that medium.
This thing that taking longer times is perfectly dealt with by the transformation of reference frames. That's what it is. That's what Peter was talking about.
No, wait. Let me just understand what you're saying. Let me just understand before you go on. You said it's a simple transformation of reference frames. So let me just understand what that means, and then you can correct me, and then I'll let you continue. You mean to say that when you're accounting for how the light moves, you're transforming it from the frame where the light is coming from to within the telescope relative to the telescope frame?
Yeah, you're moving. What I'm doing in the calculations is take a frame where supposedly, say, the star is not moving, and you have light coming from some source in this frame, and the telescope in this frame is moving, and then I'm changed to the frame where the telescope is stationary, and then you see how the light propagation changes, because what you know about how light propagation works in a medium such as water, in a dielectric medium, in a macroscopic medium, you know it when the medium is stationary. It's not obvious how you treat things when the medium is moving. So in order to do that, you have to transform the wave vector the way I did. You can do it.
See, that's the thing. That's the thing, Franco. We agree that when you do that, you can eliminate the problem. But please answer me this in real life. What about the water causes that transformation?
What about the water causes the transformation?
Right, because you introduce water and it's causing a prediction that fails. So you're saying we could transform into the frame where the water is being held and say the light is moving in respect to it in order to remove that failed prediction. What about the water is causing that physical transformation? Because that's the variable. What's that mechanism? Why are you jumping from the frame of the starlight into the telescope just because of water? What about the water is causing that?
I'm sorry, I'm not following. What I'm saying is, we know what happens when you propagate light in. We have a description of what happens when you propagate light in a dielectric medium, macroscopic dielectric medium such as water. But we know how to treat this with Maxwell's equations when the medium is stationary, because that's our model, right? And we know the physics of it. We have a microscopic explanation of it, and so on, within classical electrodynamics. And then when you have when you ask yourself, which is what I did when I was presented with this problem, how do we deal with this when the medium is moving? For instance, this is as I quote in my slides. For instance, this is what happens. A very similar problem, actually the same problem in a different perspective, is what happens in Fizeau's experiment, where you have to deal with propagation of light in moving water. You have light going down a tube or a pipe where water was flowing. This is exactly the same problem. You have moving dielectric macroscopic medium. How does light propagate in this moving medium? The way to do this is to solve for the to go back to the frame where the
stationary. We're stationary, right?
Yeah, because you know how to do.
But look.
Back to the system where the frame where the dielectric is moving, and then you find what to expect.
Right, because it's simpler to solve for it when you just use the frame that's easiest to solve, which is a stationary frame. Although in real life, the frame is moving.
Yes.
When you what causes that mechanism for the water, because that's what's being introduced, for you to be able to transform into a stationary frame, there has to be a mechanism for you to actually make that transformation. And on top of that, why not just do that in the first place? Why not just treat the telescope with the light reference to that quote unquote stationary frame in the first place, as if the Earth was stationary from that stationary frame, therefore no longer needing aberration correction angles. However, there is a correction angle. So you guys need to claim that it's the Earth moving. You see why they're saying, why not just use it in the beginning? Because now you're saying that the Earth is stationary. However, if the Earth is stationary, there wouldn't be no aberration correction angle.
No, I'm sorry.
Why not just treat that in the beginning?
I'm not following. I'm saying you want what I don't know. What
I'm saying, Franco. Why not just treat it like that in the beginning then, as if everything was stationary, as if nothing was moving? If all you have to do
it is because
right. So we could test for that. So when we introduce water, there is no angle change. We say, well, we'll just transform into a stationary frame again, so we don't have to make no correction. So we're saying, well, what's causing that mechanism? You're not saying what's causing that mechanism because of the water.
What mechanism? I'm just transforming because that's
What's
the
your
way
justification for the
Because the
transformation?
light is moving in respect to the frame that's holding the water. That's what you're saying. That frame, as the frame is moving, the light is moving with it in the water. So as it's moving with it, there is no relative motion. It's a stationary frame now, right? The light is moving with the water, and the telescope is moving with it in respect to that frame now. That's what you're claiming. That's now stationary, right?
Not following. Sorry.
What do you mean? What's the stationary frame? The stationary frame is now the moving telescope with the water, but the light that you're saying is moving in respect to that telescope frame that's moving. So you're saying it's stationary. You're transforming it into a stationary frame to explain away the light.
Into a different frame where the telescope is stationary. Yeah.
Right. What's causing the mechanism? Why are you doing that? Why when you introduce water?
Because this is a
transform into it. What's causing it? You're just.
I'm not getting it. You want to know? Let's forget about water. Let's forget about water for a moment. You want to understand why there is aberration in the starlight. The aberration in starlight is due to the relative motion between the star and the Earth and the telescope, right?
Observer
and
motion.
Then you want to see what happens if you change and put a water telescope in and see what happens. The way of proceeding is the way I did it, in my opinion, of course, and I think not only mine, but okay, in my opinion, and to because you know what happens at the interface between two media, vacuum and water, only when in the frame where the medium is stationary. In that way, you know how to treat them, and then you want to see how things change. You go back. You go back and forth from two frames where you know how to treat things, and you see how things change. And my calculations show that it's indeed what is expected, what I expected in the first place, meaning that it doesn't. The interface between two media does not know where the light comes from, whether it comes from at an angle because of aberration or because it was some guy with a laser beam shooting it at an angle. It does not know it. What the medium sees is just light coming at an angle, and it reacts with Snell's law independently of where the light comes from.
Why do you keep on bringing up the sentience of telescopes? What do you mean it does not know?
What does it mean? Sorry, I didn't get the question.
You said it does not know which angle the light is.
It's a figure of speech, of course. Local physics is not dependent of the origin of light. The reaction of if you say it's a locality statement, the reaction of water of a medium at some location is independent of the origin of light that is coming to it. If you want to see it microscopically, you have molecules of water receiving photons from the outside, and does not depend where the photon comes from. If it comes from a very nearby source or a very far source, it just depends on the angle, the frequency, and whatever. It's just a local thing. So
it sounds like you're saying the telescope is dragging the light. Go ahead, Piers, and I want Taylor to jump in.
Okay, so as far as I know, this is an as of yet.
Hey, did you say my name?
Yeah, I was saying right after Piers, I just wanted to close this one out, and then we're gonna go to Taylor.
This is an as of yet undiscovered correlation. I think I just found. Well, I just double checked. I mean, I'm like 99% positive. I just found between Airy's experiment and Michelson Morley's. So if you guys look at, I have to concede one thing. I've been giving a slightly incorrect number because in his paper, that 0.8 arc second change, that was only from spring to fall. You actually have to double that to get the total stellar aberration number, because you had spring to fall and fall to spring. That's how stellar aberration is calculated. So technically it wouldn't be 0.8, it would be 1.6 arc seconds. Now, here's something crazy, right? Because of that 30 kilometer per second velocity that they claim is happening, right? When they did the Michelson-Morley experiment, they were supposed to get a fringe shift that corresponded to 30 kilometers a second. Instead, they got a fringe shift, according to the paper, that corresponded to 6 to 8. So between 6 and 8 kilometers per second. If you want to take the average, you could just say 7. Okay, so you say, let's say right in the middle, between 6 and 8, we'll say 7. So they needed 30, they got 7. Well, in this experiment, right, they went from about 20.64 is the standard, and then what it's supposed to shift to based on the stellar aberration change. And this is for a zenith star. This star was like 0.1% away from zenith, so negligible change of these numbers. They'll be ever so slightly off by maybe a hundredths place or something. But it was supposed to change from 20.64 to 27.52. Now stay with me. This is just one more number, okay? So there was supposed to be a 6.88 arc second change. They needed 6.88, they got 1.6. In Michelson-Morley, they needed 30, they got 7. Guess what happens when you ratio these? 7 over 30 is 0.2333. 1.6 over 6.88 is 0.2326. They're within 7 10,000ths of each other. So rounded to the nearest thousandths, they're equivalent. So literally the same exact ratio of the expected Michelson-Morley measurement to the actual Michelson-Morley measurement is the same ratio of the expected Airy measurement to the actual Airy measurement. That's not a coincidence, fellas. That's the ether wind in play right there.
Right, because remember at the time it was they assumed a static ether, not a fluid ether or ether that was in motion.
Bro, their same ratio between their expected measurement and their actual measurement in Michelson-Morley is the same exact ratio down to the thousandths place as in Aries. Oh my gosh.
That's wild, bro. Insane. Coincidence. So look, I do want Taylor to jump in because I know she's been patient. And then we could double back to some more open dialogue about this. Go ahead, Taylor.
Can you also, if you provide a measurement like that, like a ratio of two measurements, you should also provide the measurement uncertainty.
You ain't hear me just say, just tell us turn. Hold on 1 second, man.
Hey guys, I think you just called on me, right?
Yes.
Okay, cool. Thank you. Because I just like closed out my screen for a sec, so I just had to make sure. So anyway, I was just gonna say earlier, Peter was talking about how basically they set up their whole thing wrong and they weren't really looking for this measurement or they found something else. And like, I just wanted to remind people that like with the Aries failure experiment, for example, they acknowledged that they failed to find motion of the earth. Like that's what they were looking for. They failed to find it. Now, whenever he was getting this, paper peer reviewed, they go through extensive processes to make sure there's no errors or possible other influences that could affect the results. And there's an extensive peer review process that will happen. And so if they got something like critically wrong in the experiment, I'm not sure that's what you were claiming, but it sure did seem like you were claiming that, oh, well, they actually, of course they didn't get it because of this, like, and that wasn't a factor they considered or something. And the peer review process is like very extensive where people who actually do some more research will read over it just to make sure those types of errors are not at play and there couldn't have been external factors, and this was the factor that they were isolating. So I just want to point that out, and they admit that they failed to find motion of the earth. So I mean, you're just kind of arguing with the basics here, and it was a peer reviewed paper, so their materials and methods I believe were sound in that. And if you want to say that peer reviewed papers are not,
I don't know if it explicitly says that in the paper, does it? I don't know if it explicitly says it.
No, the paper doesn't say that they failed to find Earth's motion. That's not what it says. The stellar aberration is a product of Earth's motion, so it's a direct implication. They just don't directly state it in the paper. They don't need to directly state it in the paper. It's a direct implication. But yeah, go ahead.
Okay, but weren't they looking for Earth's motion and they used this method?
They
Yes.
were looking.
They were
for
looking
a
to test
change.
it. Yep. Sorry.
No, you're good.
Yeah,
They were looking for a
specifically.
change
So
of angle.
yeah, so clinker
Okay,
fuse.
because of the motion of the Earth, right?
Yeah, specifically
Isn't
clinker
that what they were
fuse
trying to find?
proposed the.
Okay, yeah. So
Taylor,
they
can
were
you
they
hear
were
me?
making a materials and methods.
Tay,
Taylor, can you hear
no.
No, I can't.
All right, one second. I'm gonna drop down and come back because I want to see if I can fix this mild echo
I just
too,
wanna
real
say
quick.
one-
Oh,
Okay,
But yeah,
worse
he's
one than
answering
me.
your
Okay,
question.
my bad.
Taylor.
Be
He's
right
gonna
back.
drop down though.
I mean, I can drop.
All right, one second. One second, lads and ladettes. See if we can make this better.
Materials and methods to look for that, I believe, were sound in order to look for the motion of the Earth. Go ahead.
Yeah, Alan's based on the motion, the ratio of the velocities.
Testing 1, 2. Yes, dude, the echo's gone. God bless. Hopefully, it stays gone. Anyway, yeah, specifically in clinker fuse's paper, because some people will say Airy wasn't testing for motion of the Earth. We already knew because stellar aberration and parallax, and it's like, bro, those things are what it was in question. That's why you introduced the water. But anyway, like direct proof of like that he was trying to test it specifically was at the beginning of clinker fuse's book. He says there's two types of aberration, right? There's like a physical effect and there's an apparent effect. And when you do this experiment, we can determine which is the real effect and which is the dynamic effect, meaning like the causal mechanism, as we've been talking about, is that the Earth is in motion. That's what's being asserted as the causal mechanism of the aberration. And then people will try and say that this test is about ether and that he failed to find the ether and all this stuff. But he specifically goes on to state that the cool thing about this experiment, even though Fazal's experiment showed that light does carry a velocity potential in a medium as a ratio of the velocity of that medium. So they were assuming that, you know, because light entering a telescope that's moving at 30 kilometers a second, that there would also be a similar relationship. So how he derived everything was independent of any ether mechanics or ether variables. There's no ether involved. All he derived was using the law of cosines and Snell's law, and to make the predictions. And he was saying that, you know, based off of this ratio, we should get this angle increase when we introduce the water. And that will tell us that, you know, that the causal mechanism, the dynamic effect, is actually due to Earth's motion.
And they didn't get it.
And yeah. So check this out. Clinker Fuse actually said he did get it in his telescope filled with turpentine. He was like, "Yeah, I got that angle increase, baby." And Clinker Fuse was such a man of repute that Airy, the astronomer royal at the time, was like, "Oh, no way, you got that velocity component? Let me swoop that. Let me see if we can get that." And that's when, because you know, you got to reproduce it, right? Science is all about reproducing and whatnot. So he did his experiment based off of the same thing and found no angle change, which falsifies that idea. And what Pizio just laid out with that ratio to Michelson Morley, I mean, god dang, dude, it's been there the whole time, bro. That is so insane. Like, oh my god, I can't even believe it, man.
Yeah, let me not take credit for that. I just looked at the numbers and I was like, I wonder what happens if I ratio them, bro. I don't think half the people. Okay, let me not insult anybody in here. I just wonder if anybody in here understands the magnitude of that. That the fact that the predicted
The
friend
odds
shift,
of that happening, like,
bro, the predicted friend shift and the measured friend shift in Michelson Morley, the ratio between those two is the same as the predicted theta angle change and the measured theta angle change in Airy's experiment. They're the same ratio. That can't be true unless they are both concluding the same thing, that there's a there's not a motion of the Earth, boys. It's not moving, dog.
Mutually exclusive.
Franco, does that ratio surprise you?
Is that for me?
Your name Franco, my doodle?
I mean, I wasn't sure that it was
Yeah,
Franco that was said.
I was just asking
I
if
don't
that
know. I don't know.
ratio
I'd
suggests.
have to see. I'd have to see exactly what this claim is. And as I was saying before, when you claim that you measure, you take a ratio of two measurements, you have to correctly propagate the uncertainties in order to see whether this new measurement based on two different past measurements of over 100 years ago, by the way, is actually significant. And then you can discuss what the significance of the measurement is. But any measurement in physics comes with an error.
Yeah, got it. Well, I literally just took the raw numbers of the precise math for Airy, and I took the raw numbers of the 6 to 8 from Michelson Morley, right? I just took the smack dab in the center of mass, or whatever, if you want to call it, of the distribution, and used those numbers to ratio against the predicted values. And based on just those numbers, like I said, they're accurate to within about one thousandth.
So Franco, let's say those values are accurate, right? Let's say Piezo did the math right. Would that ratio surprise you?
I don't know. I'd have to think what it means.
Well, the ratios in question, just to reiterate maybe more concisely for you, brother, Michelson Morley had a predicted friend shift the friend shift would correspond to 30 kilometers a second. It corresponded to 6 to 8, which I said the center of mass, that's just 7. So I used 7. So it corresponded to 7. So they needed 30. They got 7. The predicted angle change for Airy, based on a zenith star. Now, once again, this star was about like 0.1% away from zenith, maybe less than that, maybe like a tenth of a percent, but a very tiny. It's basically zenith, right? Should have been 6.88 arc seconds. They got 1.6. So in Michelson Morley, they needed 30. They got 7. In Airy, they needed 6.88. They got 1.6. If you do 7 over 30, you get 0.233. And if you do 1.6 over 6.88, you get 0.2326. So they're different by 7 10,000ths, less than 1/1000th.
Bro.
But I mean, each of the two ratios is some. If you say something like the expected was 30, and you get 6 to 7, it means that the ratio is the uncertainty on this is on the order of 1/30th. It's 3 something like percent. It and then just propagating the error on the first. On the first on the numerator, and
So
then
you're saying it's just an error, not a ratio of the motion that's actually detected.
I'm trying to propagate errors here. And propagate uncertainty.
You think it's just a random coincidence that even before we go and do a rigorous error analysis to see how far off we do a plus or minus of our numbers, you think
depends what you're comparing. I don't know. I don't know if you're comparing what you get with respect to what is expected. It depends. They could be completely unrelated. It depends. You have to have a measurement of something. Measured divided by expected, it can be. I don't know. I can just climb on a scale now and see I expect to weigh some number of kilos, and then I find another measurement and I do the ratio measured with respect to expected and find something else. It depends what you're measuring actually. So I don't know. I'd have to analyze the situation. I can't say what this ratio means if it means anything.
Well, there's two options, right? The causal mechanism could be Earth motion, or the causal mechanism could be a stationary Earth with ether wind, right? So the ether wind velocity is clearly going to be different than the purported Earth motion. So that's what our position says. Our position says the reason that the observed measurement is different than the expected measurement is because the expected measurement is based on Earth motion, and the observed measurement is based on ether wind. So when we take two different
Sorry, in both cases, the expected measurement was based on an untrue of things which were proven then afterwards to be false, meaning that there's a stationary
What?
ether.
No, bro. The 30 kilometers a second is said to be the Earth's motion, right? They were supposed to get 30 kilometers a second, and that doesn't
Yeah,
matter.
because that was the motion of the Earth with respect to ether, and the fact that it didn't find anything was a proof that the Earth was not moving with respect to ether. There
No,
was no ether.
it's not true that they didn't find anything. They did find something. They got
Okay.
6 to 8 kilometers a second.
Okay, but this is now understood to be, I don't know, because I don't know all the details of how it's explained now, but you wouldn't expect anything except some I don't know other kind of effects, but you should not expect anything due to motion because of the speed of light being the same.
Yeah, if you didn't assume an ether, but if there's an ether that's in motion, then you would expect something to come up on the fringe, just like the consistent ratio to this experiment, Franco. This is what we're saying. It's
The static ether is a straw man. The static ether is nobody of any repute or report who actually wants to take these observations with respect to an ether framework and see if it works or not thinks it's a static ether, right? Because we have a stationary Earth position, and a stationary Earth position has a moving ether. So Earth's not moving, ether moving. That comports perfectly with all these observations that are known.
It would make sense if there wasn't anything. But there is. What is it? We got to acknowledge it.
Sorry?
That we have to acknowledge when there is an observation. We can't just dismiss it as if nothing was there.
Things were discovered 100 years ago.
Let me ask you this, just real quick.
Things were discovered 100 years ago. Things have moved. Physics has moved.
From when?
We are 150 years late, boys.
And y'all still trying to figure it out.
Yeah.
Still ain't got no answer. That's an irrelevant point.
Yeah,
so,
physics.
Look, real quick. Let me just ask you this, Franco. Do you agree that light moving in respect to the telescope with no water, right, relative to itself, is a stationary frame?
Say it again.
That the light moving in respect to the moving telescope, the light is moving in respect to the telescope. That's a stationary frame, right?
You can see things in any number of different frames. One would be what you call the sun's frame or the star's frame, and the other one is, another possible one is the one where the telescope is stationary. Yes.
Same frame that you use, the same frame that you use when we introduce water. When you take the water out, it's still a stationary frame, right?
The one with the telescope, yes.
So you would say that there would be no change. That's why you say that it's relative to itself with water, because you said there's no change.
There is a change.
He acknowledged there's a change. He acknowledged that. We had that discussion. We agree there's a change.
There's a change, and the change is in my slides. It's the aberration angle. If light is going one direction in one frame, it changes direction when you change the frame. Generally, if the frame is if the second frame is moving perpendicular to the light propagation in the first.
Well,
and that you obtain by transforming correctly the wave vector.
Let me clarify. Let me clarify.
Not a photon, not a particle, not a bullet.
Let me clarify. Enough of a change that you attribute to the initial aberration.
Say it again.
So there's an initial aberration, and you're saying you're transforming. You're saying they're transforming into a stationary frame with the water. So that way, to account for the fact that we don't get that predicted angle change because it's a stationary frame.
not following what you're saying. Again, this is why I'm repeating myself. I know, but this is why I'm saying that one should address things by addressing equations and objecting to specific equation. With words, it's very difficult for me. I don't know if it probably it isn't for you, but it's very difficult for me with words because I don't understand what you are talking about. So sorry.
I agree, Franco.
Nothing else,
I
please.
I agree. It can be difficult. It's these conversations without math. Like you have to be very concise, and I do. And like I will acknowledge, I will admit, I fundamentally disagree with you about a lot of things, but I do actually enjoy most of the conversations that we have. Uh, and like it is a pleasure, like having someone of an academic background with uh, a good enough mental acuity to understand these concepts given the right environment to discuss them. So that being said, like let me try to make it concise so that we don't need to break down 8 more pages, right? Because we kind of already did that. We already established, we made this agreement, right, that there would be an angle change. Both of us agreed, and we also agreed that it's a we can calculate what the angle change is, and
Yeah.
that angle change, like I said, I did the math for a 90-degree star. The star is not 90; it's like 89.98 or something like that. It's if you want to kill me over a hundreds place, fine. But the projected angle change due to with the accepted aberration formula is about 6.88 arc seconds. So I did that math, and then I plugged in what they got, 1.6. I ratioed the two. Took the same thing with Michelson Morley, 30. Took what they got, 7. Ratioed the two. The ratios match. Now you can go afterwards and you can say, let's see what the uncertainty in the measurement is. Are we able to introduce uncertainty that throw those ratios off? Maybe, maybe not. But the fact that they're already so spot on just by taking the center of mass of the distribution from Michelson Morley. Now, Airy, you're not going to find error in there. That thing's like, I encourage you to research the Airy one. Alan's got a prez on it. You can use his sources or look them up yourself. But the Airy thing was incredibly precise. They had a 1/1,000,000th of a degree precision on the micrometer scale and took left and right limits. And then they rotated the telescope 180 degrees and took the same measurement over again just to overlap them and make sure they were the same. That's extremely precise. The Michelson Morley, they took their measurements over a period of time. Was it 3 months, Alan? 3 days, 3 months. Well, anyways,
Yeah, but they only
or not
published
days,
6 days of it though.
6
yeah.
days. Okay. Yeah. So the thing about the Michelson Morley, Franco, is that it varies sinusoidally with respect to the motion of the sun. And so that is why you get that wobble. That's why you get the 6 to 8, right? Because it's like sometimes it's 6, sometimes it's 8 at different times of day or whatever. It varies due to that sinusoidal distribution. So that's why I just took 7, because it's right in the middle at center of mass, right? If I got a sine wave, I've got an upper and lower limit. Why don't I just take the middle and treat that as the average? That's not a perfect way to do it, but it's pretty darn good for most intents and purposes. And like I said, when I do that, I get the precision of the matching of the ratios in the two experiments to within 1/1000th. So, say what you will, I don't believe in coincidences like that, especially not when it comes to a causal mechanism that's driving this motion, right? And in both cases, the ratio of the expected, or the real to the expected being the same. That I don't believe in coincidences like that, man. If you think it's a coincidence, you got more faith in Earth motion than I do, for sure.
As I say, I don't know because I have just without reading what it is about. I don't know what this ratio means. But for one thing, I'm sure I'm almost sure of because I didn't see numbers precisely. But if you say that the ratio, the ratios are the same to a degree of 1 per mil. This is not a correct physical statement because one of the two is or the order of 3%, the uncertainty. So it doesn't mean the fact that some ratio, not do two numbers agree to 1 per mil, if one of the two uncertainty is greater than 3%, doesn't mean anything. It's not that level of agreement. The level of agreement is based on the uncertainties. It's not the way you compute agreement between numbers that in physics. But anyway, that's a sort of formal objection. There's a more substantial objection that I don't know what that means. For instance, the prediction in the case of Airy that you're quoting is based on a wrong calculation, and also so it's not. I don't know if the two calculations, if the two expected calculations were wrong the same way, then it does make sense that what is measured with respect to what was expected wrongly would give the same results in a modern perspective. But the whole point of everything is that what I find really amazing, as I said before many times, and people still saying, is that you people are concerned with experiments which are very old. Not like is still at that point, at the point it was 150 years ago. It moved on. You have an incredible number of other experiments done with many much more sophisticated techniques.
Which experiment you got that proved the Earth is in motion around the sun?
21st century, you have lots of experiments and none have. I just stumbled on a result from the experiment I'm part of, which was very recent, testing exotic models which would predict some very small portions of Lorentz non-invariant, of violations of Lorentz invariant in top anti-top production in LHC, and it was tested if this particular model which predicted some possible Lorentz non-invariance, and it was the results were negative. There's no evidence of any contribution of Lorentz non-invariant operators in the standard model Lagrangian at the moment. At the moment, tested in this particular, you have a lot of experiment, an incredible lot of experimental results for all the 20th century and the first 2 decades of the 21st century, and you never consider those. You stuck back to the 1800s. Move forward.
Franco, we're not stuck in the 1800s. I don't know if you know this. Like, we recently did a recap on Airy. It just came up, and we cycle through famous experiments, both modern and 150 years ago, anywhere in that range or so. We were cycling back over Airy and found more information about it. We're reestablishing a more firm position on it, and we chose it also because of the fact it's so simple that Airy is one of those things that even a layman can understand once they have it explained and check it out, right? And what you're saying, by the way, that we have our math wrong. I mean, I do disagree with you. Every source text that I have seen, I mean, if I just go to Google, I can get a physics Libre text. I can go to Wikipedia, get the Wikipedia text with all of its references to the textbooks it references. All of them give the same formula for stellar aberration, for starlight aberration, right? It's the classical formula is tangent theta equals V over C, and the relativistic formula is sine theta over gamma factor times V over C plus cosine theta. Now, the tangent phi angle of that. Now, when we did the math on it, like it's in these slides in the jumbotron. I tagged the guy we were talking to in here earlier about it. You're free to go up there and look at it, because the velocity of the Earth is so small compared to that of light. It's 60,000 miles an hour versus like 300,000 kilometers a second, right? It does not appreciably change the angle predicted by the classical formula. They agree within 2 10 millionths of an arc second of each other, pretty much. Like, we're talking on an order of like a millionth of an arc second or less that they that they deviate. So for all intents and purposes, that's not even measurable. So, you know, saying that, you know, you have to use relativity to explain it. I mean, we literally, we have the math for it, man. We put the numerics in there, not just from a principle like you did, saying, oh yeah, frame transformation should fix it. We plugged the actual numbers in when we did it, and it's on Alan's Obsidian database, and it's in the post in the Jumbo. You know, there is no appreciable change. It matches 99.9991% agreement with the classical formula. It's like 6.88 6.8 something arc seconds of change that should have happened, and they got 1.6. So they're way off. They're off, and they're off by the same amount that Michelson Morley was off. And the reason that I invoked those measurements earlier, not to beat a dead horse, just to say, you know, you said you don't know what that means or you don't do physics like that. Look, all I'm saying is if the reason that Michelson Morley were wrong is because they were looking to the wrong causal mechanism, and the reason Airy was wrong is because he was looking to the wrong causal mechanism, and in both cases the actual true causal mechanism was ether, that would make perfect sense as to why the ratios between real and expected are the same in both of these experiments. Otherwise, you think it's just like a fortunate coincidence that we just got lucky and get to use now. I mean, you know, I'm not a coincidence theorist, man.
As for the formulas, I didn't put them because I trust what I know and what I teach in electrodynamics, and so I did compute it myself. So if it's wrong, it means I got it wrong. The formula in yes, and of course, for in vacuum, there's no problem because for small velocities, you have the tangent of the angle is equal to the sine of the angle is equal to the angle in radians. So it's for small velocities, everything to first order in the angle, they're all the same. Problem is what happens when you go to a medium which is not water, which is not a vacuum. Sorry, because in that case, you have to know how to compose velocities, and what you do is you do not use, in order to understand how light propagates, you do not use either classical or relativistic velocity composition, because that is wrong, because it's not a marble moving, it's a wave moving, and you have to propagate, you have to see how the direction of and the velocity and the direction of a wave changes when you change frame, in my opinion. And this is how you treat the movement of light in a microscopic medium. If you want to do it microscopically, then it's a very complicated thing, because you have to use the interaction of photons, which always move at sea, with moving water molecules, and that is very complicated, and that's why the only way of doing it simply is to move back to this motion, to the frame where the medium is stationary, then transform back. And this, as I was showing in my slides, predicts exactly what is observed with Fizeau's experiment, which in that case leads to relativistic velocity compositions as if it was a marble. Then for the angle prediction, it doesn't predict what the normal velocity composition would. It predicts something else, meaning that the angle is reduced by a factor n, and this is also true at first order, meaning that the angle, the aberration angle in water is not theta, is theta divided by n, is not theta multiplied by n. And I think that theta multiplied by n was what it was expected by Airy, because they did the calculations wrong, and what is truly to be expected is theta divided by n. That's my point.
Well, it's been a pleasure, Franco. I think you were focusing entirely on Snell's law in your analysis, and you weren't doing the actual aberration due to the motion between the two. So that's what I was saying. You know, we did the calculation based on the relative motion between the two, which is the much larger correction. You know, it's going to eat up the Snell's law correction due to the
No,
deviation from zenith being so small and the velocities being, you know, so large.
what I'm
Uh,
showing is that so it's completely consistent. That's what I showed in my calculations. You do it with transformation. You do with a composition of wave velocities and do it properly, done it properly, and then you see you compare the Snell's law and you see that it's the same thing, which is a relief for me. It's completely consistent. Two different laws, which apparently have nothing to do with each other. Actually, not, because the physics is the same. But two laws, which are Snell's law on one side and the aberration law on the other one. They're consistent. They gave the same result. I make the prediction of the deviation angle in two.
They only give the same result if the Earth's stationary, Brody.
Sorry?
They only give the same result if the Earth is stationary. If you do, like, you got to remember, even though you Lorentz transform, the Earth is still moving at 60 kilometers a second. So if you transform to the photon and make it equivalent, then you don't predict any change. But then you're taking the distinguishing factor between the frames and making them equivalent, showing that they're like you're needing to compensate because the frames are distinguishable. Because there's like the implication is that the Earth is stationary. And when you were talking earlier about the refractive index of for vacuum going into air, that's like a 99.9999997% difference. In GPS, they don't even account for the difference where a timing offset, if there was any magnitude to it, would affect the accuracy by 30, 40 meters or whatever, right? So yeah. Well, just take my word for it. I know, but anyway, what you're proposing as an answer is not an answer, man. You can't just transform to a photon and have add the lateral velocity component to it. That doesn't help anything.
I could have, but I never mentioned photons. I only because the reason is that in water it's very hard to treat things as photons, because in that case, whereas in vacuum the wave vector is proportional to the form momentum of a photon, but this is something that is totally unnecessary here. What is not true is that the modified wave vector in water is not proportional to the momentum to the form momentum of a photon. So using photons to describe this is not the convenient way. I used wave transformations and Maxwell's equations predictions. That's what I used. I never used photons,
any velocity potential that you transform laterally doesn't matter if you treat it as a wave or a photon.
Sorry, I transform laterally because that's what was supposed to happen. I take this situation where light is coming one direction and Earth or the telescope is moving.
Okay, and if that were true dynamically, right? If that were a viable position, you wouldn't have aberration in the first place.
Why? I computed it and I showed it. The sine theta equals minus beta.
Listen, if the photon in air has a lateral velocity component, then there's no aberration. You're in the same problem. We both agree that there's a timing difference in the medium of the water, so there has to be a bigger angle. right? When we do the relativistic math, it agrees with the classical derivation. So we're not even talking photons or anything like that, right?
I didn't.
What you're doing mathematically is you're reifying what you believe in, and you're co-opting the measurement as a prediction of what you believe in to substantiate a velocity component that's not actually measured. Remember, you're taking the absence of a velocity component and transforming it and adding it to another frame to try and make it appear as if that would predict no angle change. So like we're talking dude in the lab, first order measurement of an angle prediction, and it ain't there. But then you're going to take that lack of thing that's not there, transform and apply the velocity vector to the incoming light wave or photon and say that that's the solution to it. That's not a real solution.
I don't follow you. It's not it. I think the way of doing physics is the way I did it. So if you have a problem and saying why do I expect aberration? I expect it because of relative motion, and I showed you how you make the calculation. You make the calculation with, if you use correct relativistic transformations, you get the sine theta angle. If you do it the other way, you can get the tangent theta angle. For small angles, they're the same. You predict that there's an aberration angle due to relative motion. Then the problem is, what happens if I do this with water instead of vacuum? It changes by a factor 1/n. Then how do I expect the change when light travels between the two, crosses the boundary between the two? And I showed you that if you just use those two calculations of aberration angle independently, and you get Snell's law, which is exactly what you would have predicted if you didn't know at all aberration, and you had that in your frame, in the stationary frame, where you are water station. You have light coming at an angle, can be 0, can be 1 degree, can be 2 degrees, can be 10 degrees, and what you get is Snell's law. Whether you have computed this by changing frames and starting from a frame where the telescope was moving, or whether you're not doing that.
Frank, I did the math just now. I calculated the numbers for the Snell's law. So, taking the average position of the star.
Can you send it to me real quick so I can put it on the jumbo?
Yeah. Well, it's I have to put it together because it's on Wolfram Alpha. So
Gotcha.
I can show you the number. But
go ahead. Continue.
Anyways, the star in question was, about 80 arc seconds off of zenith in the spring and about 120 in the fall. So I just used 100 because it's right in the middle. I mean, you could calculate for both and get ever so slightly more precise. I'm doing one calculation to make it easy. But either way, I used 100 arc seconds off of zenith. Okay, 100 arc seconds is 1 2/3 arc minutes, which comes out to be 89.9722 degrees. Okay, so if you use the n1 sine theta 1 equals n2 sine theta 2 Snell's law formula, and you plug in the the ratio of the refractive indexes, 1/1.33, which is 3/4, and then the sine theta angle of sine 0.02. What is it? 0.0. Here, I just had it here. Anyways,
these angles, yeah. You have to transform the angles to radians. So, yeah.
Yeah. Well, I mean, I just used Wolfram Alpha, so I can just tell it to do it in degrees, and it'll give me both answers. But you end up getting a result of 1.31 arc seconds. So the relative motion correction is 6.88 arc seconds, and then the Snell's law correction would be, at most 1.3 arc seconds, roughly. So,
Can you write, because these are vocally, I don't get them. Can you write the number?
Okay, it's just two numbers. Relative motion 6.8 arc seconds. Snell's law 1.3. Okay, so you can add those or subtract them depending on, I guess, which way you're thinking that it's happening. If the Snell's law is adding to it or taking away from it. Either way, what they got was 1.6 throughout the year. So, but I think that, what I'm thinking about Snell's law, right, in terms of stellar aberration, is wouldn't it be in one direction in the spring and the other direction in the fall? And since you're measuring over the course of a year, wouldn't you just cancel the two out, right? Because it'd be in one direction, the other direction, they would cancel. That's why you wouldn't really need to worry about Snell's law. Because it's not like he didn't know about Snell's law.
Yeah. But we were predicting a different deviation based on different formula.
Well, his deviation was based on the relative motion.
I don't know what they were predicting and based on what, because at the time they didn't know. I did the calculation based on what we know now, and what my calculation shows, and based on what we know now, is that the prediction due to aberration is the same as the prediction due to Snell's law. So if we do
no, the math doesn't say that. We just did the math. I mean, the deviation due to relative motion is about 6.8 arc seconds, and the deviation due to Snell's law is about 1.3. They don't match.
I did the math wrong. Where did I do the math wrong?
I don't know. Snell's law is super easy. It's N1 sine theta 1 equals N2 sine theta 2. And just plug in the numbers, man. I mean,
it means that the angles should be reduced by a factor of 3/4.
Yeah, it's 3/4 sine theta 1 equals sine theta 2, and sine theta 1 is 0.
Sine theta 1 equals sine theta 2.
Yeah. Yes. So it's 3/4 sine 0.0278 degrees equals sine theta 2.
Yes.
No. And then.
Yeah. Sorry.
Yeah. 1 second.
Hey, maybe you guys, what you could do to cap this off, after you exchange real quick, maybe steel man each other's position. And I think Proud wanted to say something. And if not, we'll go to Galatrax and Dr. Flat. Dr. Galatrax and Dr. Flat. But continue. And maybe we could do that.
But that's saying that discussing it vocally is just a long process, whereas it took me some hours to prepare those slides because it's a long process to write them down. But once you have the slides, once you have the calculations, you can reply to the calculations directly. Say, no, look, this equation is wrong for this and this reason, and I write it down, not just vocally, because vocally it takes forever. You get to.
Okay. Well, maybe we can come back to it. I mean, maybe I did the math wrong. I mean, I could be off, but either way, whether or not my number's too small or my number's too big, the predicted shift in angle for Snell's law and relative motion are not the same. I know that much. So, I just to be safe, I made sure to throw in the arc sign there that time in case I forgot, because I might have forgotten it the first time. And with the arc sign included, it goes from 1.3 arc seconds to 75 arc seconds. So
the reason why I did the calculation plan instead of looking at the papers and so on is that let's look at this. I got the physics that I know, and that I teach, and based on that, let's see what I would predict. My prediction is two effects are exactly the same. So independent is observed, I don't expect any difference between Snell's law and aberration in medium. If that proved me wrong 150 years ago, then I don't know. It also implies that he proved me wrong. The explanation to me is that what is expected, what you call the expected value for the shifting in magnitude due to velocity compression is that the wrong velocity due.
Okay, so you're hot, Mike, so we can't really hear you.
You should use the way a wave propagation changes, not a particle. In the case of a photon vacuum, they're the same, the laws.
Yeah, we did use the wave anyway. Let's see. So to quickly recap, you're offering a second order interpretation via transformation, which assumes a velocity component that's unmeasured because there's no actual angle change. Whereas the first order prediction and first order measurement is that there's no angle change with respect to a stationary Earth and the sky is in motion, which produces the displacement. So it already comes in at that angle. So that's a pretty good recap, I think.
It's not a second order, it's a first order. You have...
You're transforming, bro. You're in a different reference frame. You're in a photon frame to answer it. It's not a first order. That's a covariance, bro. You got a gamma factor in there? You transforming, bro? Let me see your license for that transformation. I'm just messing with you. I'm just a little hyper because this kind of went on for a while. Sorry. Go ahead.
Look at the results, and you see that my calculations are first order in beta and theta. So it's not second order. Second order is just discarded. Gamma, I put it to equal to 1 in the final calculations.
So you're saying you're using Galilean relativity?
No, I'm using Lorentz and then taking the limit for beta, but much smaller than 1, and then using first order in beta. Yes, basically it's a Galilean, but then you have a transformation in frequencies as well, which is also first order. But that way, right?
Nah, there's no such thing as a first order in the Lorentz transformation. You're taking the second angle and putting that in the in a different reference frame, though. So that's not. It's a ruse.
What? I'm using the proper transformations. Based, I said, I will not do the calculation based on what was known or thought at Airy's time. I'm do the calculation based on what is known now, what has been known for a century, and I'm doing what I expect based on what I know now, based on what I do teach at my courses in electrodynamics and relativity, and what is expected. This, and the way to do it is you Lorentz transform, and then if you want the limit for non-relativistic, you just take the limit for beta goes to 0 or gamma goes to 1. It's the approaching 0, approaching 1. This is the proper way of doing it. It's not wrong.
Okay, in order to invoke a gamma factor, though, right, you have to use you're invoking second order effects. You're invoking a second order change in time and or space. So you don't have a first order interpretation, right?
I'm using it correctness, and then I'm
not saying you're doing it incorrectly. I'm saying it's second order compared to our ratios and what we do. We don't need a transformation.
You look at the result and you see that there's a first order term.
I'd like to provide some comedic relief, if I may.
No, you may not, dude.
No. I think
Peter, you're not invited to do that, though.
Please look at the numbers, please look at the equations, and I get a first order result.
Because the gamma factor term is negligible and not relevant. That's the only reason.
Yeah.
It's the
So
appearance of first order. Your interpretation is second order. You're co-opting a first order measurement there with that. So you don't actually have a first order answer, right? Your term is negligible. It's only first order for us. Your gamma factors, it ruins your continuity of first orderedness. You're neglecting it.
what?
You only have first order in the measurement frame. Anytime that you transform out of that frame to apply any type of covariant transformation, you up the order of your system. So I mean, you can't claim a first order measurement in a theoretical frame, right? The measurement took place in the lab frame. The lab frame is the first order measurement every time a measurement's taken, anytime, anywhere.
First order means that you take the first term in expansion of the results in the small numbers, in which case, in this case, the small number is the velocity beta. First, you get a first order result in beta for the aberration angle, and it's shown in the calculation. It doesn't matter that you did it using the correct all orders. It's not, gamma is not a second order. Gamma is a function of beta, which is not a second order, because a second order would mean a polynomial, would mean alpha plus, would mean A plus B beta plus C beta square. It's not that, because gamma is a function of beta. So it's not. It's got all orders of beta in it. Actually, all the odd orders, all the even orders. Sorry, because
they don't even know what you mean, Franco. They don't know what you mean. They use the second order in a different meaning. One thing that never ceases to amuse me.
No, you're not invited to this. You're not invited to this conversation. So real quick, for the lads, first order.
No idea.
First order would be the starlight coming in. You're making the direct observation, right? There's no change. There's no there and back, and that would be the first order observation, the first order measurement, how we're making it, right? What you're applying with a gamma factor is a function of velocity, in that it changes time and space, the coordinates, right, through a Lorentz transformation. So this is invoking a different reference frame. These are second order effects. They are not first order. Your gamma factor in the equation is actually so negligible that it's neglected. As Pizio showed, the difference between the two is, what was it? 2 10 millionths of an arc second. So they're equivalent. So you invoking this different reference frame to try and explain this, to give the same angle, it's still, the actual angle isn't present. You don't get to transform, have a different velocity component, and then not have an angle difference. That's retarded.
Retarded? Please take the equations and tell me where they're wrong. Please.
We've been telling you all night.
No, isn't.
Your equations are equivalent to our first order equation when you apply them properly. When you do your West Coast custom transformation, you're just co-opting our position by doing a transformation to a different reference frame to add a velocity component there to make it equivalent to our position.
No, I'm not adding a velocity component. I'm changing the wave vector. I'm transforming the wave vector, and the way to do it is you do it not by adding velocities, because the wave vector is not a velocity vector. It's something different, and that's what you have to transform. If you add a velocity component, you get the wrong formula.
I might be using the wrong terminology, but you're taking the lateral velocity component from the Earth and you're putting it in a different reference frame for the incoming light. Yes or no?
Yes, that's what you do when you
Okay, great. So we're on the same page, but I apologize for having the terminology not aptly applied or whatever. But I understand what you're saying. And that's that's the second order interpretation. That's a transformation into a hypothetical frame that no one can go to confirm anything for. And on top of that, right, you can actually neglect your entire gamma factor and just answer it in the first order with the classical explanation when you do it the proper way. So what you're doing is you're trying to keep the Earth in motion by transformation and that's in a way that's not applicable. You're just you're reifying motion by saying that there's actually no predicted angle change if you assume motion and invoke a fictitious frame to transform the motion to. That's not okay. That's not a physically meaningful explanation.
I'm sorry to disagree. One thing again, the calculations are first order calculations, not second order. I'm repeating this for the.
Sorry, your mic cut out. Testing 1, 2. Was it me, or can you guys hear me? Testing 1, 2. I'm going to drop down and come back up. All right, this could work out in my benefit. We could get a chance to reset the echo. Sorry about that, lads and ladettes.
Uh-oh, we lost 2 in one fell swoop. I feel like we should. Sacred wasn't really too Franco. I wanted to
Testing.
hear
Can you hear me now?
Franco's idea of my question, basically.
Can you hear me now?
Yeah, we can hear you. I can hear you, Alan. Bro, can you hear
Sound
Alan?
like a wires and wireless ad. Yeah, I heard them.
You're Alan.
Cool. Yep, she did. Welcome back, Franco. Sorry, we both cut out at the same time.
So sorry, I can resume what I was saying. The calculations I sent are Lorentz transformations which are exact, and then what you can do is take the limit to the so-called classical limit or non-relativistic limit, which does not make them wrong, right? It makes you sure that they're right. So you take the limit when you take gamma equal 1 approximately, because you're neglecting second order effects, meaning that you keep the first order, which are there. And the reason I use those to transform the kappa vector, which is not kappa, it's k, because kappa is a Greek word, is a Greek letter.
Okay.
Sorry, they have the same name.
Sorry to interrupt you, but do you remember earlier when Sacred asked you what your justification for transformation is? He was like what mechanism for it? Like maybe you didn't understand that, but like what you just invoked there, right? Why do you think that there is a transformation that's needed to explain this? When the first order predicts an angle change that isn't present, and then so now that the angle change isn't present, the solution, like the mechanism, is to assume that the motion is actually present, and then mathematically we can reference frame transform to predict a null result.
It's
Why
not
do you have to do that when you add the water?
Exactly.
One thing. It's what I did was not all the calculations do not have any dynamics in it. It's just since you love this distinction, it's just a kinematic fact. You just see what happens to light propagation when you move to a frame where the medium is moving, and so it has a net velocity. That you can do it first order, second order, 10th order, whatever. What is done? The reason why I did it with Lorentz transformations is because this is a correct way of doing it, and a correct way of dealing with wave vectors. And the way wave vectors transform, because if you do it with, say, classically, by composing velocity vectors, then you might get the wrong answer in water, because what you do is just to assume that the velocity in water stays the same, namely c over n, and then you add a component, a vertical component. I don't care why you do that. You want to see the effect of this. And the effect of this, if you just take the velocity in water and add taken to remain c over n, and then add a perpendicular component, that of the velocity of water in your particular frame, then you get the wrong result, because this is not the way you should deal with light propagation in moving media.
Okay,
you have to transform
well, hold on a
what
second.
happens to the wave vector. And the way you do it classically, for my convenience, what I did was to do it relativistically and then take the classic limit, because because it's not obvious to me how to compose wave vectors classically.
Okay, well, you can apply Fazal's drag coefficient to water or, moving media, and it's the same. It's actually equivalent to the quote unquote relativistic velocity composition, which answers it the same way. But the fact still remains. You said something earlier that really kind of answered my question when you said you could get the wrong answer. And the answer, there's no wrong answer, right? It's just math. It's just a mathematical prediction based off of velocities and timing, right? Based off of the speed of light for the ratio. So when you have a classical prediction that doesn't match what you expect experimentally, that's not wrong, right? The ratios are all still correct, because the ratio used in Michelson-Morley is the same ratio that they use for the Sagnac effect, which is still used today for inertial navigations, which Pizio just showed. There's a direct relationship with the ratios of the experiment for Airy's, Michelson-Morley, and all of these things. So the ratios they have are dead accurate, and what you're doing, right, is why are you transforming? Because you think you got the wrong result. So now you're transforming to make the result match the experiment, which the implication is that the Earth is stationary. So there's no justification for it dynamically other than philosophically, right? You say you could get the wrong result, but the wrong result isn't wrong. If it was what was actually measured, it would be your guys' go-to proof. It would be very physically substantial if you put water in the telescope and the angle increased. That would be crazy hard to argue against, because we all know the implication of that. But because it didn't happen in the favor that you needed to, you're like, well, I can do this second order transformation and use covariance to answer it. Covariance is by nature second order. It's not.
Oh God! Not a second order transformation. For God's sake, look at it. Look at it.
Listen, I know, because the gamma factor cancels out, bro. I know, because the gamma cancels out.
Sorry to interrupt, but I got to drop.
You add the beta gamma, beta gamma part. Beta times gamma is the first order in beta. You expand beta times gamma to second order, and you have a first order and then a third order. If you expand that, it's a first order. But let's what I was saying. You're talking Fizeau.
Franco.
Fizeau. Fizeau experiment. I'm showing in my slides that with my calculations exactly predicts the velocity composition for Fizeau's experiments, and this is because they're parallel. The K vector and the V vector, they're parallel. In general, it is not done by velocity composition.
They're never parallel, Franco. The star is never at the zenith at any point in time.
Yes. That's why you don't do the velocity compositions as if you would do for a particle in medium. You do with a wave vector composition.
It's still not parallel, bro. You can't take something that's not 90 and make it 90. It's just not 90. It's never 90. It's just not 90.
Who is doing that? I showed the calculation for a general angle. For a general angle, I just posted the very general composition rules, and then you apply it to whatever case you want. If you start from a 90 angle, then you get a better angle. If you start from a better angle, you get something a little bit different. You can use those transformations to do whatever. Of course, I don't do all this, but those are the equations. If you, I showed a number of special cases when you have a 90-degree angles, when you have a 0-degree angles, and in 0-degree angles, you predict exactly what is observed by Fizeau, and then when for the 90-degree or almost 90-degree, you get exactly what is predicted by aberration. The point is, when you do it in water, you get something which is not what is predicted if you add the velocity component, just doing the velocity composition, not even the relativistic one, because you don't compose relativistic velocities when they're not parallel. You have to compose, you have to add, you have to transform the wave vector, because it's a wave propagating. It's not a particle moving. It's the same. If you're in vacuum, then treating wave as
not particles.
Yes, it is particles with zero mass, so they have to be treated relativistically. And I was about to say, you do it with velocity composition if you are in vacuum, because in vacuum the particles are photons, and the full momentum of the photon, so the full velocity of photon is proportional to the wave vector, to the wavefall vector which I'm using. In the case of light propagating in a medium, it's not true. In the case of light propagating in a medium, it's not true. The
Franco,
wavefall vector is not proportional to the full momentum of the photon. So sorry, I think I know what I'm talking about, because I'm teaching relativity in special relativity. I know what I'm talking about.
All I wanted to say is that all these transformations and relativistic coordinate system transforms that you're doing, all these shifts that you're doing, all of that, where is the measurement taken? It's taken in the frame of the Earth and the telescope, right? So that alone is the first order measurement. Your first order measurement is where you take your instrument and you read it.
No, you don't know what first order means in this case. Oh God!
They have no idea. They have no idea.
Oh my God! They have no idea what
this is the funny part. You treat them seriously. This it always never ceases to amuse me.
When you shift yourself out into the middle of space to a photon in transmission from the star to the Earth by using a Lorentz transformation, by definition renders your new numbers not of the first order.
What is your definition of first order? First order what? In what? First order of what? In what?
First order measurement of the light in the telescope.
What does it mean?
It means that that's what my instrument read without having to transform my coordinate system or perform any other calculation.
That's not what I mean when I talk about first order. So we have to agree on this.
So in terms of, first order effects in this experiment, right? A first order effect like stellar aberration, right? That's first order, we agree?
First order, I agree that stellar aberration is first order effect in V/C. Which means that it's the effect is expanded, Taylor expanded to the first term, which is a proportionality to V/C. Is one plot factor times V/C, the effect.
Yeah, we can plug it straight in. Yeah, we can plug the measurement that we took straight in, right? Okay. Now the measurement in this case would be like presuming that we somehow measured the speed of light, right? That's the measurement of c, and then we're granting you the speed of the Earth for purposes of this calculation, right? Or you could measure the angle and then do it backwards. Either way. So okay, so second order, right? Are there any other first order effects in this?
I don't know. It depends what you're measuring.
Okay.
It depends.
So refraction. So let's talk about Snell's law. Is refraction,
Yeah.
is that a first order or a second order effect?
It depends. If the angles are small, then it's the first. You can approximate it first order because it's sine. It's because your first order approximation of the sine angle is the angle itself in radians.
Okay, so you think it's first order even? Wait.
It's first order. The angle is less than 1 degree. If it's 45 degrees, it's not a first. It's not a first order effect. Absolutely not.
Franco,
Okay.
you don't understand what they mean. What they mean is a first order measurement for them is when you take a value of a particular measurement and that's it. You don't perform any calculations on top of it. So a first order measurement would be measuring the lengths of the sides of a rectangle. That's a first order measument. Second order measurement would be calculating the surface area. Let me finish, you internet cowboy. Calculating the calculating the surface area of a rectangle in their lingo would be a second order measurement because you didn't measure the surface area. Oh, come on.
Calculating the surface
Any
area.
sort of calculation on top of your measurement is second order.
Let him get his thought out. And we got
any sort of yes, I will. Any sort of calculation done on top of something that you took directly from an instrument is a second order to them.
Okay, so first order versus second order. First order is going to be your primary effect, right? Always going to be that thing that you're measuring, though. I can't think of a single case in which what you measure is not going to be, your primary effect. Your second order effects are going to be things like relativistic effects, coordinate system transformed effects, because they're going to be secondary. They're going to be of a smaller order of magnitude in the contribution compared to your first order. So, for example, our first order effects, our measurements that we're taking in this lab when we're measuring the angle and presuming that there's, a velocity on Earth, of course, it's presumption, but still treated as first order. That's going to be your first order effect, your direct stellar aberration due to your relative motion. Your second order effect is going to be when he does a Lorentz transform and applies relativistic corrections for velocities much less than c that have a tiny, tiny, tiny effect to the system overall. That's going to be second order. Relativistic effects are always second order, except in imaginary worlds where we attach like light speed velocities to things. When the speed of the Earth is 30 kilometers a second and the speed of light is 300,000 kilometers a second, any kind of relativistic effect you apply is going to be second order. It's tiny.
Yeah, so, like the things that Franco does in CERN, right? That's tiny.
The Earth
protons going at protons going at like 4/9 of speed of light or whatever it is. That's tiny, right?
The Earth is not moving at 4/9 the speed of light.
Yeah, so your brain is not moving. So
Peter, please don't do that. Please don't do that.
I've been listening to your delusional ramblings for hours now.
So
can you
tell me what I'm?
So if I can say something, I'm sorry, but it's not.
One second. I do want to hear from Galatrax. Pete, you look at you even up here right now, so you go put your hand up. I do want y'all to finish, but Galatrax has been super patient. Let's see what he got to say, and then we'll open it back up. Go ahead, Dr. Gala.
Testing 1 2. You have to unmute Gally.
Yeah, sorry, it still said muted. So I've been listening for about 45 minutes. I think we should be more appreciative of Franco. He's spending time with us on a Saturday to talk to us about science, experiments, and studies. Appreciate you being here, Franco. I will say I don't like how the ad nauseum repeating of stuff, where it's sort of like a really long diatribe and it's repeating stuff like, I did the math using what we know today. I think I heard that 5 times, and that was 5 times too many. The other issue I had was with how you guys repeatedly said that Alan and Piezo didn't know what a first order measurement was, but you guys are saying that before you asked them for their definition of it. So if you disagree with either Alan or Piezo's definition of a first order measurement, then what do you disagree with about their definition, and why did you say they didn't know what it was before asking them what their definition of it was? So basically, can you say how they defined it wrong, and like how it was wrong, and then which definition did you disagree with? And then that's one question. Lastly, I wanted to ask, did someone cite that there's a specific experiment that confirms or proves Earth's motion? Or did I mishear that? And if there is such an experiment, can you post that?
The direct experiment was definitely glossed over. I heard that too, Galatrax.
So maybe let's address the second one. So Piezo, could you, just to help us understand what you mean by first order measurement, because it's prudent to define terminology before debating, right? One risks a humongous misunderstanding if one doesn't do that. Could you give us an example of a first order measurement of a surface area of a rectangle? Go ahead.
No, it's actually too late for that because he gave his definition of a first order measurement.
Sure, but it was very complicated.
I'll let you finish. Hang on. You said he was wrong before he gave his definition, and now that after he gave his definition, I would like to know what issue you had with it. I don't want you to ask him a question. I asked you a question.
Good. I apologize. I was wrong. Piezo, could you please provide an example of a first order measurement of a surface area of a rectangle? Go ahead.
Do you have like a listening comprehension issue, brother?
Yes, I do. And I would really appreciate it if you could provide an example of a first order measurement of a surface area of a rectangle. Go ahead.
Dog, I just gave you my definition of of first order and second order measurements as they relate to stellar aberration.
Please provide an example, dog.
That we're talking about, Peter, in which you
then you should have no
insulted
problem.
me.
Then
Peter,
you should have no problem
Did you listen
in providing
to
an example. Yes, and I couldn't understand it, and I really require a very basic example of how one would measure surface area of a rectangle using only first order measurements. Please provide such an example. It should be trivial for you.
Peter.
Go ahead.
To explain to you how to use a ruler.
Well, for the audience also, this guy, Dr. Gala whatever,
he wants
also
you
to understand.
To stop being a child
ahead.
and poisoning the well and just answer
Provide an example of a first order measurement
Peter,
of surface area of a rectangle or a circle.
I'm not your child. I'm gonna control myself here. I'm not your child. I need you, if you want to get up here and act like that, after you've already had this explained to you, you've already been told the definition, and I already asked you, what was your problem with my definition? It's not my problem.
I couldn't understand
English.
I couldn't understand it.
That's not my problem that you have a cognitive impairment.
Well, you're one of the illustrious teachers, so please provide an example of a first order measurement of surface area of a rectangle.
Do not do that.
Peter.
Now,
Airy. So how do I use a ruler to measure surface area? First order. Go.
Oh my gosh. This is ridiculous.
How? Walk me through it.
How do you get a mic on this stage? How do you continue to get a mic when you act like this?
Well,
you're literally the most childish
Keys and I are BFFs. Hey, dude, go ahead.
We're trying to beat the echo chamber allegations. Go ahead, Piezo. Or you could just pass the mic to Franco, Peter, if you don't want to answer his question.
Well, I worry that Franco will continue to engage with those guys without having defined
Dude,
terms. Clearly, there was a
you have to
misunderstanding.
bring quality
But
to the
we asked you to
conversation, man.
determine what was wrong
Well,
with it.
here's
You
the
didn't explain
quality.
it.
I am humbly asking two of the illustrious teachers to provide an example of a first-order
Nah,
measurement of a
man,
surface area of a rectangle.
you're being purposely obtuse.
Dog, just
we were
do it.
already
30 seconds.
we were already mid conversation with Franco where he was
It's going to
agreeing
take
with
you 30 seconds, but he doesn't understand
stop
what you
interrupting
mean by
me.
first-order measurement, clearly.
Stop, dude.
No, he said he doesn't.
That he was literally, dude, you interrupted a conversation with Franco and Pizio where they were working that out and they were
Are
agreeing
you
on the
avoiding providing an example?
they were working out the
I think you
terms
guys are both
and
running
agreeing
away from
it
a
because
very simple thing.
they're both on the same page of what's being discussed. You coming in here and asking for the surface area of a rectangle isn't relevant and acting like this point is like,
First order
oh, I
measurement.
got you, bro. We're talking about light in a telescope. We're talking about
Yeah,
and we're talking about stop. We're talking about a measurement.
Take you 20 seconds.
Listen, guy,
to answer my question.
if you want to be a part of this conversation, you have to add quality to it. You can't be dog shit tier. What you're doing right now is dog shit.
It's not a conversation when you're refusing to engage on a valid question that helps advance the conversation between you and Franco. This was specifically an area where you guys misunderstood one another. Franco meant something completely different, but by first order. You meant something completely different. You have a chance to explain to me, to him, to everybody in the audience what you mean when you say first order measurement. And I'm giving you a trivial example before you tell us about telescopes and water and aberrations. Just tell us how you would measure the surface area of a rectangle using only first order. Let's go.
Ruler. I'll tell you what.
Ruler how?
I will answer your question if you will drop from the stage and not bother us again.
Okay. Yes. But one condition. I will be allowed to ask you a clarifying question if I misunderstood. And then I'll go. So,
oh my goodness, thank
again,
you.
first order measurement surface area of a rectangle.
Of a rectangle?
Yep.
So, well, we know that the area of a rectangle is length times width, right? Length times width, right? So you take your ruler, you measure the quantities of your length and the quantities of your width, and you multiply them together, and you have your surface area. There you go.
So not a first order. You performed a calculation.
No, Peter, it's first order. Did you not hear the definition I just gave you with regard to
So explain how it is first order.
Because the controlling quantities for your calculation, the ones that are primary, the ones that have the greatest magnitude of effect on your calculation, on your result, are length and width. In this case, there are no other factors. There are only first order quantities involved. There's no such thing as a second order quantity in the surface area of a rectangle.
Okay, now point out where, and now I'm going to go as promised. When I'm gone, please tell Franco where he didn't use first order measurements.
And here, just to clarify, your direct measurements that you make in the lab on the rectangle are your first order measurements. As I said, I really can't think of any examples in which your first order measurements are not going to be the measurements that you physically take in the lab. Can't think of any examples of that. But in Franco's case, right, he is calculating relativistic effects, right? He's doing
like you were calculating surface area.
Please don't interrupt. Surface area is a direct relationship. You're doing a Lorentz transformation of terms that get neglected for the first. Stop, please. Stop, please. The relativistic part gets dropped. It's not relevant, and it goes back to the first order. And you're invoking the first order. You're imposing. After that, you're then imposing the first order variables on a fictitious reference frame. Now that's second order inherently. Now we can continue.
Everything Franco does is logically equivalent to you applying the known relationship between the sides of a rectangle to calculate surface area.
No. As I said before, and I'll say again, and then thank you for dropping from the stage, the relativistic effects, the relativistic corrections involved in Airy's experiment are negligible due to the difference in the velocities of Earth that's supposed and light, 30 kilometers a second versus 300,000 kilometers a second. They are off by a vast order of magnitude, such that the relativistic corrections employed are about 2/10,000,000ths of an arc second. They're within 1/10,000th of a percent that of the classical corrections. These transformed corrections in a transform frame due to relativity are always going to be second order or higher. They're never going to be first order. There's no direct measurement of them. They don't play a leading role in anything and are not first order and never have been and never will be. In fact, they don't exist.
Thank
but
you.
There you go.
Thank you. I wish you a good night. And tomorrow we all wake up to a new day on the flat Earth. Good night.
Thank you for honoring your agreement. That is
So
that is
I did
honorable.
have a question. I did miss it, but did someone cite there was a specific experiment that confirms or proves Earth's alleged movement?
No, there was a generalized statement by Franco that you need to stop living in the 1800s and get with the modern times because there's been a number of modern experiments. And then Alan asked him which ones, can you name one? And he didn't really do that. He just kind of flustered himself, but he didn't actually name one.
Okay, so does the room agree or does anyone disagree that that there's no experiment that confirms or proves Earth's movement, or does someone have an experiment that confirms or proves Earth's movement?
And Franco's the man with the
Well,
task at hand. I mean,
I think a really good analogy would be similarly to how you use the ruler to get the surface area, right? In the same scenario, they were using the water in the telescope as the ruler, right? And they were trying to measure a velocity. So imagine you took your ruler out and you predicted that you were going to measure something that was 6 inches long and you have a 12-inch ruler. So you've got the exact amount of, you can definitely measure this, right? Then you go to measure your 6-inch measurement and it turns out to only be 1.5 inches. And you're like, well, if I transform to a reference frame that's not even on Earth and I look at it from a different perspective and I add I add a length component to it because I know the length is actually 6 inches, I can make up the missing value. That's what's being done here mathematically.
Yeah. I mean that's presumptuous though. That presumes a thing and then seeks to prove it. It's a hypothesis.
Yeah. But anyway, Franco, you got your hand up. Did you want to? Did you say you had the experiment on site?
No, I don't want to discuss that. I want to discuss what we were talking about, meaning the change in angles and in this case.
Franco, I'm burnt out, honestly, bro. Like I refer you to the Obsidian database that we put up in the Jumbotron. We have the
number. Let him finish. Pizzo.
Sorry. I was just saying I'm done because I was mostly the one engaged, and Alan's free to do it. My bad, man.
Okay, so according, just to go back to what is first order, not according to me or you, but according to the science community, first order means first order in some small parameter, meaning that there's in this problem or topic that we're talking about, there's some number which is a dimensional number. Doesn't have to be it must not be a dimensional number. It must not be a dimensional quantity. It has to be a ratio between the two quantities. So a pure number that is much smaller than 1. And you have this small parameter, and saying that something is to nth order, it means nth order in this parameter. So there's no such thing as a first order measurement, full stop. First order measurement in one small parameter. In this case, we're talking about first order in the small parameter being the it can be two things in this particular experiment, in this particular case that I dealt with in my calculations. And there's two things that can be small. One thing is the ratio of the Earth's velocity or the telescope's velocity in one of the frames considered, and with respect to light, so we see the beta factor in the Lorentz transformations. This is a small parameter, and you can expand the results, expand the results as polynomials in this small parameters. And first order means that you stop at the first power of beta. Second order means you stop the second power of beta. Third order, third power, and so on. So this is what is meant by first order. Then the other thing that can be small in this case is the angle between the incident light, and the surface of water, and the normal to the surface of water, which in this case, in the cases that we dealt with, that I computed, is small in the case what I call Airy-like case, not in the Fizeau case, because in the Fizeau case the angle is 90 degrees, so it's not small. So that what is meant, that those are the two possible parameters. In the Airy case, the beta, which is the ratio of velocity of Earth with respect to light, and the aberration angles are basically the same order of magnitude. So they are actually related by one of the is the sign of the other, and something like that. So if one is small, the other one is small, and so you making first order approximations of the results in beta is the same as making first order approximations of the results in the angles. As to Peter's question, the way I would have answered it is it doesn't make sense in my definition, in the common definition of what is first order, to make a first order measurement of the area of a surface area of a rectangle, because you do not specify first order in what. So if it's for example, first order in the precision of the length of the uncertainties on the tolerance of your ruler, saying that you measure lengths with a precision of 1 millimeter. So you have that you measure one side. You say it's 6 centimeters plus or minus 1 millimeter. Then you have that you have the uncertainty is 1/60th. That is a small number. And then you have you measure the other side, which is 5 centimeters plus or minus 1 millimeter. You have 1/50th. So you have that you multiply the area is 30. If you make the calculations, it's actually 30 multiplied by 1 plus 1/60th multiplied by 1 plus 1/50th. This is the maximum error on the area. And if you want to express that to first order, you just neglect, you compute the 1 plus 1/50th times 1 plus 1/60th, and you get 1 plus the sum of 1/50th plus 1/50th, and then the product of the two. Stopping the first order means that you neglect the product of the two small numbers, which is a second order effect because it's a product of two small numbers. You stop to the first power you stop the polynomial in small numbers is stopped at first powers. You neglect second powers. This is what is meant by first order. In that case, but you have to specify first order in what? In the precision of the length measurement of the sides. In my case, the calculations doing with Lorentz transformations have a linear term, actually a first order term, because if you look at the way the parallel component of the wave vector is transformed, it is the parallel component of one frame multiplied by gamma plus the frequency multiplied by beta multiplied by gamma. So and there's a C factor somewhere takes into account the dimensionality. And this term is first order in beta. Sorry, beta gamma is a term that is first order in beta. So what you do is you have a change in the parallel which is what changes the angle. Is exactly this is the addition or to the wave vector of a component which is perpendicular to the original one, and this is proportional to the frequency. And this you only get if you use the correct transformations. If you use the classical ones, you don't get it. If you transform a plane wave, if you take a plane wave, such as waves in ripples on the oceans, and then you move. If you move perpendicularly to the waves, the wave front will still be coming perpendicularly to you. If you do the Galilean transformation, so you don't get the correct answer if you only do the Galilean transformation to wave vectors when moving at a certain velocity, even to first order. So that's why I use the correct ones, and then you take the limit. Beta approaching 0 and gamma approaching 1, and only take, but taking the limit doesn't means that you only take the first order terms in beta, and you neglect the beta square and higher exponents. So if you look at my calculations, they are first order. What I'm saying is that it's not the same as the result that you are getting, even to first order, because to first order they agree in vacuum, because you have the angle. I say the sine, you say the tangent of the angle is beta. To first order in beta, sine theta equals tangent theta equals theta. So to first order, they're all the same in vacuum. Not in vacuum, we get different results because I get sine theta equals beta divided by n. You get tangent theta equal theta multiplied by n. So even to first order, they're different, because one is that the angle is theta 1 times n, it's beta times n, and in my calculation, to first order is beta divided by n. So get two different first order predictions. So if your claim is that mine is wrong, I urge you to tell me where it is wrong, because what I did is to transform waves moving in a dielectric medium, and this is the correct way of doing this, not using them as particles, because you don't treat light moving in a medium, in a dielectric medium, as a photon. It's not, because the form momentum is different.
Frankel, would you do the same transformation if the Earth was stationary?
Yeah.
If the Earth is stationary and the star is moving, you can compute. If the Earth is stationary, with respect to what? For God's sake, what I'm dealing with is to see how light transforms when when changing between two frames.
I want to hear this. I want to hear this.
And then you can decide who is stationary with respect to whom. I did the transformations to see what happens to light when transforming to a frame where light is where the water is stationary.
Right, but would you have to do that if the Earth was stationary and the starlight was in motion?
Yeah, it will be the same. Because you know, I only know what happens. I only know precisely what happens when light crosses from vacuum to or air, because it's really negligible, the effect of it being air. From vacuum to water, I only know what happens with certainty when the water is stationary, in the frame where the water is stationary. If you want to know what happens when you change between frames, then you have to first compute it in the frame where it's stationary, because I know in that case what happens, meaning the Snell's law and the water and the light goes at the velocity is reduced by a known factor. And then what happens when you move, when the water is moving, you have to know how to compose velocities, and which was not known properly.
But what if it's not? What if it's not moving? What if it's not moving?
If it's not moving, it's just Snell's law, and that's it.
No transformation is necessary.
Yeah, why would it be? Then why would you have an aberration angle at all?
Because the stars are moving.
Because the stars are moving, yeah.
So look, Franco, what you said earlier about first order effects and transformations, we should go back and touch on that. So what we're saying here, right, these first order effects is the velocity of Earth over the velocity of light. That's going to give you a ratio to an angle that's going to be 20 arc seconds, right? And when you measure that in air, that's what they say they measure the angle to. And they're like, oh, no way, right? This ratio, this first order effect gives, and the effect being like Earth's motion, right? Like the causal mechanism, right? So it's directly proportional in V over C, right? So we got this first order effect. And now we're going to introduce water to see if the causal mechanism is the same, because we can't change Earth's velocity, right? And when they do that, they find that there's no angle change in the first, like this is all first order, right? In the lab frame, right? No transformations yet, right?
Small one, but not enough.
What's that?
A small one,
I'm claiming it's not what is predicted in any theory.
What?
I showed you the calculations. You do not predict that. It depends.
Listen.
Okay.
Yeah, when you do it correctly, that is the prediction. And when you add the gamma factor to make it relativistic, it agrees with the classical equation to 2/10 millionths, or 2/10 millionths of an arc second. So they're equivalent. That we without even transformation yet, or transforming yet. Now you're saying that if you assume that the Earth is in motion, and if we invoke a fictitious frame, like who's in the photon frame that can measure the inverse for this, right? What you're proposing is by assuming the velocity component is true and transforming and applying that same lateral velocity component, that you're going to make the angle be the same. And you're conflating that with first order. That's not the same, because the gamma factor components all cancel out and we're using the classical approximations, right? Like there's no link contraction and time dilation happening. That's not what we're saying, right? And as you corrected me on before, link contraction and time dilation are a function of the square of a velocity over c squared. So these are second order effects. They're never proportional, right? If you take something like the Sagnac effect or the timing delay in GPS that derives distances, that measures a variance in the speed of light that's directly proportional to a velocity, that's first order.
Can you please look at the equations I wrote?
Yeah, we looked at them and went over them with you, dog. You're just saying the same thing on repeat with your custom transformation.
K parallel kx is changed to kx plus beta omega over c times n, or divided by n. I don't remember. It's the equation there. I don't have it in front of me. It's the equation that gets a first order change to the parallel component of the wave vector, which is the same thing that you want to do when you say that the prediction.
Are you in the lab frame or no?
There's an aberration angle. Where does the aberration angle come from in your prediction before knowing relativity?
It comes from the
Where
stars.
Does it come from?
The stars are in motion.
The stars are in motion. So there is.
If the Earth were in motion, when you introduce water, the angle couldn't possibly be the same. These are two mutually exclusive predictions. You can't transform to the photon frame and like dynamically or treat the Earth as stationary when
There's no
dynamically in
such thing as a
heliocentrism
photon
it's
frame.
moving. It doesn't. I'm sorry. I keep calling it the photon frame. I mean the wave frame, because you're doing it through the wave transformation. Sorry, I meant the
Light
wave.
frame.
Yeah, the light frame. Thank you.
How do you compute the angle when you assume that the motion is the motion of the star and not of the Earth?
The same exact way you do it with the assuming that that it's the Earth, because it's just a measurement. It's just an angle. The measurement alone can't tell you if the sky is moving or if the Earth is in motion. That's why they introduced the medium to slow down one of the velocities that they could manipulate. There's only two velocities in this first order equation for the angle change: velocity of light, velocity of the Earth. Can't slow the Earth down, right? But we could slow water. We could slow the light frame down in water.
Yes, but how do you determine the angle?
By the ratio of the two velocities, you take the arctangent of that, or you use the relativistic formula, which is going to agree within 2/10 millionths of an arcsecond. They're going to give the same result. So you use one of those two formulas and you're good.
No, what I'm saying is that when you use it in water, if you use it by taking the tangent of the angle is what? Say it again.
Tangent theta. Do you want the classic one? Because like I said, the classic and the special relativistic ones agree within 2/10 millionths. So you might as well just use the classic. It's easier.
Use the classic. Yeah.
Tangent theta equals v over c.
Where v is what?
The velocity of Earth.
Yes, but this is in vacuum. What about water?
When you use water, you change c to 3/4 c.
Yes. So the angle will be?
So the angle will be 4/3 of the original angle.
What I claim is that this is wrong, because if you do it with wave vectors instead of velocities, the angle is 3/4, not 4/3. That's a first order disagreement.
Either way, I mean, I have never seen a single source in any physics textbook, on Wikipedia, on LibreText, anything that says stellar aberration, right, would decrease, right, if the speed of light decreased, right? Because think about it. If you're dividing by a smaller number, then your result becomes bigger, because the speed of light's in the denominator. So if I have, let's just say I have 10. If I divide it by 2, I get 5. If I divide it by 1, I get 10. The smaller the number I divide by, the bigger my angle becomes. But even if you were right,
because you're doing the wrong calculations.
Okay,
what you have to do,
bro, it doesn't matter even if you're right.
It's not a velocity. You have to compute how the wave vector changes its direction.
But
the wave vector does not transform by adding the velocity component. That's what I'm claiming. You're doing the calculation wrong. You don't have to use.
Even if you're right and it's 3/4 instead of 4/3, which I would grant you just for the sake of brevity, but I don't really agree, but it doesn't matter. Even for the sake of brevity, I'll grant it to you. It still doesn't match what was observed, and that is the problem. There was not an observed angle change, or there was a very, very tiny one, rather.
Again, that would have
to be one.
Then that would have disproven Snell's law.
It also disproves it. No. Franco. With or without Snell's law, follow me here. With or without it, you still have to deal with the change in angle due to the relative motion part. And the relative motion equation, which is the aberration equation. The equation I just gave you is for aberration. Your equation is Snell's law. It's a refraction. There's a different equation for refraction than there is for aberration. But aberration still stands on its own whether or not you add refraction to it. The aberration was not satisfied. If you add refraction to it, it gets even worse. So it just makes you're actually making the case stronger for us.
No, if you
That's why I
please,
asked you, Franco. That's why I asked you, like, could you do this from a stationary Earth with the stars in motion, and would it be a similar value?
yes.
Right. So we don't gotta disprove Snell's law. We don't gotta get rid of it if the Earth is stationary. You gotta get rid of Snell's law if you need the Earth in motion. Which one are you gonna choose?
So sorry, I'm not following this. Let me go back to. I'm not following this. Let me go back to Pierre's. I think it was him. Objection. I'm not adding Snell's law to the aberration effect.
Well, they're separate corrections.
What I showed in my calculation is that they're the same. They give the same result. If you apply this correct rule for the aberration angle, you get that in the frame of the telescope, you get just Snell's law, independently of the fact that the Earth or the star were moving. Light is coming at an angle of 20 arcseconds.
You don't need the transformation.
With an angle which is 20 arcsecond multiplied by 3/4. That's the prediction of both Snell's law and aberration. They are consistent.
You don't need transformation though.
Franco, you can't say that they're the same when you didn't actually put numerics in. We literally have screen.
You look at the calculation and the formula give the same formula. So I'm saying that I'm predicting the same thing.
I want you to plug in. This is what I want you to do next time. Plug in. Take the stellar aberration formula. Okay. Then take the Snell's law formula. Plug in the numbers for both and see if you get the same number for each. You don't. I already did it.
I say I calculated the formula. What you're saying is that I got the formula wrong for the aberration, right? This is what you're saying, because if I did it wrong, if I did it right, if I calculated the aberration formula in water, it's exactly the same as Snell's law. It's exactly the same in formula.
What are you saying? What are you trying to say? Are you trying to say that the two offset each other? What is your claim?
I'm trying to say that they give the same prediction.
Wait a second.
I've said it a number of times. I said that.
What does that mean? How does that help you if they give the same prediction? I don't understand how that is relevant to the point of Airy not measuring an angle at all.
Because my prediction, which is based on first principles, which is relativity principle, is that the telescope doesn't in the telescope's frame, which is on Earth. The telescope does not care. I don't know if I don't care if you are laughing about my giving a telescope a personality. The telescope does not have any way of telling whether light is coming from a moving star or a moving laser or a spaceship or someone flashing a torch to it. The telescope.
You already give the causal mechanism.
Just reacts with Snell's law.
You already give the causal mechanism when you say that motion of Earth is causing an aberration in the first place. That's your first premise.
Yes.
Do you think that there's a disconnect here because you can't simultaneously, right? Because we're not just talking about kinematically looking at this. Once we introduce the water, there's that dynamic asymmetry we were talking about. Like on the Earth side of the system, you've got this like tube of water, but on the star side of the system, you don't. The entire path from the star to the Earth is not filled with water. There's only a small section filled with it, right? And that's what the telescope's at. So you can't say that the Earth is in motion and then also do your calculations as if the Earth was stationary and say that they become valid in a transformed frame. Dynamically, only one of those can be true at the same time. You can't simultaneously be like talking both sides of the argument. So you have to pick one and stick with it in order to do your calculations.
No, that's precisely the relativity point. You can either Galilean or Newtonian or Einsteinian. You can make computations in whatever frame you want, especially if they're both numerical.
You already agreed earlier, and you haven't recanted because obviously you do agree that the angle would have to be different with the water included versus with the water excluded, and I feel like you're just talking past that for 2-3 hours now. Like we agreed, if you add water to the telescope, the observed angle of the starlight will change. And you said it will change in accordance with Snell's law and the aberration formula. We are specifically telling you we agree it would have to change, but it doesn't. That's the contradiction here. It's the fact that historically, as documented in history, the astronomer royal George Bedell Airy did this experiment, and when he measured the starlight, it did not change positions.
Right. So like if we went back to the paper, Franco, and it said that 3/4, 4/3, whatever he was arguing, I forgot which one you were saying. And it said like, you know, it matched, then you would have a point. Because you're like, look, it matches, but it doesn't match.
I will say for the last time. Okay, my prediction is that the observed
That's my final word.
If it's reports, it means that even Snell's law was proven wrong in 1850, and people have used it and continue to use well into the 21st century without realizing it's wrong. Okay.
No, it's not. It's not that. It's not that. Because we also said too the possibility that the Earth is stationary.
Even if the Earth is stationary, it would have to obey Snell's law. So if the angle is not measured to be 3/4 of the incident angle, then Snell's law would have been proven wrong in 1850.
1871.
Well, luckily for us, it wasn't.
What happened? Was it proven wrong?
Nope. It's an agreement with the stationary Earth.
I don't care about stationary. I care about if you say that results are different, it means that the incident angle in water is not 3/4.
You keep saying if. You keep wait. You keep saying if, bro. It's not up for discussion. There was no measured angle. Like that's a fact. You keep saying as if it's like a theoretical thing. Like if it was like this, Franco, he didn't measure an angle. Period. There's no discussion.
Then he disproved Snell's law. That's
Okay, nope. He disproved the velocity of the Earth.
Because you just said that without
you like logic, right? Like if the prediction is it should obey Snell's law, and if the Earth is stationary, it should obey Snell's law. It doesn't. So
it does. It does.
Ergo, Snell's law, it is wrong. This is the conclusion.
Nope. It does obey. Like where are you getting that from, dog?
The conclusion is that you think that there should have been this angle measured, and it wasn't. We don't throw out Snell's law. We say maybe there could be some other component that needs to be accounted for that's causing that angle deviation to be brought out of the system, such as an ether wind, etc. Right? Like you have to. We independently know Snell's law can be proven to be true through all of physics. We also independently know George Bedell Airy did not measure a deviation angle in his telescope. Both of these we know independently are simultaneously true. How do we reconcile them? In order to reconcile them, we have to bring something else in, such as Earth is stationary and there's some unknown component external to the system that's also affecting the light. That's the only explanation that is valid. You can't say Snell's law is invalidated because we know independently it's valid. We also know independently Airy's telescope measurements didn't show the angle change. You have to reconcile these. You can't just cog this and freak out and say, well, if it was true, then all of physics would be wrong. Bro, it's what the measurement was. It's established in history. He did what he did. The telescope said what it said. Like, I don't know what to tell you.
Yeah, like the same way, Franco, the same way that you're saying, oh, they must have thrown out Snell's law, right? Is what they say with the actual, challenge or mainstream narrative saying, oh, well, if the Earth is stationary, they would need an ether. So that means the ether been debunked. It's like the same type of mind frame. Oh, we should just get rid of Snell's law. Oh, we'll just get rid of the ether. That's what they're doing now with that. And it's really just about the motion of the Earth relative to the starlight.
Yeah, like I can hear the gears turning in your brain, brother. Like I understand that like you're realizing the pigeonhole that the mainstream paradigm is in because you can't give up Snell's law. Like ludicrous statement. Like you spoke it out because you know it's ludicrous. Like no one's claiming that, right? But you're like, well, to use that as a justification because you're going to stand on the strength of Snell's law. So what you're actually trying to do is call into question the experiment. But the experiment never called into question either. It's established and well recorded in history. Both the experiment is valid and it's valid. So the only way you can explain it is by finding an explanation that with both of those. Anyone that's going to do that, man, is and has an ether
Not hearing anymore. Sorry.
Yeah, because you kind of was choppy. He dropped out. He'll cycle back up. I think Beast had his hand up. Beast, you want to chime in real quick?
Peace. Look, I just wanted to say, from the last 2.5 hours.
Is that cosmological?
Yeah. Oh, I thought that. I'm sorry. It was. I thought you said me. I'm sorry. I just wanted to type in something else.
Oh yeah. I just seen Beast with his hand up.
Oh, you good? You good? Well, while I'm here already, just go ahead and get it out because this ain't gonna take long. I'm not alone.
Okay, you got.
I do want to pay respects to Franco. First time ever that I was able to do it because he's a good sport. He's not acting like this. Whoever he is, somewhere in the chat.
Yeah, definitely better around Mike and then
classical framework. Can you? Yeah, he's stuck in this like classical framework of a primal axiom of academia, and he sees it. I honestly know this man sees this, y'all. Okay, and out of no disrespect towards him, it's something for someone not so credentialed to bring him something that he's never seen. That's what this is about. Secondly, Alan, keep doing what you're doing because they're going to have a photon framework. All right, I'm just letting you know. Because people like you are going to, pave the way to push all the unfalsified Jordan out of the way, and stuff like that with a photon framework is probably going to become mainstream. And they can't say maybe, PZO. They got to say gotta be, like dark energy and dark matter and stuff like that. So basically, that's just what I wanted to say. The last 2 hours have been so frustrating because this man is very intelligent, very intelligent. And for him to just wave past 3 times, I heard him say, well, I don't know what you're talking about. I have no idea what that is. And then he goes back to a framework of academia that really and truthfully can't even associate to the different points that y'all are trying to put in front of him. And what y'all doing is y'all putting a whole different way of looking at things because what y'all done is y'all taken everyone. See, I know I'm going to jump around, but Franco has seen certain frameworks and he's probably been decompartmentalized to a certain, area of that certain field. And that's what Mr. Bennett was telling us. We've been so decompartmentalized and dumbed down. And I'm not saying this out of disrespect because to be dumbed down is just we didn't know. Okay, we're ignorant to the fact, but we're learning now. And what I wish Franco could understand is we are paying attention not to just one field and not to just one argument. Truth is a frequency, Franco. And I say this with all respect. And I hope that you can hear what I'm saying with the most open mind, because I think you have a good intent because you don't throw ad homs like this other guy. And I think that there's something here because the way you carry your conversation out. Now, I believe that you're in a place where you really can't accept it, but you see it. And besides that, PZO, what you can do, what Alan can do, Sacred, you are getting like spot on, brother. And I'm going to tell you right now, Proud, the mediation you do is A1. And the points that you bring to the plate, Run Boston Bear, awesome. I haven't heard from you tonight, but I'm going to tell you what, PZO, you have analyzed the framework behind every aspect of how you can explain it on the most remedial friggin' level. And for them to just hand wave dismiss the most perfect factual explanation that is so crisp and just like basically logical. That's the thing that these academic scholars don't have, folks, is what we got to remember is the logical aspect. They're stuck in gotta be, okay? And we're in the maybe. And when you stay in maybe, anything can really be found. And when you're standing in truth, it's a frequency, okay? And it's undeniable. That's why when PZO goes to explain it, he doesn't stutter through his words because it's fact. Alan, you can calmly and assertively put the facts out because they're facts, and you don't stutter step through them either. You can see when a person's at fault when it comes to a conversation of intellect, because if a person doesn't know what they're talking about, they're not going to be able to talk about it. And the thing is, all we have to do is keep doing these conversations because the people like Franco that is interested in what we're seeing, is at the forefront of all this too. So he has an opportunity as well, unlike this other Rob, whatever this guy's name is. But I just wanted to say that Franco, look, keep showing up because it'll be undeniable. And I believe you see some of this stuff because PZO, he's not in Alan, they're not just in Shane, they're not just run of the mill scientists. And I'm not going to try to blow them up, but along with Austin Whitsitt, this panel has got some savant attributes to it because they've taken these abstracts and they have dissected them to the molecular. You know, metaphysical is a word. It's a bunch of physical little parts on a meta level. But this stuff that we're talking about, Franco, it's spiritual. That's why it's not quantifiable. Okay, to certain frameworks of the materialistic aspect of nihilistic, you know what I'm saying? But let me get out of here now because I'm going to ramble on. But I just wanted to tell y'all, thank y'all so much. This is so mind blowing. These conversations are so next level and they open up the mindset into different inspirational kind of like frameworks. So it's awesome. Thank y'all so much for what y'all doing. Y'all motivate me. I made myself stay up because this is one of the most interesting conversations I think I've had. PZO, I want to tell you, explaining about the ratio between the Michelson Morley and Airy's failure, that mutually exclusive viewpoint is awesome. Dude, I was jumping up and down when you explained that, brother. Thank you. Y'all keep doing what you're doing because it's undeniable. God bless you all.
Yo, cosmological, my God. Wonderful assessment.
Thank you for the kind words.
Yeah, don't be too nice to me, man. I appreciate it.
Y'all good. Late night at the tattoo shop, man. I got home and I walked in on this conversation with Franco and PZO putting just the basic logic out on how to see this explanation. And that mutually exclusive point that you were making about those two different things is like, dude, I was jumping up and down in the living room. But anyway, I'm gonna fall back, y'all. Thanks for letting me speak. Sacred, bless you, my friend. Proud, PZO, Alan. And I haven't seen her run or anything like that. No. But I'm gonna fall back. God bless y'all. Y'all have a good night.
You too, man. Did you guys lose me at the last thing I was saying? Because like it started to crash and bug on me.
Yeah, if you can't finish your thought, it was a kind of roboting. Shout out to the robots out here. And after that, we slide over to
my browser memory leaked. I had the task manager close it and reopen it. I don't know what happened, but anyways, yeah, I think I was speaking to Franco. Yeah, man, we enjoy having you here, man. I think in retrospect, maybe I should have went this angle at the beginning, this avenue at the beginning rather than now. But it just like struck me that, oh my gosh, there's this huge disconnect. This whole time we're speaking in theoreticals and ifs. Like, why is there an if? Like, dude, he didn't measure an angle. Like that's the observation. Experimentum summus judex, Franco. Like, experiment reigns supreme. We have the measurement. It's established. It's a fact. Snell's law is also valid. Both of those are valid. So now the job is to find a framework which can incorporate both of them at the same time without a contradiction. And heliocentrism cannot do that. Earth in motion cannot do that. You have to have a stationary Earth, and you have to have some external source that's incorporating velocity into the starlight. That's the only way. But it's my 2 cents. I think you got a little bit of it, but I just want to make sure it was reiterated because this is what he measured. We're not talking if people. We're not saying, well, if that's what happened, then he would have violated Snell. No, dude, that is what happened, and Snell's law is not violated. We know those are both simultaneously true, so figure it out.
Yeah, Franco, I'll let you jump in here in just a second. I just want to make sure that everyone get a chance to chime in because it was definitely a nice, valuable, long build there. Beast, what you think?
What's up, everybody? Sacred Proud, thanks for
Yo, I'm gonna reconnect
hosting.
real quick. I'll be right back.
For sure.
The robot thing is killing me.
Yeah, I don't know if you robotic future or something. But yeah, just want to reiterate. Thank you, Franco, for at least coming and giving it a shot. If it's out of the lab frame, then who measured this the star frame? Like, who was over there? No one. Like, you can only use the lab frame. So anyway, just wanted to say what up to everybody, and yeah, great conversation.
The almighty Labby.
The lab frame. No, I'm sorry. The lab frame. My bad.
Glad you enjoyed, Beast. We keeping it moving. It's stationary Saturdays, you heard? I think it was Axel, and then we'll slide to Lynn.
Yeah, sorry, I'll try not to be very long.
Don't be, man. Nah, good to see you.
I guess I just want to see if I want to clarify what's going on here a little bit. I was listening to this for about an hour, and I was listening a couple weeks ago, and you guys are talking about the same thing. All right, so everyone agrees that water in the telescope doesn't change the stellar aberration, right? We're not arguing about that.
It didn't physically do it, no.
Correct.
Okay, so the argument. So the I guess argument's a good enough word. So the argument is that if the Earth was moving, that wouldn't be true.
Correct. It would have to change.
Okay, that was all I wanted. I wanted to just clarify those 2 points because I was a little unclear what exactly the conflict was about. That was it.
And, that was actually a really good clarifying question because sometimes these conversations build from other weeks. We may have some new listeners. I forget to do that sometimes. So thanks, Axel. I appreciate that. But what do you think about that? Like, what you see that as a important implication?
I mean, I'll confess, a couple of weeks ago when you guys were talking about it, I looked into it a little bit, but I am not a physicist myself, and I didn't get a very satisfactory explanation from what resources that were available. And I'm afraid the mathematical physics of optics are more. I'd have to spend a long time brushing up on my physics in order to be able to solve the equations myself. I will just say that obviously this would be a challenge to relativity because one of the core concepts of relativity is that there really isn't any such thing as being stationary / you can declare anything stationary and all the equations work out the same way, at least as long as you're talking about things that are going slower than the speed of light. So, but I don't have a strong opinion about exactly what the math says. As I said, I looked into it and I was like, well, this is too complicated for me to understand. So
what about the logic behind it, right? Because if you could treat everything like it's stationary, right, and if the Earth was moving, you could just treat the Earth as if it was stationary within that same frame, then there would be no aberration.
There'd still be aberration because the stars would be moving relative to us, right? So,
but yeah, there wouldn't be any change when you introduce the medium, though. Rather, but yeah,
right, with the medium of water, right?
Mm-hmm. Yes, but I think the contention is that if the Earth is moving, you still don't have. Well, as I said, you can't tell if you're moving or not, and so I don't think that it would seem odd to me that you get around that by filling a telescope full of water. If there was really a way to determine absolute non-movement in some sense, I mean, that just isn't a term that makes sense within special relativity. But I'm not trying to. I know what you guys believe about it. So that would be my resistance to the claim. But as I said, I don't have a good counterclaim on the specifics of how this apparatus actually worked, because as I said, the math's a little too complicated for me, and so I would just end up defending it on larger physical principles, which it doesn't seem to be what this conversation's about.
Very self-aware, man. I will give Axel that. Very self-aware.
Yo, Sacred, I just wanted to mention real quick. I almost forgot when I was up here. Galatrax still wants that source. by the way. So now that we kind of
Oh
calmed the
yeah.
conversation down, if Franco could provide that source that actually shows Earth's in motion, right? This assumed Earth motion, please provide it. Thank you.
Franco, you remember what you told us?
Sorry, say it again.
The experiment. You referenced an experiment about the Earth being in motion. Galatrax was wondering if you had a link that you could drop for us.
Well, I'm not an astronomer, but I know that stellar aberration and parallax and things like this, and even the and yeah. Why are you asking me things then if you're going to scoff? And then
I'm sorry, I apologize.
And then I know about I know CMB dipole shape. The dipole component in the cosmic microwave background. There are a number of experiments, but this is not my field, so I cannot just.
So you don't have it.
It wasn't a scoff, Franco. It was more like a laugh. But when you said like multiple experiments, you were just talking in jest. You weren't specifically talking about something like worldwide and known.
I thought you were
the multiple experiment I was talking about is about relativity is about special relativity being right, and then this my whole, as I'm saying from day one, my whole field is counting on special relativity every single day in every single calculation we make.
Franco, can I ask you a really good faith question? This is not really a debate thing. I actually do want to ask you a question, man, like on a personal level related to what you just said. So like, don't feel like I'm trapping you, because I give you my word I'm not. So like, you listed stellar aberration, which is actually the entire subject of our whole discussion tonight. So, I don't, clearly, since, the observations didn't match the predictions based on Airy's experiment, you can't, Airy's experiment was something that was supposed to dynamically confirm stellar aberration. Prior to that, they just had this, kinematic model, but they didn't have any mutual exclusivity to it. So he had the chance to prove that, and he didn't. So you can't really use aberration. Parallax is not mutually exclusive. If someone was to show you a presentation, like if you were to look at it in a geocentric framework and realize that it's equivalently valid in a geocentric framework, would you ever be open, right? Like if you were to go one by one through the supposed proofs of Earth's motion and realize that not a single one of them are mutually exclusive, this is my question, realize that not a single one are mutually exclusive to an Earth in motion, that they would all be equally valid to an Earth at rest, would you ever consider potentially changing your position and believing that Earth is at rest, in fact?
My position is that I'm a relativist. Relativist, I don't know how to say, I have way to put the stress. So this is what I was taught even in high school. Every frame reference is legitimate. You can take any frame of reference. The difference between choosing one particular frame of reference with respect to another is that the dynamical laws can be much more convenient and much more simple if what physics says is if the frame you choose is an inertial frame. So the point is what the explanation would be of how things are moving with respect to Earth. So if I see that all stars have a parallax motion and an aberration dependence, which is annual, I'd have to find a mechanism for which all the stars in the universe, all the stars that I'm observing, all in our galaxies, are moving around us with a period which is 1 year. and things like that. And I'm sure there's a number of many other observations, cosmological and astronomical observations, which are in agreement with the current model. Of course, you can describe everything with taking even your own house as the center of the universe, or your own, I don't know, sink in your kitchen as the center of the universe, and then describe everything starting from that, measure all distances from that, and so on, and all movements and all motions with respect to that. Okay, the problem is having a dynamical model which describes what you observe, and people have been.
That's only if the bodies move relative to that observer, though, Franco.
Yeah.
It's not that the bodies don't move relative to that observer.
Yes.
The bodies in the sky do move relative to the observer. So yes, you're right. You can do this from a geocentric.
You have to explain in a model why this happens. So that's why people switched from geocentrism to heliocentrism in the 17th century, early 17th century, because the model was much simpler. And
because if the masses in the cosmos was spinning, that would account for a perpetual universe in motion.
Sorry?
If the masses in the cosmos were spinning.
Yes.
That would cause a translation of motion, and that would create a perpetual motion of the universe.
But he's saying that you would have an equivalent dynamic result if the universe was rotating around the Earth as compared to if the Earth was orbiting through the universe. He's saying that you would get the same forces imposed upon the Earth.
They're exactly the same description. Only in one of the two descriptions, you have a complicated way of describing the dynamics. That's the thing, and it depends on in some particular problems, it's more convenient to have a frame which is stationed with respect to Earth, same as it's convenient, to have a frame which is stationed with respect to your car when you're taking a sharp curve. It's the car moving with respect to Earth.
But
in your frame, in the frame of your car, and say, okay, here I can explain things, but I have to introduce centrifugal force and so on, and sometimes it's convenient to do that, sometimes it's not. For the whole, it's not too.
But
all right, last thought, Piezo, and then we're going to go to Lynn.
My question wasn't asking you to justify your position as valid or not. I was just wanting to know if you were to take all the supposed proofs of this is exclusive proof that the Earth is, in motion, and one by one, you were to find out that they were not, in fact, exclusive, that they would all actually work in a geocentric framework, and that there were also even certain situations in which people introduced dynamic asymmetries, such as in Airy's telescope with water, Newton's bucket, etc. And there were these experiments that actually went against the idea of motion. Would you ever consider, right? I know you're a relativist, I know what you believe now, but I'm saying in the light of evidence, right, that showed that the position of a stationary Earth was actually equally, if not more valid than a motion or an Earth in motion, would you consider changing your position and believing that the Earth is stationary? And if not, why not?
I say that it's a very, very unlikely hypothesis, and again, what is meant? I'd have to consider what is meant by the Earth is not in motion, because as I said multiple times, motion is only relative; it can only be relative to something else. So, what does it mean that you prove that the Earth is not in motion? It means that
absolutely fixed.
Yeah, with respect to what?
The universe itself. There's an absolute frame and it's fixed in it. Earth is the stationary frame. Like, it is absolutely fixed in its place. Absolute rest.
Absolute to absolute frame. But how do you measure motion with respect to this absolute frame?
Well, that's a
No.
separate conversation, and I, say to honor sacred and his space, we've taken so much time. I will give you an answer in short, and maybe we can, talk about it again next time or exchange in the meantime. But I would say interferometry, light itself, right? There's plenty of experiments that show that Earth's not in motion, and also that you are even able to observe such, for example, the generalized Sagnac effect is one of them. Ru Wang, is able to take a interferometer fiber optic gyroscope in which there is zero relative motion between the detector and the source, in which they are in uniform translation, not just rotation, but translation, and then also rotation, did both equivalent speeds of rotation and equivalent speeds of translation, and in both systems directly measured a fringe shift proportional to the velocity of motion. So he directly measured translation with a fringe shift without a reference to any external frame at all. So experiments like that can do it, but just all interferometry in general, really. He generalized the Sagnac effect. He showed that it applies to all systems anywhere there's motion of any kind, not just rotation.
Oh, I would say that I don't believe it, but okay. I'll have to see it, but of course that would mean then you're saying that it's an exaggeration when we say that you claim that the whole lot, the entirety of physics of the past 4th century is completely bullshit, because it's based on Newtonian and Galilean and relativity principle, meaning there's no absolute space and no absolute frame which is privileged for this.
I wouldn't say that. I would say that the way that physics has progressed across the last century or so, right? They've taught relativity and all these things, but anytime we actually make anything that actually works, any type of real engineering, we always use it with respect to a lab frame or an earth frame or both, right? Same difference. We always do that. Everything actually operates in the lab frame or the earth frame. And we don't have any technology that operates based on, relativistic corrections that it needs in order to function. So I would say that in practice it's not true.
Galilean relativity. What you're saying is that even Galilean relativity is wrong, because there's a preferred frame that is moving the motion with respect to this even translation motion with constant velocity with respect to this frame is detectable, which is the tenet of a pillar of physics since
Galilean relativity is the only one we agree with, Franco. That's the only one we agree with. That's just basic classical relative motion. It doesn't actually there's still not a dynamic equivalent there, and we recognize that. Newton's bucket showed that in the 1600s, but it's still valid kinematically. But it's Galilean relativity only is what we accept, and only on a kinematic basis, not a dynamic one.
No, it's dynamic, meaning that the laws of physics are the same in the two frames. This is
dynamic meaning introduction of forces. With kinematic meaning motion without forces considered. Dynamic meaning considering forces also.
And since you show mathematically that when you move from a frame to another frame with just translation and velocity, then the accelerations are kept equal. And then you can use a law such as the second Newton's law, F and A, because MA is the same in the two frames, so you can use the same force. This is a simple proof that you can use the same dynamics into frames which are related by
no, Galilean relativity doesn't hold dynamically. That's why you can, use things like Bennett's example of a pendulum or Newton's example of Newton's bucket, and they're only valid in the earth frame, in the lab frame. They're not valid in any other frame.
Sorry. Sorry to disagree. I was talking about inertial frames and frames which are related to one another by translational constant velocity. So Newton's bucket introduces a rotation, and that has a inertial frame. And the pendulum, I don't know what it means, and what it means that Bennett disagrees on pendulums.
Bennett's hiker example. He has a hiker example. He has a translation example using a hiker in a car.
It's an embarrassingly wrong example. Sorry to say.
Well, a stationary hiker with respect to a moving car, and same thing with the pendulum. It's just the pendulum swinging, so you could say that there's an arc or whatever. But I mean, if you just treated it as translation, just for simplicity's sake, it would produce. It's the same thing because, when you calculate like momentum, right, and work, and the relation between force and work and momentum, and you have a pendulum swinging. When you have a pendulum with a little bob attached to the end of it, and it's swinging and it smacks the earth, like let's say it smacks a mountain that's just rigidly fixed to the core of the earth, right? You could either say from one frame the pendulum is smacking the mountain, or from the other frame the mountain is smacking the pendulum. When you incorporate the mass into the system to calculate the momentum and force and work, you either have to choose the velocity is going to be the same because they're both moving towards each other at the same speed, but the masses are going to be different. You're either going to use the mass of the pendulum or the mass of the Earth. And if you choose the mass of the Earth, the pendulum bob's going to get smacked out into outer space. And if you use the mass of the pendulum, it's going to budge the Earth none. So,
I'm not following. I'm telling you, no. If you're making this kind of argument, no, it's completely wrong. Even on Bennett's paper, read about this kinetic energy and things like that is really embarrassingly wrong for someone who has written a thesis using covariant notation and showing that the Earth's precession is perfectly compatible with Newton's dynamics due to the sun and so on. But he was using tensor notation and relativistic covariant notation all along his thesis. I've had a chance to have a peek at it, and it was done in a perfectly legitimate way back then in 1971. But what he writes now, what he has written recently, is really, really embarrassing. Something that would have people not pass a high school physics test, not let alone.
No, I don't want to hear it. I don't want to hear it because you wasn't on that when Dr. Bennett was around. Stop it. I will never want to hear that ever again. Until you talk to Dr. Bennett, don't ever talk about nobody with no high school physics, no credentials. Franco, stop it. We hear what you got. We hear what you said, but I ain't gonna let that go no more. That's it. Until you talk to Dr. Bennett, don't want to hear it. Live in patient. We're gonna come back to you, Franco, and there's a couple hands up.
Good night, homies.
Oh, you out here?
Later, Piezo. I put the equations up top for Bennett's hiker and the pendulum that he was talking about, where dynamically relativity or any other frame that isn't the Earth frame makes the wrong prediction. And then secondly, Bennett used to be a relativist, and then he realized the implication of Airy's failure and how you can't explain it unless you invoke fictitious frames and just basically, make things up like you're doing now.
I have a question for you, Franco, after the hands.
Okay, I'm sorry. I can't see you proud. Go ahead,
Peace,
man.
boys, follow Jesus. Good night.
Thanks, Piezo.
Oh, Piezo.
Oh, my God.
Piezo, before you leave, I want to let you know how much I appreciate the respect you give the people you talk to in this room. I think besides Sacred and Proud, you're at the top of the list. So I really appreciate it.
Well, thanks.
Yeah, you're welcome, man. And I wanted to say, let Proud go first, then I'll go.
So I don't know. My question, in my opinion, is a little convoluted. It's for Franco, but he has to follow my train of thought. I'm not a physicist, Franco. So I'm sorry, I'm not as articulate. Don't kick me out of your class. But we asked you this once before. If you aligned with string theory, and it kind of offended you because we used the word belief. I don't want to use the word belief. Instead, I just want a simple, if you can, yes or no question. Are you optimistic about the possibility of finding gravity on a quantum level?
Well, I don't know. I wish I was. have an idea. I hope someday they will. I know they're still struggling, but they're not. I've only translated. I've translated books, popular books about this, but this does not make me an expert. So I don't know.
No, that's fine. I just know like from this we could build from this. So, like I said, I'm not an expert, but theoretical physicists, particle physicists. I posted a clip of us or Sacred talking to some of the other particle physicists, some of the other theoretical physicists, and he posed that same question to them. He said, "Hey, are you guys optimistic about finding gravity on the quantum level?" And now the two physicists, both with PhDs, disagreed. One was like you; he was confident and he was, optimistic about it. You even replied to that content and you said, "Hey, you liked his train of thought." But the other guy didn't have that same train of thought. He said he has no hope for it, basically. So my question to you is, you value the scientific community, you value the other speakers in your community, but when you find people who are also in the field as you who disagree with maybe string theory or they don't necessarily align with gravity on a quantum level, how do you refer to them as? Because I want us to get out of you feeling as if we disregard all science as bullshit just because we don't necessarily align with what you're saying. Now I know it's not the same thing as saying, hey, speed of light isn't constant, but I'm genuinely asking you, what do you call the people who may not believe in string theory, or they may or may not have the optimism to finding gravity on a quantum level? Because those PhDs do exist.
Yeah, but this is why we're still doing science, and both on experimental level and on the theoretical level. Science is not over. There are things that are still to be determined, and one of the things is how to reconcile quantum field theory with which is very successful in particle physics, with general relativity, which is very successful in cosmology, and you have to reconcile those. We haven't yet, but that doesn't mean that the established facts are agreed upon by the community. That does nothing to do. There are open questions, and that's the beauty of science. And of course, people still investigating the open questions may have different opinions, different possible theories. As I was just referring to some minutes ago, a lot of minutes ago actually, they're even contemplating violation of Lorentz invariance, because which is one of the pillars I was referring to. Nobody actually believes it, in my opinion, but still there are some theoreticians, some theoretical physicists who say, look, maybe in the Lagrangian of quantum field theory describing particle physics, there are terms which are actually non-violating Lorentz invariance. What would that imply? It would imply this and this on the angular distributions in the course of a year of T2 bar production in LAC. We measure that, and we compare that with the prediction of this exotic prediction of maybe some terms which are not Lorentz invariant, and we find that they're not compatible with the experiment, or at least there are limitations. You place upper limits on this, on how big these are. At the moment, they're very small, not measurable, if they exist. So we confirm Lorentz invariance. People are still in what is still not established, open to many suggestions. Of course, they disagree with one another, because otherwise there will be no point. If you only have one way of going, then everything is useless. I don't know if I've answered.
Yeah, you did answer it. I kind of wish there was a specific term, because I basically heard another PhD say that there are other PhDs that they don't respect because it's not as high, it's not high level, it's not worthy. So I guess in that regard, I'm not gonna go tell the PhDs that you feel this way, but if you're able to work next to people who still consider science to be changing and growing, and not having all the answers, they're just challenging the mainstream narrative that could be potentially out right now, but you still align with them as, hey, you're challenging the science instead of labeling them as dismissal. I'm wondering, how do we get to that point with people in the scientific community? How do we get to a point where we can be labeled as people just challenging something that's quote unquote mainstream thoughts right now, you know, while science is still changing and growing.
Because there are things established, and before challenging that, you have to make a very strong case. And in principle, there's no objection to that. Of course, you can challenge. I don't know, even Lorenz, even someone even claimed that in very far regions of the universe, the laws of physics may be different. The constants, which are presumed to be such here, such as the speed of light, Planck's constant, and so on, may be different in different regions of the universe, even in multiverse or something like that. This is very far-fetched speculations. I have no idea how they can be tested experimentally, but there are people saying this. Of course, if someone comes up and says, no, the Earth is flat, people will say, no, come on. And then there's a difference in the weight of things that you're claiming, and the way you make your arguments. Of course, again, I'm sorry to bring up Bennett again, but as to answer Sacred, I don't want to discuss things vocally with him, because you see now, you've seen for the past 3 hours or so, that vocal exchanges do not lead to anything unless you discuss, and at least from my point of view, from the scientific point of view, that you don't come to any conclusion unless you discuss the equations. And what I claim is that in the papers, the equations are not tenable, and in the latest one. So it's useless to do that vocally. You have to do it saying, look, this equation is.
Bro, you saying that, but you've been up here this whole time. How can you say it's pointless?
Okay, so I have to go anyway because I have a medical check. Then I'm already late. Sorry. See you guys. Bye
bye. Hope you're good. Sorry, y'all. I don't know if y'all had a question for him, but I didn't know he had to dip out like that.
We'll be here till tomorrow.
Still rocking.
It's probably like noon or 1 o'clock there.
Yeah, I gotta figure out a better way to articulate this in the future, but I know theoretical physicists and string theorists aren't going around calling each other quacks. Like, I know they're not in the office arguing that your theory is stupid, no, your theory is asinine. Like, they have to come to some common ground, at least having different opinions. They still have to come to some common ground. He even commented on that. I'm talking about the Quantonaut video. He commented on Quantonaut talking to that science guy and Jorge, and he liked Quantonaut's train of thought, which is what we figured he would. He would align with Quantonaut, but it's like, would he have the same like conversation with the other physicist that was disagreeing with Quantonaut, or would he call him a quack because he's right and that other guy's wrong? Like, I'll try to find the video for everyone.
How do you define what a quack is? Scientific community.
Oh, if it walks like a duck and talk. I'm sorry.
All the trolls that be ducking. Go ahead, Lynn.
Well, just a couple of short things. First of all, as I've said before in this space, I'm probably the least scientifically minded person here. But Sacred, I want you to know that I enjoy this kind of conversation. I don't understand 90% of it, but I enjoy it. So don't cut this conversation short. On my account, I can't speak for everybody else in the room, but on my account, don't cut it short, because I enjoy the back and forth. I enjoy being surprised a lot because I don't know much about the science. When people like Franco and our resident troll, who I'm not sure if he's still here, when they say certain things, that they say it with such authority, or whatever, I think, oh dear, oh, maybe we got something wrong. But no, Alan or Piezo or one of the fellas will chime in very calmly and usually respectfully, say, well, no, we're not the ones wrong. You're the one wrong. And they give a good answer. And so I enjoy that. I enjoy hearing that a lot. So anyway, so I want to just echo, I think it was Cosmo, all the nice things he said about everybody. I just want you to know I said amen to everything he said. So anyway, that's all I have to say. Carry on.
Thank you, Miss Lynn. That was a nice recap.
And don't worry, sometimes I fall 2-3 steps behind the conversation too. It is fun though. I really like the feeling of when the guys are going back and forth, and I'm actually following along more than I anticipated. So that's nice. It shows that we're taking in information, gathering, and able to retain it. It's cool. Cheers to learning. I think Axel was next, and I want to make sure everyone on stage gets a chance to chime in. If you are listening in the comment section, this is Flat Earth Fridays, Stationary Saturdays. Welcome. We might rotate some mics after we do a little intermissionary music session.
I mean, do you
Ooh,
want to
play a
do that
little Big
first?
Shack?
Do you want me to go?
Oh, yeah, definitely.
I assume that was an affirmative. I was just going to say that, like, when we were talking about frames of reference earlier. Sorry, I had to cough. Yes, like all the math works from, in theory at least, all the math works from any frame of reference, but a lot of the times the reason why you choose one over another is because you want to pick a frame of reference that corresponds to like a physical explanation that makes sense. So you could set your frame of reference just to be you, and then when you go outside and you walk down the street, you could be like, I'm stationary and the Earth's moving. Like all the math will work, but what would that mean physically? Like the Earth's a conveyor belt and it's moving underneath you, and you're pushing your legs along it, but just staying still. Are your legs pushing the Earth? Like you're not moving because you're spinning the Earth like a ball or something like that. But like those aren't very good physical explanations for how you walk down the street. Like they don't make a lot of sense. Doesn't seem like your legs would have enough energy to move the Earth. If the Earth acts like a conveyor belt at your whim and no one else's, like it's incompatible with like other people are walking in different directions. Like the whole Earth can't be moving. I mean, I guess it could be. It'd have to be doing it in a way we don't really understand. And so I think a lot of the reasons why people didn't just go from geocentrism to heliocentrism because the math was easier. Like because a lot of the math wasn't easier when they did that. But they also did it because they had come to the conclusion that made more sense as an explanation for how the solar system worked, and so they wanted to work in the frame, at least when you talk about astronomy, that they thought better explained physically what was actually going on. I mean, obviously, we treat the Earth as stationary for all sorts of normal purposes, because it is easier to just be like, well, let's assume the Earth's not moving, and then I don't have to have a very complicated speed display on my car or whatever. But I think that is a big part of it. Is scientists want frames of reference that fit in with what their physical explanations of how the universe work are. That was it.
Great
Well, it gotta be.
comment. I would like to add a little bit to that. Sorry, Sacred, I didn't mean to cut you off.
No, go ahead.
I know,
Bro.
dude.
You got it.
I've been talking a lot tonight. I don't mean to.
I like it, bro. I like it. Go for it.
All right. So, kinematically, right? is the Earth moving, or am I moving the Earth from underneath me? Right, for sure, super valid, and mathematically, valid, right? Because that's kinematics, right? But then you went on to give dynamic explanations where you were like, the energy required for my legs to move the Earth would be like preposterous, right? And it's like, that's where the difference is made in the dynamics, right? Because when you're making future predictions of motion based off of forces and all these things, that's where you can distinguish the validity of a frame. Relative motion is only valid in kinematic analysis. When you go to apply forces to make predictions, as in your example you showed, there's where the distinction is in dynamics. So in dynamics, the only valid frame is the lab frame, the stationary frame, which all the measurements are taken. You mentioned that physicists and people doing experiments or whatever choose the frame relevant to what they're doing. Well, all the experiments ever done are done in the lab frame, so they're that's where the observer is. The observer, like in reality, is wherever the information is being recorded at. So that's the frame of reference that you choose. And then for dynamic predictions based off of that, they will be interpreted through a stationary Earth frame. And there was one other thing. Oh, yes. For the stuff in the sky, right? That position is chosen philosophically for the Earth to be in motion. And that is because when they started ratioing constants against the periodicity of the planets, they realized that it all comes out proportionally. So you can derive Kepler's laws from Newton's using the constants for G, and the M cancels out because the M's cancel. So the only thing that actually matters in the equation is the periodicity. But when you incorporate big G in it, you're asserting dynamics now. So like it's giving explanatory power to like, I know what's going on in the sky because that planet weighs this much, the sun weighs this much, therefore it has to be this far, and it's exerting this much gravitational force between these two bodies, blah blah blah, right? And this is what completes the periodicity, and it has to be moving this fast. That is why they started doing experiments to see if the Earth had a velocity component to it. So that was the purpose of Airy's failure. Because when you look at parallax, you're like, oh, that could be due to the Earth's motion around the sun, but because it's a triangle, right? You could just reverse it. The baseline becomes the sky. Your observer point becomes the convergence, and then you have an equivalence there. So that observation can't tell us if the Earth is in motion or if the sky is in motion. And then we have stellar parallax, which is a generous grant that there's a true position of a star, and that there's a deviation from that true position over the course of a year. And when you ratio that against the speed of light, you get the angle that's observed, and you get 30 kilometers a second for the ratio. So people were like, oh, dude, no way. We found Earth's motion, boys. It's right here. But again, that's an observation with no manipulation of independent variables. That alone can't tell you if the Earth is in motion or if the ground is in. If the Earth is in motion or if the sky is in motion. So that's why Airy's introduced the water, because there's going to be an angle change if the Earth is in motion. So that was like step one for falsifying the dynamics of the sky regarding how that would apply to, big G and the interactions of mass between the planets. And then they went on to do Michelson-Morley in 1881 and 1887, the 1887 one being the better constructed, the better constructed apparatus that took care of the sensitivity issues from the first one, where they were getting background noise from just ambient vibrations. But anyway, that also definitively gave a velocity component that didn't correspond to Kepler's laws of Newtonian dynamics. So the only interpretation that's valid is the Earth being stationary. And if you take that interpretation, then the 0.8 arc second difference in Airy's that was measured, and the just over 1 fringe value that was measured from Michelson-Morley become first order measurements with respect to a stationary Earth and a dynamic ether. And you don't have to do any transformations or violate any laws of physics or come up with any crazy axioms to build an entire mathematical framework on. That's essentially just about transposing a velocity to a different reference frame and saying that velocity also applies in your frame. But because you're moving at a uniform velocity, it can be treated as stationary, which is like, okay, dude, that's true. But also when you get into dynamic analysis, there's only one way you can treat it. And that's the end of my sermon.
I you know what? I'm not going to say the slightly mean thing I was going to say because I'm being nice today. But I have it wasn't going to be mean to you, so never mind. But I have a question because you were talking about dynamical theories. I also think that even if you're just talking about relative motion, can give you reasons to want to prefer one frame over another, because one of the problems with the idea that the Earth is stationary and non-spinning is you have to have an explanation for why, like what's going on with these celestial objects. I mean, it's going to turn out they do have to be relatively close, which we have evidence that they're not, that you don't agree with, but stick with me here. But you're going to have to, why do they all move at the same speed? Even though there's reasons to suspect they're not all at the same distance. And or at least largely at the same speed. I mean, we know that some planets are further away from us, or at least the ancients thought that some planets are further away from us than closer ones. We know the moon is closer to us than the sun. But why do they all seem to travel the same speed through the sky if it's like they just all have convenient velocities where they all just travel at the same relative speed when you look at them? I mean, that could be true, but there's reasons to be suspicious of that. And certainly if you think the stars are far away, you're going to run into the problem that, throughout the day, they're moving at multiple times the speed of light, which isn't physically possible. And so it's going to make you be like, well, that can't be right, because, they can't be, Alpha Centauri can't be traveling at, 16 times the speed of light or whatever it would take to rotate at 4 light years away from us, that entire distance 4 light years away every single day, be a lot more than 16 times the speed of light, be an impossible velocity. And so they're even purely just on relative motion. You can be like, well, is this an explanation that makes, I mean, a lot of it just is this an explanation that makes sense? Given the other things that we know. And I think for the most part, it doesn't. And you think it does, and that's fine. We don't have to agree about these things. But I think that's sort of why I don't find those arguments very persuasive.
Well, you raised some interesting points there, and I'd like to go over them. So, again, there's no preferred frame in kinematics, right? That's just a measure. That's just like relative motion. Like it could be, am I moving towards you or are you moving away from me? We're not applying causal mechanisms or force analysis, so there's no way to distinguish. And then in regards to the celestial objects, as I mentioned earlier, the only variable that changes is the periodicity. It's simply a ratio over pi. So the distances and velocities don't necessarily need to be physically meaningful. And in fact, in the geocentric model, like where the epicycles occur, like we could have a variance in the speed of the planets. They don't have to be all the same. It's just a dependent. That actually just depends on your reference frame, right? How you apply it and what the orbital patterns would be to complete those orbits. So you would either get those fractal geometry flower of life patterns, or you would have the ellipses. Now, in regards to distances, right? Confirming distances. Well, for the purpose of celestial navigation and using the coordinate system given to us, known as the latitude and longitude for the old globe, right, as they say, which is one of the projections that coordinate system fits on. Now, what you do for celestial navigation, you can consider everything in the sky, the stars that you're using for navigation, the planets, the moon, the sun, all at the same distance at an equidistant web that's basically at the limit of your vision. So like as far as you can see, that's where, that's as good as the distance of any. And then when you apply the cosines they use for celestial navigation, they're setting the elevation angle for that for a two-party system. So two people can triangulate their positions using the stars. And all of that, when you follow all of those calculations, that's, the quote unquote actual distances of these planets and the motions concerned is completely irrelevant, and everything is brought to an equidistant web that's geocentric relative to your position. And then we have, let's see. Yeah. So if things moving faster than the speed of light, well, that would only be if you link causality to the speed of light. The speed of light is actually measured c plus or v in the lab frame all over on Earth relative to the latitude. No one's actually ever measured c as being c in an experiment. You know, they claim that they're measuring Earth rotation with the speed of light, which necessitates a c plus or minus v in the east-west directions to give a timing difference to produce the fringe that when they do a Fourier transfer and of the time for sidereal time against the measurements that produces the sine wave that gives them the good correlation for, you know, the measurement being related to the position of the sky for it to be Earth rotation. Anyway, general relativity also agrees with me because that generalized all frames, including the geocentric frame. So the special theory says, you know, heliocentrism is valid. The geocentrism can't be true because all motion's relative. And then general theory came through and was like, hold on a second, bro, I got you. We're going to generalize all frames for acceleration and gravitation. So that's so you can basically treat the Earth as stationary, and then everything would be revolving around the Earth. And as soon as you get out past, I think it's either Saturn or Uranus, everything has to start moving faster than the speed of light. But that's fully canonized in the special theory, and that's why Einstein, in like I think it was like 1922 or 1924, wrote in one of his books about how, you know, the speed of light is variant, and he regrets putting a cap on it because the implication from general relativity, you know, regarding the geocentric frame is one, out past Saturn or Uranus, you're well exceeding the speed of light, and then exponentially as you go further, if you accept the current cosmological distances. And then on top of that, let's see, I think that's pretty much it. I mean, the theories that you subscribe to already agree with the equivalence, and then they just don't talk about it because the implication is that things are, you know, violating causality in your paradigm. And then that pretty much wraps it up. So if you have anything to add to that or comment on, I'm all ears.
So you think it's possible for things to travel faster than the speed of light?
No, I think it's possible for things to, like, not material objects, and I don't consider the planets and all that material objects and stuff. So, like, obviously to complete their daily circuits and stuff around a geocentric you know, point of view, they would have to travel at those speeds, but I don't think they're physical objects.
So you think non-physical objects can travel faster than the speed of light?
Well, the speed of light is measured as c plus or minus v, so light, whatever light is, travels plus or minus v.
I mean, well, you see the light comes at you the same velocity regardless of your relative velocity towards it. I mean, it's the frequencies that change, not the velocity of light itself.
Well, it's an inversely proportional relationship with the wavelength, which actually changes the wavefront, which provides the phase difference for things like interferometry, showing that the speed of light when it completes a circuit isn't the same. If the measurement isn't made with respect to absolute space and all motion is truly relative and the speed of light is constant for inertial observers, then the speed of light in the interferometer, the split beam, would recombine without producing a fringe shift pattern, because it's just like the distance is going to change because of the motion, but the timing won't change because the speed of light is constant. So it's just going to complete the distance at the same time, going with and against the rotation.
No, light appearing to be the same speed to all observers is like a very well-established physical fact. I'm afraid I'm not going to get talked off of that point by your understanding of an experiment that happened 140 years ago. I mean,
we can do Fazal. Fresnel drag coefficient is used in modern interferometry now. So in an interferometer, when they ionize the gas inside of the tubes, that electrical current produces a preferred direction for the gas inside, which produces Fresnel drag, which is C plus or minus V. And the way that they cancel that out is they have circuitry inside of it, an anode and cathode, that interjects electric current in the opposite direction to, you know, nullify that C plus or minus V component so that they can get accurate readings. These effects, while they, you know, come from the 1800s, are still used today modernly. Like, for example, the Michelson-Morley equation is equivalent to the Sagnac equation, and the Sagnac equation is still used today in modern interferometry. So we got Sagnac, the Fresnel drag coefficient, you know, all still super relevant in imply C plus or minus V.
Yeah, I mean, that's just inconsistent with the entirety of my understanding of relativity. I'm afraid I'm not going to take your word for it.
Well, what if I gave you a physics textbook to start off with that says the Fresnel drag coefficient derived in 1818 is equivalent to the modern relativistic velocity composition that they use? Would that be like a good starter to show you the equivalence for that, for C plus or minus V?
You know, I mean, although I have read many physics textbooks, so, but also I think it's outside the scope of this conversation. So, you know, I'm not saying I'd be unwilling to be convinced under any circumstances, but not in the context of a Twitter space, I'm afraid. So we'll have to move on to something else.
Absolutely, absolutely. Can I add you on Twitter, and then I'll send you a couple of experiments, right? And then maybe we could talk about them next week. We can do a follow-up. We can do like Fazal, Ruyong Wong, and then maybe you can send me some, and we could do like a little compare and contrast next week. What do you think about that?
I mean, if you want, I mean, my DMs aren't, I think, I mean, I'll follow you back if you follow me, but I think I let anyone send me DMs. So if you want to DM me something.
Yeah, no worries. All right, cool. Well, I'll send you a message here of a couple experiments, and then we'll reconvene in a week. And then if you have anything you want me to take a look at, feel free.
Axel, real quick, are you okay with Earth being stationary if that means it's still a ball, or are you just against stationary Earth as well?
And I don't want to echo Franco, but stationary with regards to what? I mean, you know, that just isn't a statement that makes a lot of sense to me. No, I mean, I don't think the Earth's stationary. As I was saying, I think you really run to problems pretty quickly with astronomy. Like, it's inconsistent with our understanding of modern astronomy. And I know a lot of people here strongly disagree with modern astronomy, but I don't. And so, you know, the idea of a stationary Earth is just not compatible with, you know, big parts of my view about how the universe works. And so, yeah, I don't think it is.
Oh, no, that's cool. We got some globers that I think were saying that they would be understanding of a stationary Earth and local luminaries. I guess to answer your question, stationary in regards to the universe. Local luminaries, everything around us moving, but they were still adamant that it would have to be a spherical Earth with a stationary part. But that's cool. I don't know who else was next, if anybody else was next, or if you guys wanted to continue. A different topic.
No, we're good. I'm gonna send them some stuff, and hopefully we can discuss it a little further next week.
Oh yeah, I was supposed to be pulling up music for our intermissionary. Wait, what?
Into what? Axel, when you find out they can't find no motion, you're gonna at least be geocentric.
I don't know. I know I've said this before, but you know what? You guys have your own beliefs, and that's cool. I'm here to be a bit of a foil. I'm here to have something to do at 5 a.m. where I live. And I don't mind talking to you guys. I mean,
Axel, it's not a belief though. We're looking at actual measurements.
Most of you are nice enough, but
we can't deny the science. We gotta acknowledge it.
I mean, I could go down the road if I'd like to see what, I mean, like, how far away do you think the sun is? Like, you know, but a feeling I'm not going to get a straight answer if I ask that.
No, I can give you a straight answer. So it depends on how far you need to triangulate it to get everyone to believe that it's a physical object at a certain distance, right? What I laid out earlier about how you can treat it following the coordinate system given to us, the distance actually doesn't matter, and you could treat it just at the limit of your vision, which would be the length of a terrestrial or half of a terrestrial meridian. So if you took the distance from the equator to the North Pole, right, that would be 6218, something like that. So you could treat your limit of vision as 6218, and that would be just as good for a distance for the purposes of celestial navigation and, quote unquote, using the globe to navigate or whatever, right?
I guess. I mean, I guess I just would like to know some things about the sun, like how large is it actually?
Well,
How
all we
does
have
it
for a sun
now?
is an angular size and a periodicity, right?
Yeah, but it seems like we should be able to get more.
How?
Would you accept presuppositions?
The only way you could get more is by referencing other things in the sky and making assumptions about them. That's exactly what they did with the with Venus and the sun and some transit they used. And they were like, "Oh, look at this alignment. The angle would be 30 degrees, and we know that Venus is the same size of the Earth." So it's like, yeah, if you make a bunch of assumptions, then yeah, you could definitely reify a distance out of it. But for practical purposes, to I don't know, make a map for navigation, you treat it as 6218.
I mean, the Greeks made a try at it, assuming that when the moon was half full, it was at a 90-degree angle from the Earth, and they tried to calculate the angle between the difference between the angle between the sun, the Earth, and the sun, the moon. And I think that guy did come up with that the sun was like 83 times further away or something. Although by modern standards, it was way too small a number. Although good attempt. Although it's a very small angle, so it's hard to calculate.
Yeah, the modern canonized distance measurement is using Venus and assuming it's the same size as Earth. So it's like just another celestial alignment to get the angle necessary to give them a distance, but it doesn't have to have any physical meaning, like I said. I mean, if it's 93 million miles or 6210 or 6218, there's no difference. It's still the same angular size, right?
Sorry?
So because it still maintains the same angular size, right? At 93 million miles or at 6218.
I mean, it maintains the same angular size because its relative distance to the Earth doesn't really change very much. But I guess if it was further away, it'd be smaller. If it was closer, it'd be bigger, right? Like that's the way looking at things work.
Well, it's kind of making some assumptions about the physicality of the sun and its distance. Like, for example, if the sun, I don't think the sun's a physical object, right? So that's my position. So if we move forward with that and we examine the two positions, right, we have a physical sun that's 862,000 miles wide, and we have a sun that's we have an Earth that's 24,000 miles in circumference. So what we have, and due to gravitation, we're basically locked into the central part of that, and what we would see in the sky, if those distances and sizes were true and in combination with the parallel light rays, you would see the sun would be the biggest thing you see in the sky, because it's just, it's 86,000 miles wide from what you would see, and what we see is what is it? It's half a degree, in angular size. So we don't see this massive thing with parallel rays. We actually see anticorpuscular rays that converge and diverge from that focal point, around us. And so we don't, I don't have a physicality to it to have that burden where it has to be a certain distance for anything like that.
I mean, that's fine. Although, yeah, I guess I would say that, well, I'm not sure to what extent that's a scientific claim. Objects have to be made out of something, right? It's,
for sure. But I'm saying the way we perceive it isn't perceived through the lens that you would be able to optically derive anything meaningful out of it, because the fact that we don't see it in that way means that we see, in what's called curved visual space. So if we have celestial objects that are gigantic, right, but we see them as small focal points. Think about a star. A star is infinitely bigger than our sun, but yet we see them as little tiny dots, but that's because you say that they're super far. But in order for us to even perceive that, we have to converge all the light, all that big ass parallel light ray that would just take up the entire sky. We have to converge that into a focal point to see that star. And we all see them slightly differently in slightly different positions. And that's what makes me think that they're not physical.
Okay. The parallel light ray thing is never made a whole lot of sense to me in the sense that, like, you know, you don't really need light sources to be that far away before you can treat the light coming from them as being parallel to where you are. I mean, it's easy to measure it's just a matter of geometry to measure the angle difference, right? You've got, you're standing on the other side of a room from a light bulb. And so the right half of the light bulb has a certain angle to your eye, and the left half of the light bulb has a certain angle to your eye. And there's your angular difference with that light source. And it's just a question of what you want to consider parallel or not, like what's close enough to consider it parallel. But like, even like, looking at a street light from 100 yards away, it's pretty close to being parallel. There's not much difference at the angle that the light's coming into the. I'm just using one eye here to be convenient, say a camera, but there's not much of an angular difference between the two sides of the street light when it comes into your eye. So if you want to say like, well, there's half a degree difference, I don't really consider that parallel. All right. I mean, the sun is a bit difficult because it's pretty big. And so, on Earth, we know it's not strictly parallel, because the sun isn't a point source, or I mean, nothing's a point source, but the sun doesn't look like a point source, right? It has size in the sky. And so, yeah, there is a difference between, it's not as parallel as, like, I don't know if you could isolate the light from Sirius or something like that, but I mean, close enough for government work for the most part to treat the sun's light as being parallel. I mean, I guess it just depends how parallel you want it to be.
Yeah. So actually, I found this out a couple of years ago about the parallel rays incoming, because that didn't make sense to me either. But in order for celestial navigation to be explained in terms of the causal mechanism for starlight displacement 69 miles per degree, would have to be due to the shape of the Earth. So because if it's not due to that, then if it's due to some optical effect, then they lose mutual exclusivity over the 69 miles per degree. So it absolutely has to be mandatory coming in parallel from basically infinity. So that's the issue with that. And then the reason they need specific distances for the stars and sun and whatnot is because that has to be backwards derivable with Kepler's laws, and it all has to. So, and if you were to triangulate it with people on the Earth at different locations, different latties, you're gonna unless you expand that distance out to like 93 million miles, which is like essentially infinity. Those the people triangulating the sun would never converge to a point if the Earth wasn't a globe and they were just for example, setting an arbitrary point so they could use the law of cosines to calculate distances based off of that. Then you would have that discrepancy.
I mean, yeah, I don't really know a whole lot about celestial navigation except in the most like abstract sense, but I would just say something like, like a lot of things, it is all relative. If you're standing I'm probably just saying things that are just repeating things you said, so I'm sorry. But if you're standing like in front of a searchlight or like a big light on a movie stage, well, those light rays aren't really parallel at all to you, right? You've got like light coming in from the right of you, light coming in from the left of you. That just isn't parallel at all. But you move that searchlight really far away from you, well, yeah, it starts to get parallel, right? I mean, and like you said, it's just a matter of the geometry of the light source and your location from it. So it's not, it's not like particularly difficult to figure out. And as I was saying earlier, it just determines how parallel you want it. Like, I'm not sure what the error would be in celestial navigation I mean, point sources like stars are close enough to being purely parallel, whatever. But like, I don't know if they try to use the sun for celestial navigation. I'm not sure, what the error bars actually would be or whatever, how inaccurate it would make their measurements, because, I think there's like a 1.5 degree difference or something like that with the sun. But yeah, it's just the way that light sources work. It's not. I mean, whatever. Sorry.
No, you're good. But yeah, do you understand though that if the light rays aren't coming in parallel, then mutual exclusivity of deviations from the stars become a matter of perspective and not a matter of due to the physical contour of the Earth? Because that's the position. Like that's why it's regarded as like mutually exclusive and all these things. Because if it's not regarded in that way, then you're open to perspective being the causal mechanism, and if that's the case, then there's an equivalence in observation between Earth curvature and optical curvature, which is what people, you not being privy to this is like, I'm just kind of explaining to you the position of the people who are like, more involved in the conversation and why it is the way it is, because it allows them to give a one-sided view of the paradigm.
I mean, are you saying something? I guess I'm confused. Are you saying something like different people in different places on the Earth would disagree that the light rays were parallel or not?
No, they would disagree with the position of the stars. So, like, like what they try to say is they say that like you can't do celestial navigation on a flat Earth because 69 miles there would be like no deviation in the stars. Because their interpretation is that the deviation could only come from you're basically on a curved surface and you're walking you're walking around away from that star from some point, and then now you're curved relative to where you originally were, and based on you being like at a physically different angle because you're tilted on the surface. Yeah, you get it now. Yeah, so that's
I don't understand what you're arguing, but I understand physically what you mean now.
Right. Yeah, well, I was saying because you were trying to say that like, you don't get why it has to be parallel or whatever, and it can just be parallel enough. And it's like, well, no, it has to be pretty exact to follow the curriculum of globularity.
Yeah, I don't know enough about it. I've never really. I mean, there are some globe Earth arguments I don't like very much. I think that's one of them because I think it gets into. I mean, well, one, it's a counterfactual, and two, the problem is that like if the stars are relatively close to us, then they would change their relative position based where you were on the flat Earth, right? Like they're still assuming.
Shout out to you, bro. Exactly. Yes.
Or for all intents and purposes, infinite distance.
Yeah, because think about it like this, right? You have a street light above you, and you can see a series of street lights, and as they get further away from you, they start to look lower. But if you were to like start to walk down the street, each one of them would start to rise above you, and you'd be like, oh, okay, that's perspective. And if you tried to apply the same thing to stars, the globularist proponents that are more involved in the conversation, they would, they can't allow that. So what they'll tell you is that like perspective doesn't apply to the stars, and that the light rays have to come in parallel, and then due to the shape of the Earth, that's where you get your deviations. Like that's actually how they argue it, and I'm glad that you don't agree with that, because it is like logically absurd. Like why, at what distance? So you can triangulate different positions of a plane and you'll get different results, but like somehow at the stars at infinity, that's where you can get a real distance.
Well, I mean, I think there's I don't. I mean, I guess they're not here, so no one's going to call me out. But yeah, I mean, I guess there's just other problems too. Like if you think the Earth's flat and Polaris is roughly above the North Pole or whatever, then yeah, it's still going to like be at a different angle when you move away from it, because you're not directly. If you're at the North Pole, you're directly under it. If you're not directly under it, it's going to be at a different angle, even if the Earth's flat. Like that's not going to change, even if it is.
You're speaking blasphemy right now to the globularist. No, that's exactly our point, man. Thank you for acknowledging it.
Never admit that, ever.
But yeah, in the midst of other globularists, never say that out loud. They will disavow you.
People argue for the correct position with bad logic a lot. What do you want from me? Yeah, I don't know. I mean, I try to I really do. I'll read what you send me, my friend. I do try to avoid getting to the scientific minutia because, as I said, I'm not a scientist, so I don't. It's a lot of it is. It takes more mental effort than I maybe really want to expend on understanding it. I get enough of that from the I get enough of that from like the sovereign citizen people, because like I work in the legal field, and so you know what? I'm not gonna. I'm not comparing you to them. I was just sort of thinking.
I said, what in the comparison is going on?
Yeah. I'm not comparing you guys to them. Sorry.
What the analogy?
I'm on my own rule here. I'm sorry. I apologize. I was just saying that like sometimes sovereign citizen people will send me their documents about like why they think the law works a certain way, and I'm experienced enough in that field that I can understand why what they're saying doesn't make any sense. But I'm not so experienced in physics, and so like I'll look at things, but I don't have a physics. I took 2.5 years of it in undergrad 25 years ago, and so I don't have that much of a background in it, and so it's I understand it at a layman's level, but actually reading scientific papers and understanding them takes a lot of effort for me.
Oh, no worries, man. I mean, it's the same situation for me. I have even less of a physics background. It takes a tremendous effort to, learn all of this and figure it out and decipher it and share it with the lads. Yeah, we learn best through, argumentation and trial and error. So it's all part of the process. So, feel free to interpret it how you want, because what I've learned is that, basically the only thing that supports the current mainstream paradigm is just if you don't agree with it, you're just not going to get funding or have a career. And if you look at the experimental measurements, and take them as is, and they contradict relativity theory. They almost never support it.
This Binet guy you guys have been talking about, I remember hearing him on here a while ago, and I've looked at a little bit of his stuff, assuming we're talking about the same guy.
Add a little flair onto it. Okay,
I could be mistaken.
Yeah, Bennett.
But he's you guys are trying to set Franco up against him. He's not a flat earther though, is he? Right? He's just
worried.
Nope,
views about special relativity.
Nope, he's a glob lad.
That's what I thought, but I wasn't sure. He does seem like a crank. Sorry, guys. But
and if he's a crank, there's a mathematical analysis that's posted that's pretty basic high school algebra if you would like to provide an explanation of it to show how a non-inertial frame is just as valid as the lab frame. I mean, you're welcome to, bro. You can crank that one out real quick.
I'll just do that. Non-inertial frames are inconvenient. But I mean, we are in a non-inertial frame.
Ooh, okay, good. We're in a non-inertial frame, right? Let me ask you this, dog. Where do the laws of physics apply?
I mean, everywhere.
On Earth, right?
Yeah, so we assume by extension everywhere else.
Well, no. But what's been experimentally confirmed, though? What makes the correct predictions for dynamies, right? It's only stationary frames. It's only, and when you get in specifically to experiments with dynamics, right, the lab frame is the only way to interpret the experiment with respect to a stationary Earth. The Earth is never the thing doing the rotating or the moving.
I mean, I've done in physics classes, I've done experiments where, where we do take that stuff into account, basically as a way to demonstrate that it's doable. But it doesn't make that much of a difference in the results, and so you shouldn't bother. But yes, it is true. Mostly we ignore the Earth's rotation and the fact that we are within a gravitational field when we do lab experiments.
I mean, that's a huge presupposition because as we went over earlier, there's no big G, right? And then to further assume the correctness of relativity theory for the special theory to then be extended into a general theory, to have a pseudo inertial frame provided by a gravitational field is just like, several layers of mathematical assumptions that have been experimentally falsified, hand over fist, right? Like, I mean, just starting with the falsification of special relativity, where the speed of light is shown to be c plus or minus v in the lab frame, nullifies that. But then, like, even if we were to look at the general relativity by itself, like let's assume we could separate the two and they could be, we could have one without the other. We could go over the history of general relativity and the falsifications of that as well. None of these theories that are put forward actually explain anything, without first assuming that the Earth is in motion and that it's somehow a non-inertial frame, and then we're going to apply fictitious forces to it. We're going to apply pseudo forces to it, and it's like, do you have to do that in the lab frame? Nope. So one frame is superior to the others. It's not that it's inconvenient; it's that you're invoking fake forces are fake physics. So you're invoking fictitious forces to make the frame equivalent to what's already stationary. By assuming that it's not stationary, but due to all these different factors, it's you're in the illusion of stationary.
I mean, are you talking about treating gravity? Wait, sorry. Are you talking about treating gravity as a fictitious force?
Yes.
Yeah, I mean,
because if you make it fictitious, you also lose your dynamic claim, because dynamies are real forces. So it like also undermines it, just like,
you can treat it as a real
right off the rip. Well, it's either real or it's not. Right.
Ooh, that's an interesting idea.
Because in a geocentric position, the frame, like all the forces are real. They're all, Coriolis force, Euler force, centrifugal, centripetal. All those would be real forces. In general relativity, those would get converted into fictitious forces, but when you're in a low gravitational field, you can use a Newtonian approximation because, it's all the same, and you're just taking derivatives of the space-time metric, to make it infinitesimally flat, so you could apply Newton's equations to them to make it the same. And it's not like, okay, where's the physical reality difference between how we're going to apply the math? Are we going to use the space-time metric itself, or are we going to do derivatives of it differentials of it to make it infinitesimally flat, to basically say that, it's the same as Newton's equations? It's like, that doesn't mean anything, When does a real force become fake? When you change the math equation? It's preposterous.
I mean, it depends how you're treating it, whatever the problem is. Like, it's just, I mean, it is all a simplification. Like centripetal forces, centrifugal forces, sorry. Like, those are fictional, but if you want to write a force diagram for someone, in a roller coaster, it's easier to treat as a real force. And just be like, yes, technically, what's actually happening is they're not being expelled towards the outside. They're being pulled. There's this tangential frame. They're being pulled towards the center. But it's a simplification. It's mathematically equivalent, but they say that because they're like, be aware there isn't actually a force on a roller coaster that's pushing you against the if you're on a loop, there isn't actually a force pushing you against the outside. That's not what's actually happening. But we can treat it like a force because that makes it easier to solve the problem or solve the equation or understand the forces involved. And that's fine. I mean, that's like what 90% of like math is like finding tricks to make the problems easy enough to solve.
Well, dynamically, though, it's physically happening. And if you don't have some sort of barrier or way to contain yourself, you're going to get flung off, right? Now, the difference, though, is like you say, you can treat it as fictitious, but they'll say like that the force is fictitious, but it has an effect. Well, how does a fictitious thing have an effect? Stop you from flying off the roller. Right. That's not, you can't have a fictitious thing that has an outcome. A fictitious thing can't affect the physical outcome. That doesn't make any sense. So it's either real or it's not. And, we treat them all as real. When you do a convenient transformation and invoke fictitious forces or pseudo forces to make them real, that's not an equivalence, right? That's just a mathematical gobbledygook, really.
I mean, the problem is that Franco, probably better if Franco was back here to explain this, but yeah, like, a roller coaster on a loop, what's happening is that, you're being, you have some tangential velocity against whatever the radius arm of the loop is or whatever. And normally you would just like fly off into space. But the reason why you don't is because there's something there physically stopping you. But, you're in a car, you're in a, whatever the pod or whatever the thing is. But it's not like there's a pod force in the way that there's like an is electromagnetism, but there's not like a pod force in the way that there's an electromagnetic force that's like keeping you in the pod. It's just that what's happening is that it's just easier to explain it that way. There's no causal mechanism there. It's not like there's something about spinning pods around a roller coaster that gives them that they're generating some sort of force that keeps people inside them, right? Like it's you're being kept in there because like that force is being passed up the strut to the central frame or whatever, right? There is a mechanical force keeping you in there, but it's not really like a force from outside the construct that's resisting you leaving. It's just we explain it that way because it's much simpler to do mathematically.
So, would you say that if you were on a merry-go-round and like you would predict that there's a non-force forcing you outward off of the merry-go-round to be flung off?
Oh no, that's a real force. It's the one keeping you on the merry-go-round. It's not real.
Oh, so you're talking about centripetal.
Yeah. Centripetal force. Centripetal force is real. Centrifugal forces aren't.
Well, it's the inverse. They say that the centrifugal force is a fictitious force, but it's always felt in opposition with the centripetal force, which is equivalent to gravity. Yeah, dude, it's very confusing because they actually teach it like kind of retarded so that you can't make sense of it. So that like I said earlier, they'll teach that it's a fictitious force, but it produces an effect, and it's like, what? How does nothing produce an effect? But let's see, what was I saying? Okay, yeah. So yeah, in regards to a centripetal force, though, that usually requires a physical tether. Like, for example, if I have a basketball in my hands and I extend my arms and I spin around, there's a centrifugal force pulling the basketball out, and then there's also a centripetal force of me pulling the basketball in. So that's like a physical tether. Now they say, the gravity is equivalent to that exact force and blah, 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 right? But, when you apply that to astronomy and you get into Michelson, Morley, Airy's failure and stuff, that you realize that force doesn't actually apply to anything in the sky, and that anything anyone ever measures is just the downward acceleration of 9.8 meters per second squared.
I mean, I think the classic example of a fictitious force is like you're in a car and you accelerate, and there's a force there. Your car's accelerating, that is causing a force. But what your experience of that is that the chair is push you feel yourself getting pushed back against the chair. Well, you're not really getting pushed back against the chair. The chair is getting moved forward. Right. And so, but it might be easier to explain the situation as you being pushed back against the chair.
Are you physically moved back towards the chair? If there was no chair there, would you just fall backwards?
But there's not a force. Right? I guess hold on. You're actually bringing a good point up. You are, but there's not a force acting on you making that happen.
Oh, it's just an effect from a fictitious force?
Well, no, it's the sorry, I said it the wrong way. You might go, there's a force pushing me back against the chair. There's not. There's no force moving you against the chair. What's happening is the chair is being accelerated along with the rest of the car, but you experience it as you being pushed back against the chair. But there's no force came out of the sky and started pushing you back against the chair. What happened is the car is accelerating. And so that's normally when people say fictitious force, they mean situations like that. You can still write up the force diagram like there's a force pushing you back. That's fine. It'll work okay. But but that isn't what happened. Someone didn't come into the car and push you back against your chair seat. What happened is your chair is moving you forward. Does that make sense?
Yeah, can you write an equation that shows the inverse, or would it make the wrong prediction though?
I mean, someone could come in
based on what you actually feel, based on the dynamics of it.
I mean, I guess someone could come into your car and push you against your chair seat, and then the force would be him pushing you. But you could be like, "Well, I'm experiencing this as my chair pushing me back."
Well, the opposite, but yeah.
Yeah. So that's normally what they mean. I mean, I don't like the terms because it's very confusing. And it has to do with mathematical formulation, mathematical formalism more than it does with what's actually going on in the real world. It's just that, but I understand why people who are teaching physics are trying to be like, no, there isn't a force that comes in your car and pushes you against the chair. Like, I mean, that is kind of important, I guess, for people to understand.
Real quick, lads. We were about to do intermission. We just want to let you guys get your build in. We also want to make sure Winston isn't trying to holler at us before he hops on the plane. Grand Rising, good morning, good morning. As well to all those who are just now tuning in and jumping in.
I mean, I'm curious about Witsit's Argentinian adventure.
Yeah, we feel like we might be having a little bit of audio issues, so I don't know if you can hear us. Taylor either. I don't know if they can hear from listener. Has it been 6 hours? It should have been 6 hours. Witsit, if you can hear us from the tarmac, upload a photo.
He said they got the jumbo jet.
I mean, free trip to Antarctica, I guess.
So what you think, Keys? Intermissionary break. Give the lads a chance to get a drink, stretch.
Yes.
Hit a dab. You wanna hit a dab, Ellen?
Like
Go ahead, guys.
like where your head's at, Proud.
Yeah. Feel free to stretch as well, Axel. You don't have to leave just that. Hopefully Witsit will come and give us a little rundown. But
Yeah.
Yeah, we're here, guys.
Stationary Saturdays. Little Reese busy.
I do not care about your raps. I do not care about this track. I do not care. I guess I am rare. Yes, I hear the trash. Take it out back. Oh, you can hear it. You must have your ear to the cash. I'm itching a spaz. I do not hack, but yes, I'm still with the mask. Snatch a beat right out the mainstream real quick. Fuck around, yeah, we gon' remix it. We got you spinning and now you dizzy. You looking like Disney, seeing sixes. All these agendas and all these false flags. How many times till it gets familiar? They've multiplied so many times they form in the line to normalize the pedophilia.
Double heads going to Antarctica.
Shit getting handled. They're gone with one snap of my finger. Yeah, damn. Yeah, I see your ice, your shit be shining, but how many of those innocent African children had to die for those diamonds? Huh? Tell me. They wonder why they were living all so divided, with all those rooms in that big ass mansion with the homeless family sitting right outside it. 1,000 bodies died for that outfit, and you ain't cleaning the blood off it. Your favorite celebrities got blood on their hands, Marina Abramovic, Hillary Clinton. She's gonna send out a hit if you leaking those documents. If you a holistic doctor, they gon' pop your toss you secretly off a bridge. Exposing them, smash the internet, cause we don't fuck with no fake shit. Nah, NASA images, yeah, thanking your highnesses, yeah, for paying the scientists. Yeah, you kneel for the anthem, huh? But you still play for the Zionists. Damn, yeah, they trying us. They splash subliminals. The Super Bowl, the halftime show. No, That's a ritual. Global warming, climate change. Next year will be a new name with a new tax and a new op and a new fear for a flu strain. Oxa text the new Dr. Moreau and they teamed up with the synagogue of Satan. Yeah, I see what you can do in Q, but I still don't trust the administration. Nope. They drinking adrenochrome straight from a child's throat. You sitting down with that vegan meal, but you still drinking a diet woke. Lady Liberty screaming, covered up in that emotional looking at me like I'm the devil, but I don't see him though. Mad Murdoch, all these dark occultists and globalists, the ones causing a mass murder. They try to swerve at me, throw the curve at me. So I had to flat earth them. Listen, boy, I don't care what you say and all the bullshit that he said, she said. All I care is about you waking up. If you don't, you gon' get hurt. Him, you need that. Let the 5G spread, and you gon' see there's a bunch of pissed off and stressed Americans. Say hi to my friends, they're all domestic terrorists.
I can't see your comments in my room. Can't take back the hammer I gave you. It's to the point where I just can't debate you. Bet I cannot change you, so I must disgrace you. Oh, easy to call us dumb. I know you love the sun. Listening to Bill Nye instead of your head. Put on another sock, you're on the chopping block. I won't let you forget me. You came in failing and trolling in our chat room. I know that you want us dead. You take prescriptions to make sense of your model. I know it's all in your head.
Dizzy.
I have these lucid dreams where Earth is not spinning, thinking of globes in my head. You were my everything, sticks and balls prove nothing. Now I'm just better off dead. I do it over again, I didn't want it to end. I watch it blow in the wind, I really wish I had friends. Did this shit in the past, but I want it to last. Globes are made out of plastic, babe. I was tangled up in your spastic ways. Who knew astronauts really didn't go to space? You give me a globe that was spinning with hate. I gave you my ball and you made that shit break.
I love Saturday.
If you lie to the government, they'll put you in prison. But when they lie to all of us, it's called
First Binary Saturday.
guns away, we'll save our kids from the killings. But you're pro-choice, abortion kills way more than racist. It probably isn't safe to encourage immigration. Just saying, all the contradictions are embarrassing. You know who hates America the most? Americans. Trigger warnings used to be on TV for seizures, and now they're everywhere to protect millennials' feelings. He, she, his, him, hers, them, they. Screw a pronoun, cause everyone's a retard these days. Hear them preaching at the protest that hatred's the problem, but hating straight men, white folks, and Christians is common. Coca-Cola telling people they should be less white. They preach intolerance, but if you disagree, they fight. There's a race war here, elections based on fear. Black lives only matter once every 4 years. Soldiers died for this country, and every one of us benefits. Give welfare to the bums and forget about the veterans. Black folks and white folks divided by the news, but we are all the same. We are red, white, and blue. Ashamed to be American? Okay, that's cool. But honestly, we are all ashamed of you too.
Y'all are so fake. Oh no, the forecast said that there'd be snowflakes. Whoa, you can make us see it your way. Another one. Leaning throwback. More flames. Oh no, no more snowflakes.
They set us up to fail, that's what they built the system for. Put an ammunition shop across the street from a liquor store. Empowering women used to be different than this before. The role models got OnlyFans or dance on a stripper pole. Screw it, I ain't tripping, I don't mean to be mean, but if our children are the future, then our future is bleak. They take an Adderall to focus, hit McDonald's to eat. They're addicted to phones and they take Xanax to sleep. They blurred the lines dividing communism and democracy. In 2021, we paint the patriots as Nazis. The men playing women's sports get trophies for winning. Like, great, let's celebrate a man for beating some women. If you're black, your life matters, you're supposed to embrace it. If you're rich or you're smart, then you're probably Asian. If you're gay, then you're brave, all of that I'm okay with. But if you're white, the stereotype is you are a racist. Blaming capitalism like that's the reason things are tough. While you tweet from an iPhone and sip on a Starbucks, you're supporting what you stand against. You go, you are a Percocet cigarette addict don't donate money to pharma. Damn, dog, we're all afraid to speak the truth. And the more afraid we get, the more we hate the ones who do. You're ashamed to be American? Okay, that's cool. Because honestly, we are all ashamed of you too.
Y'all are so fake. Oh no. The forecast said that there'd be snowflakes. Whoa. You can make us see it your way. No way. Gasoline and propane. More no more snowflakes.
We can all get along, but there's no stopping. Everybody's wrong, that's a real problem. They don't want to hear it, but they still talking. Soon enough, we running out of options. This ain't gonna end till it's in the coffee. We ain't gonna be friends till we try to squash it. I don't know how we can make amends or we drop it. Snowflakes melt when it's hot, kid.
Y'all are so fake. Oh no. The forecast said that there'd be snowflakes. Whoa. You can make us see it your way. No way. Gasoline and propane. More flames. Oh no. No more snowflakes.
It's an evil world we live in.
Some stuff just beach ball. You just don't. That stuff is flat.
Check it out, did you know that the earth is flat? It's flat, it gets a ball, and you know that's a proven fact. What if I told you pics of earth were made in Photoshop? And astronauts are actors acting in a movie plot? What would you say? What would you do when you find
No club on Friday, no club on Saturday.
You globe is about to turn into a bunch of flat earthers. Just ride the wave, cause you know that y'all bad surfers. Ride the wave.
Or the ice.
That's not the curve of the earth, right?
At that height, you don't see the curvature of the earth.
Tell them, Neil.
That stuff is flat. That stuff is flat.
Stay here in Florida! SpaceX is moments away from making history! 8, 7, you see the crowd! 4, 3, 2, 1, blast off! It's fact that
Bully me out here.
it's flat. It's fact that the earth is flat. It's fact that the earth is flat. It's fact that the earth is flat.
Y'all want us to keep going?
It's fact that the earth is flat. It's fact that the
Y'all want us to keep this thing rocking?
It's fact that the earth is flat. It's fact that the earth is flat. It's fact that the earth. NASA allows us get to around 1962ish. They tried to get through it the very first time. Mushroom clouds filled the sky. The Soviet Union and US got denied. The other side of the firmament, they couldn't access it. About that time, they invented NASA ships that couldn't pierce through the sky.
Tell a Globy grab a coffee and pull up,
I
man.
wouldn't imagine it, and I ain't acting stupid when I say that space is fake. That this ain't no adding to it. See, the Masons made the Matrix maze and used religion to take away your faith. Hey, I guess I was just saved by grace, woke and not just a daily eighth to the face. And for a second, I ain't know if I should do this song, but then I thought, ain't no one could prove me wrong, cause it's fact that the earth is flat. It's fact that
Good morning to the
Well,
motion.
now there's a lot riding.
fact that the earth is flat. It's 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 fact.
Horizons broader, going on this adventure, searching for the reasons why. All I see is this flat water. With a telescope, I can see farther. It's a curvature.
Bang that thing, girl.
Now that I'm awake and I can't turn back, and the space is fake and the earth is flat. Look inside your soul and you'll also know that it's not just me. There's a curve on the earth and to me it's surprising. Now I know earth is not a globe. NASA
It's not a globe, sing it with me.
glow is shining, but after all, earth is not a globe. Oh, it's not a globe.
Hey, stop moving your hips like that in my space.
I know you think you're educated, but you're simply indoctrinated. They're trying to control your mind, teaching us things that can't be proven, like Big Bang and evolution, but we're actually all divine. My eyes are open wide, all my fear is gone. God is on my side. How could I go wrong? People seem so blind to what's going on. It's not hard to see.
Airy success.
See the sun as it shines on the sea, local lightning. But they say
No Snell's law can't save you.
sometimes it just seems like they're not even trying. There'll come a day when people say there's a curve on the earth, and to me it's surprising. We all know where there's not a cloud.
Catch him in the labby.
And secondly, when you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see.
I don't remember seeing anything.
9 steps are what you take, walking on the moon. I hope my legs don't break, walking on.
This time I'd like to introduce the Apollo 11 crew, astronauts Neil Armstrong, Michael Collins, Edwin Aldrin.
Bob, what the hell you doing? What the fuck does Stanley Kubrick have to do with astronauts and movement? Who the hell you fooling? Fuck you and this whole stupid flat earth movement. Well, you don't like assuming if the science proving you a college student shouldn't be assuming green screen, sound stage, soundproofing. Time to gotta use my tools in a glass case, astronaut suit, footprint don't match the boot. Been to the moon once and ain't been back since. And I'm just trying to figure out where the tax dollars went. NASA.
You want me to knock you in the head? Well, I want you to swear to God on the Bible that you walked on the moon. If you walked on the moon, we're given the opportunity to swear to God that you walked on the moon. I'm going to give you the opportunity to get the hell knocked out if you don't leave me alone. Swear to God.
Walking on.
Well, I take your stuff and get the fuck out.
Not a huge fan of the award for the best rapper, but they give the Moon Man award to the best actor. Guess we must go straight to the source. Let's ask NASA. How do you explain the occurrence of lunar waves? Why do we only see 1/2 of the lunar face? How do you explain air bubbles you view in space? Why is it so important to lie to the human race? Million-mile internet that travels light years, but they can show a space shuttle re-enter the atmosphere. Okay, to blast off, you gotta practice Freemasonry, an acronym that stands for not a space agency.
Some may say, I'm wishing my days away. No way, and if it's the price I pay, some say, tomorrow's another day. You stay, walking on the moon.
Put your hand on the Bible. Swear to God you walked on the moon.
Mr. Several, knowing you, that's probably a fake bite.
Blasphemous.
Hosting the show, we're breaking the molds. Every Friday night, we gather round to dive deep into truths that astound.
Bomba God.
Leo's in the house, with facts so clear. He's on a mission to make things appear. Flat Earth believers, we stand tall. We're breaking barriers, we won't fall.
Good morning.
Days all night we go interstationary Saturday. Don't you know Theo keeps proving? Oh, won't you see the beauty of the world that's flat?
What's up, level heads?
You want to talk to me about fucking flat Earth, motherfucker?
Fridays all night. We go into stationary Saturday.
Glow clowns, you gotta get a life, bro.
Keeps proving, oh, won't you see the beauty of a world that's flat and free?
So it's just flat as fuck.
The beauty of a world that's flat and free.
Flat earther like Tesla. Here's a flat earther.
Welcome. 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 Awesome. Thank y'all for staying with us during intermission. You know, I don't really know. Sacred, Taylor never came back. Neither did Woodsid. I wonder if they got caught in the etherical Tesla wind or ether wind.
Not the Tesla wind.
Not the Tesla wind. Guys, pray that I find paper. I'm gonna start with putting on my oculars so I can see.
Detachment upgrades. The accessories.
Yeah, they just don't make bots with 2020 vision like they used to. Ridiculous.
Updates coming soon.
Do I need to extend my power grade to another cup of coffee, or you know what? No, we could wait. We could wait to see if Witsit comes back. I want one last update.
Probably moving around.
I know.
Both of them too. Taylor be on the move.
Boots on the ground. Tweeted at some intellectuals. Somebody said a word earlier that was funnier. But I tweeted at some intellectuals earlier. Maybe some of them will catch the bite or bait early this morning, 7 a.m. and whatnot.
I mean, of course, every physicist is up at 7 in the morning and want to talk about physics.
Telescopes filled with water action.
Shout out to the telescope lads.
That's what my question to you was that I sent you, because I seen somebody who has a PhD in fluid. Wait, what is it? Fluid mechanics, I gotta go look again. I don't know. I already forgot. Something about fluid. But I know fluid means motion. But regardless, I was gonna ask him about light and if light slows down relative to its medium or relative to the speed of the medium. Just to see what he says. I want to find other globe earthers that agree that light slows down through a given medium, which, you know, I thought that was like agreed upon. Apparently not.
You can just like transform your way out of, you know, foundational physics.
Add the Transformers soundbite to your soundboard. Transformers, robots in. That's a genius idea. Do it. Just for the next Glober that says that. And we need one for them saying relative to what? Oh, I did have a question. Where did I put I'm gonna go to the closet. Don't let Shane hear that.
Hello.
Good day, sir.
So
this Louis Apple from TikTok. What up, man?
What's up, Sacred?
Oh, hey, man.
Good to see you, bro. I sent you the link. I seen you was active.
Yeah. I'm just testing it out. I was actually gonna start my day. My girlfriend just woke up, but I wanted to test this X out and see what it is.
Yo, it's good to see you, bro. I wish you had just popped in a little while ago. We had a CERN physicist up here we were kind of talking to for the last couple of hours. It was pretty interesting, back and forth. I'll send you the link. But yeah, man, we up here just chilling. It's stationary Saturdays. We're keeping it rocking. And shout out to you for pulling up, man. Y'all follow Louis Apple, man. He be going crazy over on TikTok.
Yeah, I'm mostly on TikTok. I don't post videos or anything, but I like the debate platforms over there. But it's the only debate platform that I know, so I'm kind of new to. I'm gonna start debating probably on modern day debate too, with Enoch, with Nathan.
Right, shout out Enoch. He pulled up. I seen him in the listeners about 2 weeks ago. I think during the holidays. Over there going crazy on TikTok too. He did the TikTok lads, y'all. My guys. I'm gonna start sending you some spaces from some of the squad over the week. They got spaces where they have these type of conversations too. So that way you could bounce back and forth between the platforms. They always got something going on TikTok, y'all. They do like TikTok lives every day. It's fun though.
Yeah, I'm gonna start to try to reach out with more platforms. So you're Sacred. You're gonna be my guide for X. That's for sure. You're my guy.
All right, just let me know, man.
All right, I'm gonna leave and start my day. Go take care of the wife and kids. Have a good one, Sacred, and everyone on the panel.
Pop back in if you got some time later. That's super dope. I was kicking it with him in a TikTok live, I think the day before yesterday. If y'all want to go see us in action on TikTok, it's at Sacred Keys. And he said, yeah, Sacred, man, I'm going to pull up the Flat Earth Fridays, man. I don't be on Twitter, but I'm going to slide through. That was pretty dope.
I was gonna say, speaking of TikTok, you want to play any builds from TikTok, or you want to play any of the stream from Jaren?
We could. I know Witches said he was gonna go live. Oh, is that what he's doing? Hold on, let me check. Make sure he's not. I remember he said that he was thinking about going live.
Yeah, and he got a fan base to keep updated, so I feel it. Maybe we'll merge platforms. But yeah, check YouTube land. Shout out to YouTube chat. W's in the chat. Spam frothing globers, if you're hearing me right now. Also, public service announcement. If you drive the blue Nissan, please, your lights are on. Please, your lights are on. Update. I did not find a raw paper, but that's okay. We'll make do with what we have, guys. I have some Globe Earth NASA propaganda in my phone that I forgot to post. I need to make the thread, because I don't know if you guys were here last week, but Aurelian was talking about the shoes that he posted. I think he was like their BMX shoes, some type of sport Ooh, is BMX a sport? Okay, guys,
But we ain't see her really in this week.
That's what I said
Maybe
last
we'll
week.
catch up with them.
Oh, true. Maybe the space that they were running like took them out. That'd be happening. Ken probably gonna roll in here in a little while. I gotta make a thread though of all the NASA propaganda that we see just rolling around this level plane.
Hey, anybody new to this, I do advise y'all go look up some NASA bloopers.
Are
Just
you
for some
talking about
surface
when
stuff.
it glitches, Secret?
You say what?
Are you talking about when it glitches? This is my Glober voice. That's just editing issues. That's just compression file issues. They can't save the files from the hard drive of the ISS because it's working off of calculator computability. So of course the footage is going to transcend and be trash when they save it. Of course it's going to have glitches and people disappearing. Of course the color is not going to be on the actual object that they're showcasing. Like, what do you guys expect? 4K quality from a toaster?
It do be like that.
A1 level gaslighting. Yo, Lucy. Lucy said it earlier. She was like, yo, sometimes the Globers are so confident that it makes you think like maybe you're wrong. Maybe we gotta rethink something or figure something else out. And I thought the same shit when Globy McTardface was up there saying that gas pressure isn't fucking atmospheric pressure. I'm still not gonna let that go. Sorry, I'm cussing. I'm still not gonna let that go. That pissed me off. Like I was so tuned in, trying to understand like gas pressure versus atmospheric pressure. Like I was so tuned in, only to find out it was total rubbish, ridiculous.
They get to say anything over there.
We gotta put a stop to that. We need a fallacy detector immediately over when we get on TikTok. A specific sound that they know is dedicated to fallacies. Gosh.
It's very different pace. I'll tell you that much.
Yo, just thinking about hosting another live over there is making me tired.
Yeah, we ain't been live over there in a while. We need to actually go do that. Yeah, y'all might catch us over there next week. I'll keep y'all tuned.
Austin.
That's one thing I haven't talked to them about yet. I haven't gone to TikTok and talked to them about Airy's failure. I'm gonna do that this week.
Ooh, who are we looking at as a target? Is it a friendly conversation or is it like
Any globe earther that
on the ground?
any one of them. They out.
Like
Look,
side flat earther versus Glober.
I mean, we don't got nobody blocked, so
No, the ones who are worth the conversation are usually awake in the daytime. And the trolls are usually up at nighttime.
if they're in Antarctica, it's always daytime.
I wonder if Jake's
There's definitely better conversations than others.
Yeah. I don't think you've really had too many interactions with Mecca, but the last two interactions I had with Mecca were actually really pleasant.
I don't know the names of none of these guys.
The Globers ruined it for him, so I'm glad he got to see like what his own people. Sometimes they be your own people.
Yeah, they definitely got a lot of weird stuff going on in their community over there in the globe earther TikTok lads. But something's cool.
Yeah, I want to say he's a PhD, but I don't really know for sure. But he's someone in the field.
I'm just tossing that shit around, bruh. Ain't no way.
Is Alan talking?
I don't think so.
Yeah, that one intellectual science lab, when I was talking to them, I was talking to like the globe earthers, but you could tell he was like a distinction. Like he was trying to separate himself from the globe earthers that were in there, or like the anti-flat earthers that were in there, and like being a science lover. Because as soon as like they crashed out and kicked me out, he was like DMing me. He was like, "Oh, I'm sorry about that. Those guys, you know, they see it's flat Earth, globe Earth. They don't care about the sciences. Thank you for engaging. We appreciate it so much. Anytime you want to talk, I'm here." He was like really trying to separate himself from those guys. So I want to talk to him. If we could catch him in a live, I want to talk to him. And the nuclear energy guy, I don't know if there's a sector of electric universe Earth, but that's what I call him. I don't know what field that is. Maybe Franco could tell us later. But the electric universe guy is pretty cool too. He has an accent. We should bring Newton's bucket to some of those guys too. I feel like Jorge tried to address it, but like
I gotta get my TikTok folders right, man.
Oh,
I
yeah,
gotta get organized. They be fast with they backdrop.
yeah. I gotta like proportion it out so that it automatically fits to scale. But it's hard to know.
Yo, y'all tell Elon we need video spaces already. I've been out here blue checking for a while now.
Baby, you know, sitting there, oh, can you help me find peace for yourself? You boy,
Bro, you is hot micing like a. So today is the day. Squad gonna be touching down on ice for real. Temperatures looking in the negative 10s to 15s. A little cloudy out there. I don't know. I do hope that it's a safe flight, of course, obviously. I'm glad they're going to be comfy with enough room. They did say that they didn't know. At last minute, they told them that they could have brought more gear. So they were planning for bringing a certain amount and didn't realize that they were going to be able to bring more. So they were kind of bummed out about that. But at least they were able to get whatever they needed for what they planned to take. So that's cool. They said they are suited and booted. A lot of gear. A lot of equipment. To keep sanitary sounds crazy. Like the stuff that they got to go through. That's gonna be a wild week, man. Oof.
Can you ship a package to an airport, or is that like hella illegal and sus?
It's a good question. It's a little sus, but
I was thinking about that. If they weren't able to actually carry things, could you ship it to them? Probably costs a kidney, but I'm
too late for that now.
Oh yeah, definitely. Retrospect.
D3, is your hand up?
What up, D3?
Yo, what up, guys? I was half listening in for a little while. I just heard it kind of get quiet, so I figured I'd ask like what I missed because I had an internet outage, man, and that was for my phone and my home Wi-Fi, so I couldn't really get online.
It's because
Wait,
of
they
the
hit you out with
volcano.
an ERP?
There's a volcano. I'm telling you.
So what I missed? Did I who came in earlier and stuff? Can I get a recap?
We basically went over the Airy's failure. Some more little deep dive. Franco came in. Say what, bro?
Franco was here again.
Yeah, the resident CERN physicist.
We gotta ask him if he uses proton mail.
You never know.
You never know.
He hit us with a few transformies and a couple Snellies.
Did he ever come to?
No. I mean, he did acknowledge that stationary Earth would limit a lot of the issues, but he didn't actually acknowledge it in that way.
Mm-hmm.
He was taking to the approach where I'm gonna use current information in my current calculations to explain what's actually happening, as opposed to understanding the implications of what we're observing. So he's saying, well, I can use my own calculations and I can describe what's happening. I don't have to refer back to that. But we couldn't get past like, okay, even with that being said, like it's incomplete. There's a prediction here that's not being met.
Yeah.
Just some foundational issues that we were just not seeing eye to eye. But Alan did a really good job. Yeaza was in here. A couple other guys in the squad was chiming in. We also had Joe Hanvey. I don't know if you heard Joe Hanvey.
Nah, I missed. I think I missed all of that. What time did you guys start? Normal time?
About 7, 8-ish West Coast.
Yeah, I missed it all. I just got in like an hour or two ago, and I wasn't like fully on board. I was doing a bunch of stuff. Where all the globies at?
I know they ain't clock out on a stationary Saturday, did they?
It's time to get up, folks.
I mean, Axel been here, but Axel been kind of honest. We call Axel on a good day.
Oh,
yeah, we call Axel on a good day.
That's good. I think I've heard Axel speak before. What was the topic of convo with Ax?
Still about motion of the Earth. And maybe taking a re-examination of cosmology.
Now that my internet's back and I'm about to look at I'm about to see if I could get information, like where to get information for all of the plane survey stuff.
So was it just the internet? Was this the internet, or was it like electricity?
Nah, it was home internet and my phone service internet. So I had no internet all day. But finally it's back. It's all good. Back in business. I just knew I missed a whole bunch, so I wanted to see, what happened and stuff. What's going on with WITS? I heard you were just talking about WITS. You said they're arriving soon?
Yeah, so they're hopping on a plane in a couple hours to make it over and touch down in Antarctica. That's why we Antarctica and chilling.
Where they at right now?
I think they're in, is it Punta Arenas?
Okay.
I think that's
I
what
saw they did a live like a few days ago or something. I saw that.
Yeah, I think they did another one last night.
Oh, I didn't see that
I was thinking about playing it. There are a lot of people in there.
That'd be dope because I didn't watch it yet.
Yeah, they were just kicking it, chilling outside, thinking about what some of the things that they're going to do. Kind of recapping some of the interactions that they're having with some of the other globies on the trip. It's funny.
This is so cool. I hope they can live stream, man. I hope they can live while they're down there. That'd be dope.
Yeah, they
You
were
know,
talking about having some type of connectivity.
yeah, that'd be dope. You know, they're gonna be quite famous after this, I think, because whichever way it goes, they're gonna be on the mouths of all of the Globers and all of the antis. Either way it goes, so they're gonna get a little bit more fame for this, and due to that, the spread of this idea, and then also just how it is in Antarctica. Like, a lot of people don't really see what's going on in Antarctica, and get like a real like amateur video from there. So this should be pretty cool, man.
Right.
What up, TM? I see you down there. Mr. X, Bryce Sweet.
Squad. We have Pete Glowinski pop in here too.
Klobinski. Okay.
When Wiz was in here, he was like super tired. Like, you could tell. I know he had a long day, and then you got to get on a flight this morning. So
Yeah, this is his first time out the country, so he's probably not ready for those flights.
right.
Yeah, his jet lag is gonna be crazy the first day. How long they gonna be there? A week?
I think it's a week, right? Right, y'all?
That's good. That gives them enough time to do, a bunch of different things. That's what's up. I can't wait to see all the footage.
Keon, if you're still in here, bring your bean head ass up here.
Oh, Bean King.
Yo,
What up, Bean King?
Is that D Thrice?
What's up, Alan? What's good? Yeah.
What up, dude?
Chilling. I just heard Bean King get called out. What's probably why we calling out Bean King? What's good with that?
Cause I just want to see the temperature. I'm just testing the temperature. He said today was gonna be an interesting episode of FEF, so I want to know what he mean by that. That's
Oh,
all.
he was talking. Yo, Keon, where you at, Keon?
Kiki with the anti-flat earthers. I just want to make sure he have that same energy on mic.
Make sure.
King, you going anti on us? Come on, man.
No,
I had
not
the sweater
Focused
already.
on UAP drones in Jersey. That's what you should be focused on.
not sweet baby Keon.
Yeah, what's up with that drone situation though? That's a little odd. I saw they said there was like 50 of them. What the hell?
One more call out. One more call out.
Uh-oh.
602607876 for OBUX. Don't piss me off. Do not piss me off. I really hope that you having sacred spaces in your name is like a term of endearment, but do not piss me off.
You don't even have
Carry
a
on,
name. You don't even have a legit name. Meh.
Well, I don't see who that is. Brian Sweet in here. What up?
Well, good morning, everybody. How you doing?
Top of the morning.
Brian, you'll be pleased to know we got to the bottom of the telescope filled with water situation, bro.
How'd it turn out? Are we moving?
Well, if you want to throw out Snell's law or do a Lorentz transformation, then you can keep it.
Dude, I like the thought of us contracting all the time, man. That just seems awesome. I like that. Just squeeze down, just when we need it, though. Never, you can't really tell it's happening, but
no.
I mean, Why do people come up with magic to explain their stuff? I mean, it's stupid. No, it's slow down. No, it's you're contracting. Everything's contracting right now. Oh, okay. Can we measure that? No.
Nope, you're already contracted.
You already contracted. It already happened. It's too late. But we got a mathematical equation that tells us how it happened. Don't know how we came up with that either. Just we needed it.
602, Twitter is not doing a good job of translating your language. It's just not. I don't know. Try it. I don't know.
Did they
Try
clone me or something?
What happened?
What happened?
Did they clone me or something?
Looks like they starting the process.
So,
I mean, do you feel like it's disrespectful for someone to have Sacred Spaces as their Twitter name? I mean, if not, then I'll leave them alone, but I'm spamming in my mic.
so you guys know they gave these guys little tracker beacons, and I don't know if you got that Telegram or whatever for a Wetzik, but it's got a little app on there, or a website or whatever, where you can track these guys as icons.
The GPS track.
Yeah, there you go. So right now, it's still showing them in South America. Are you sure they're on the plane?
No, they're not on the plane yet.
Oh, I thought you said they were flying already.
In a couple of hours, they're gonna board.
Man, but when you look at this, man, these guys are far apart from each other. I don't know what they're doing, but
Are they really? I thought they was in the same hotel. Maybe they just want to stay far, far away from each other.
I mean, they're like really, really far apart. It's like, I don't know. Didn't they say they had to, what? Are they on the same time as, it's like, what, 5:30 there right now? Anybody know what time it is down there?
Yeah, they're 2 hours ahead of Eastern, so 9:37 a.m.
Yep, 9:37.
So it's 9:37 a.m. there. They're 4 hours ahead of me? That's weird. They're like right below me. That seems odd. But I thought they had to get on the plane at 10. Their time.
Might be 10. Wish to give us a rundown, but I forgot. I ain't gonna lie to you.
Dude, they were going.
Dude, I've heard it 700 times since this all went down. I can't remember a single time or date.
Dude, I that's what I'm like. They were going over the time differences yesterday, and I was like, that's why I'm like, what time is it? Because the way they were talking, the way they were posting the video, I was like, is it Saturday down there? It seems weird that it'd be that far ahead of us. But it seems weird that they're 4 hours ahead of me. It seems weird.
Well, what time zone do you live in? You Mountain Time or Central?
Dude, I live in the only time zone that got it right, man. We don't have to mess with our clocks, man. I don't know what the hell y'all do.
Oh,
yeah,
so
Mountain Time.
okay, yeah. So yeah, you're 2 hours behind me. By the way, the Eastern time zone is the only good time zone. Your time zone's 2 hours incorrect.
No, you guys got to mess with your clocks, man. We just put it at us and we leave it, man.
Dude, we recently decided to stop this time for realsies. We definitely promise, and we so super promise that our mayor or whoever's in charge of that stuff, wrote it into legislation. So they're serious about not doing it this time.
Man, that would be awesome. I'd almost trade fluoride in the water for stopping the time zones. Give me some more fluoride, stop the time zones. That's how much it bugs me. But But yeah, I think it's funny that they get down there to Punta Serenas and they say, hey, you know what? You guys can carry more luggage if you want. They didn't know how many people were going. I mean, how many people are, how often do people do this trip? It's like they had to know it was 9 people all along.
Right, they're going to give them a heads up.
Hey, man, just so you know, it's only you guys going to this really cold area that no one really goes to, so you could probably do more. What are they taking? What did they say? A 757? That's a
big old plane.
They said they had to get in there. They can't even shut off the plane, man. They got to just drop everybody off and get the hell out of there because it's so damn cold. No, we out.
Does it rain in Antarctica?
It's what
desert?
Does it? That's a good question.
It's a desert.
Yeah, but it's supposed to have
precipitation.
It's supposed to have what?
Snow come from?
And it's supposed to have what? 0 really low refractive index or something like that. So you should be able to see really super far.
Brian, don't you know that when it's cold, that's when the gradient's at its most extreme on the inversion, creating the most refraction, Brian? Come on.
Man, I gotta say, man, I hope they see a rainbow down there. Apparently it's supposed to be pretty darn close to the surface.
Yeah, that would be dope.
No, just ice.
And kind of flat, too. Have you seen that?
Yeah, it's supposed to be really slow and flat. I was like, oh, man, you got to see that. So have you guys seen that Crow 777 video where it's showing like 2 suns?
Yeah, I've seen it.
What do you think about that? They were pretty close.
Not a lot, honestly. Like the way it was proposed, and it was like there would be definitely like there would be replications of it, like more observations at different points. Those have never manifested, so I'm not sure what was seen there, but doesn't seem to be anything of consequence.
Yeah, that's what I was saying too. I was like, you know, I kept on wanting him to kind of like pan out a little bit to because it was really close up. I didn't really see, you couldn't really tell what he was doing. But Crow 777 doesn't seem like the kind of guy that just posts a bunch of shit either. So.
Right, I like to give Crow the benefit of the doubt too, based on a lot of his other work, where he's just gone insanely hard on the research, and you just listen to him talk about a subject, and you're like, God dang, that's a man who thoroughly investigated the matter to completion.
The way he's talking about those lunar waves, man, it's like good stuff. But yeah, that was weird. But I do not. They're going to have a time of their life, but man, those guys are going to be freezing so bad. Did you see that guy out there wearing shorts?
Yo, he's wearing shorts. We was talking about that last night.
I'm like, where's this fool from, man? At first, I thought it was MC2. I was like, is that Tune? Out there wearing shorts. Did you hear about that little dust up they had? McToon wanted to film everybody, and he got checked on it.
We had to sign a contract.
Well, you know what's funny is Will Duffy's a little shisty, little sleazeball, man. This guy's supposed to be like a pastor, a man of God. He comes out, puts out a video, and says, you know, sometimes globies irritate me. And I was like, all right, you're going to say something. But no, he's all like, he was talking about this situation, and he was playing it off like he didn't know about it. Like he didn't know, you know, MC Toon was like, you know, #1 troll of the world, and his main target is Witsit. You know, it's like, come on, really? But he's all like, and I asked him to do me a favor and not. No, bro, he's all acting like this came out of the blue, and he asked MC Toon to do do him a favor. I'm all like, it was like a 10-minute video. Sleazy slime. He could just say, hey, man, you signed a contract. You can't do it. And put him in his place. No. He made it sound like he asked MC Toon to do him a big old favor, and he agreed to it. So MC Toon's the hero here.
Oh, big old virtue jerk. Dude, that's cool.
But nope, you signed a contract. You can't do it.
I don't watch any of his videos. I would think they would want to control the narratives.
And apparently, you can even tell them you can't even have me in your panoramic shots, too. I would be that petty. I would.
I mean, if they was down... My bad, go ahead, bro.
Yeah, we were talking earlier about like what we think the narrative is. If it's not a hit piece, they know they couldn't get that accomplished this time around, like Netflix did last time. The narrative will be to still have two sides of the story. So it's going to be the future generations looking at this like, well, how the fuck did flat earthers and globe earthers go to Antarctica and they both have different stories? Like, that's going to be the new narrative in the future. Like, well, it was inconclusive because the globe earthers say one thing, but the flat earthers are also saying another thing.
Well, you got
that's the new narrative.
I think Will Duffy's already planning his second adventure. Now he's talking about a 24-hour moon. Oh, so that's definitely going to put an end to this argument if we see that. I'm all like, bro, I live in Arizona. I see the moon in the daytime. What are you talking about? What are you talking about? This happens like all the time. Matter of fact, I was on a space at 6:15 in the morning on a Friday. I was looking up at the moon, and it was daytime. It was summer, and I'm looking at it. It's got a little bit of waning going there on the bottom right there, and I'm talking to my friend there in Australia, and it's 11 o'clock at night, and he's looking at the moon, and the waning part's up at the top left. And I'm like, how the heck are you seeing the moon? We're on a ball, and you're on the other side of it. This seems impossible. What kind of mystical magic are you working on me? He's a Maori guy, he could have whaled a spill on me. I don't know, man. Those Native American or Australians, man, they got some mojo going on there. He put a whammy on me. I don't know. Maybe I didn't see the moon. Maybe it was refraction. No one's ever explained it to me, though. How could that be possible?
Welcome to Flat Earth.
I'm telling you, man. But that's his new thing now. I think they're gonna come up with. I don't know. I hope they get some good stuff. But they got there and they showed I don't know if you've seen any of the live feeds in there so far, but they got a lot of cloud cover out there. Lots of clouds.
Yeah, we was looking up the weather last night. It's a bit cloudy this week. And then next week's supposed to be like super sunny.
How long are
I'm
they?
pretty sure they'll get something. They got to.
And they're going to be down there for what, 5 days, you say?
Yeah, I think so.
5 days in that cold, man. Whew. I was looking at him at the Punta Arenas going, man, that's freaking cold. What'd they say? It was 28 degrees? That's stupid.
All right, lads. I gotta go to bed. I'm passing out here.
Trooper, man.
Good to see your space audits. Shout out to the YouTube chats. What you got coming up this week, bro?
All right, we got Dr. Heffron coming back on Tuesday to do a Prezi on debate, like how to, form arguments and some tips and stuff like that. He's been inspired as of late watching us debate, cosmology and flat Earth and stuff. So he's gonna come by and drop some tips.
When
and
is
then, that'll be on Tuesday, this Tuesday. And then Thursday we'll have research and reading night. And then Friday will be Flat Earth Fridays. And then I think next week Bennett might be doing some prezzies on the alpha model, Newton's bucket, and Einstein's train or something like that.
Is that the train with the bomb?
No. Well, yeah, but without a bomb though, like in there, But yeah, same thing.
I'm still not getting on the train.
Nah, definitely not. Especially if it requires a Lorentz transformation. Never trust a second order interpretation of reality.
Right?
Damn transforms.
I mean, at what point in time did somebody say, "Hey, you know what? I think everything shrunk," and somebody said, "Yeah, go with it." Serious? How do you bring that up,
dude? So what has to happen is you have to have an undying belief that the Earth is in motion. You have to have some philosophical bias deep inside of you that's like, the Earth is in motion. It's nowhere significant in the cosmos. Like that's your fundamental axiom, right? And then you have to start doing experiments where you're measuring absolute velocity with light. And you're like, oh, dude, you know what? I bet you I could measure the Earth through space to confirm my philosophical belief system that the Earth is nowhere significant. I'm going to measure the shit out of this bad boy. And it's going to confirm all these equations I've been applying to the sky that definitely substantiate my cosmology. But then you start making those measurements and none of them give agreement to any velocity predictions that are mandatory for your cosmology to be true. And then someone asks you, they're like, hey, bud, how'd those measurements go? Well, I heard you were building an interferometer to test your cosmology. And you just got to go, oh, you know what? Funny story about that. I didn't make a measurement difference because my whole apparatus contracted. My dog ate my homework. It's like same thing. My dog ate my velocity.
The first time I saw that, I was watching The Principle, and I'm still trying to even learn what this whole experiment is. Is like a year and a half ago, whatever. And I was all like, "Wait a minute, what?" I rewound it. I was like, "Did he just say everything shrunk?" I was like, "What a big cheat!" How do you even propose that we all just shrunk? We all just contracted. Nobody noticed it. You would think you would feel that. Out of all the motions you might feel yourself contracting.
Dude, and not only that, but you're contracted by an insanely small amount, bro. Like the square of the Earth's velocity over c squared, it's like super, super small. I mean, you would never even be able to perceive it in any physically meaningful way. But because you assumed the velocity that you inputted into the equation for the transformation, and it gives you a calculative value of the shrinkage, the change in the coordinate system relative to that velocity as a function of the square of it over c squared, they're like, bro, check it out. I just found the velocity. It's in another reference frame. Like, imagine if you were playing Mario and you just never found the princess.
In the other castle.
And just every level, it was just like, oh, you know what? She was just here, dude. She's fucking Bowser just swooped her up, though. She got to go 10 more levels and see if she's in that one.
Oh, shit.
By 2 seconds, you could still smell it. Man, I just can't see a bunch of reasonable people that are trying to do this say, hey, we all shrank right now. And everybody said, yeah, we're going to go with that. But then again, they adopted relativity. So,
yeah, they fought it for a while. And then they were like, oh, you know what? We actually can't explain this any other way. And like how Franco was kind of sarcastically saying, oh, I guess we'll just throw out Snell's law. Well, that would be, if you did that, you could keep Earth's motion for sure, right? But what they ended up doing in a similar respect is they just threw out the ether. They threw out that absolute frame. And they were like, oh, you know what? You actually can't tell because all motion's relative to other motion.
What kills me with Franco is, man, he'll sit there and argue and argue and argue and argue, and you actually get him pinned down on something. He goes, well, I don't know. That's not my area of expertise. And it's like, I don't have to answer it.
Yeah, but in his defense, that's like an academic training thing because it's like you're so specialized in your field, you know, you feel like if you were to comment on someone else's expertise, like you'd be way out of pocket, you know? So I think it's like there's a level of like professional courtesy / indoctrination to like, you know, just trust that everyone's just as up to snuff as you are in your respective or in their respective field.
Oh, I get it. I get it. That piece of paper, man. What do they call that? Compartmentalization. Everybody loves a little bit. No one knows a lot. No one's going to step on anyone's toes. I think some people should step on some toes.
That's what we doing over here, man. They don't like it.
I mean, I thought, you know, isn't science there to be to challenge the status quo? Aren't we just challenging the status quo? What's wrong with that?
No, they only allow that kind of stuff in Russia, apparently.
Here in America, you can form. You do it this way. How dare you have a thought for yourself?
Yeah, Sabina Hoffensfelder or whatever said it best. When I graduated from college, I had a dream, and then my other dream was to get paid. So I had to let go of my first dream to continue getting paid. And then now I'm super spiteful and resentful because I had to give up on my dreams to get paid doing nonsense work. Paraphrasing, of course.
I think saying this is outside my area of expertise is often a polite way of saying that you've run into the end of my chain of explanations I can give you. Like, you know, explanations for anything have to end somewhere. And, you know, people can, and at some point you have to be like, well, okay, I can't explain this any further to you. Like, it's, you know, you've reached the limits of my understanding of like how a tree works or whatever. And so if you want to know more about how a tree works than what I can give you, you're going to have to find someone with more specialized knowledge about trees than me. You know, I can be like, well, they absorb light from the sun, and that allows them to, through chlorophyll, generate carbon dioxide and oxygen they use to construct most of the material of them. But if you start being like, well, how does chlorophyll work? Well, I know it has something to do with absorbing photons, but you know, like at some point I want to be like, I don't know that much about chlorophyll. If you really want to know more about it, you have to find someone that knows more about it.
It's a good point. Absolutely.
That is true. I agree. Well, gents, another excellent
Hello?
episode. What's that?
Man, my mic was muted the whole time. Anyway, I was saying good night, lads. I'll catch you on the, you know, when I wake up, or see you guys next week later.
Peace out, brother.
Yeah, I appreciate you, brother.
Yeah, I'm getting ready to head out too. I got a few errands I got to go.
I was muted the whole time. Anyway, I was saying good night, lads. I'll catch you on the, you know, when I wake up, or see you guys next week later.
Peace out.
Yeah, I appreciate you, brother.
Yeah, I'm getting ready to head out too. I got a few errands I got to go take care of. Would you say you're going into Sunday? I might be back.
Bill Flat Sundays. We did that a couple times. Those some long streams, man.
I tell you, man. We'll see. We'll see. You guys are tapped into ether, right? You're good. You're good.
Charged up stationary Saturdays.
But I heard, what'd you say? Peter Globinski was in here trying to argue Airy's failure. He got cooked.
Oh, he didn't want to. He didn't want to answer any questions.
I'm gonna have to. How far in the stream last night did you get before he was in there?
Felt like a lifetime. Couldn't even tell you. Probably too long.
Yeah, I was a little burnt last night. I couldn't stay in too long.
Yeah, they said y'all was going all day.
Only about 14 hours, so it was all good.
Sheesh.
Globies are scared though; they don't want to come in.
I know. I know the feeling.
They ain't got no defense, man. They're all gonna be crying here. What, a couple days? They ain't gonna see no sun. Where the concavers gonna go? What's gonna happen to them?
Oh, we had Concave Earther come up here. He ain't really say much.
They got awfully quiet. They were in my time for a long time. Now they kind of just faded away. They're like, oh.
Hey, Concavers, if you're listening, I don't remember if y'all ever showed me that bottom up construction. Don't be spamming my joint, but I could throw some bottom up construction and chat if y'all want to. If you listen.
I got pubes in my mentions right now.
Oh God. Where he spawned from?
Some Antarctica post frothing at the mouth.
You can come grab a mic for a couple minutes.
I just asked him that if he wanted to discuss the presuppositions required to make his model work, since he's claiming that we're just denying it. He forgot we got him at 4K. Calling interferometric data bullshit. So he might get triggered after reading that. But Pubes and the rest of the Anti-Flat Earth Fridays Discord, you're welcome to join. Clearly.
Oh, they still live? I forgot about those guys.
I'm pretty sure they're frothing at the mouth. Keon was on the timeline convening with them about the interesting episode that this might be. So somebody was streaming us from somewhere.
Keon got shamed back into believing in Spaceballs. And, he was hanging out with the Globies, and they shamed him too much, and he couldn't handle it. He's like, I'm back on Spaceballs.
Bean King, come on, man.
Nah, he's a little weak. This is like his third time living back and forth.
We're going to have to downgrade him from the premium sweater. He's just going to get a t-shirt. I do have a question about the images and stuff that I showed last week. I don't know. When we're talking about the full picture of the Earth, right? That's using some type of modeling and masking and things of that nature that give it the shape that we see in the final release to the public images. But the direct shots of things like the surface of Mars or the moon, these, they're not spherical because they're just straight on shots of a limited amount of surface. So they're not showing you the whole thing. So there's no need to do any spherical imposing. But they have these images. So what are your thoughts on that? Is everyone ready to accept that these are physical objects, or is everyone still, or not everyone, but are some people still saying, they're not physical objects?
You talking about specifically planetary systems or like?
Yeah, I'm talking about the planets and the moon. Yeah, I don't know so much about the sun. Like the sun is another conundrum in itself. But when you look at the images from the so-called space telescopes, they're straight-on shots, and they show what seem to be, you know what they look like. They look like sand dunes, right? And craters pretty much everywhere.
You mean from the rovers pics that are supposed to be from the rovers down there, the Mars rovers?
No, not the Mars rovers,
okay.
although those are really interesting as well. Like, I mean, people can say they're fake, and that's fine. That's fine. But they have the one that I showed last week. They take images pretty often, and they get transmitted back here and then displayed for download. And they look, they look pretty much like sand dunes and craters to me, guys.
Well, they're photoshopped because it has to be. Remember that old chestnut?
Nah, see, that's where I don't see that happening. Maybe it is, but I mean, it's not Photoshop.
Well, how would they take a picture of anything in the solar system? Like if we're chasing the sun at 500,000 miles an hour, and it's 93 million miles away, but all that stuff is going around the sun too. How do we take a clear shot of anything?
Well, what if it's
I don't
not,
see
right?
it
What if
happening.
our whole position is that it's not? So if it's not, then they would just be traveling around in the moving ether the same way everything else is, and they'd be getting their shots.
So I've been like thinking about this a little differently lately.
Mm-hmm.
I found it very interesting that, again, I feel like I said this last week, that they make so much references and they're harping on these solar system, these other planets, Harty, in the sky, but they also blatantly admit that only not even half of them are actually physical objects. So it's like we're arguing with globers who are parroting that these are physical things, but then NASA will say, hey, Jupiter is not really a physical planet. You can't really touch the surface of Jupiter. So it's like wrapped up in the truth of the lie. It's part of the in between the lines thing that they got you. They're going to sprinkle some truth in with some lies. So it's like I'm supposed to believe that Mars is a solid surface compared to Jupiter and Saturn and Neptune and Uranus. So yeah, that's why we're going to Mars. It's like and then you got, well, Jupiter's not a solid surface, it's just gas, but you got Jupiter's moon that's solid. So it's like I want to listen to
You're
them. They're
not
saying,
supposed to
oh, these
believe
are
it.
solid objects, but
You're not
then
supposed to believe it. The rest of the sheep are that will question nothing. Like why did NASA found an abandoned bunker on Devon Island, and no one they're not going to question it. Like what's NASA doing on Devon Island? We know what they're doing on Devon Island. No one
Yeah, I don't
questions
see how
it.
that's relevant, bro. We're talking about images
No, I
from
know
space.
they're filming on the Mars stuff from the rovers on Devon Island.
he's saying all the pictures
Oh
that
yeah,
they
again, I'm not talking about the
given.
rover. So like,
Oh yeah,
I'm
I
talking
know,
about
I know.
I'm talking about shots that we get delivered from satellites that are taking images of the moon and Mars. I haven't really looked at Jupiter yet. I have looked a little bit at Saturn, but the pictures I found were like, it was just like a speck in the distance. So I haven't seen anything like convincing about Saturn. But Mars and the moon seem like sand dunes, bro.
I
Like
feel
I
like
can't ignore that.
Saturn's a little important only because you were talking about the rings, and the rings are
Yeah, it's so
3D
crazy.
looking. But I have this
Hey
photo on
guys.
my phone of this light that's basically doing the same thing. It's literally just a picture of a light bulb, one light bulb in the sky, and there's rings around it that look 3D, and I have no idea where it even came from. I don't remember. But like
Yeah.
basically the phenomena was recreated to make rings. I'm pretty sure people will argue that there's different angles of the rings. And I even seen an article about how like the rings are gonna disappear because the orbit of Saturn or some shit like that.
Regarding
Yeah,
satellite
it's really
imagery,
interesting.
they don't even have cameras on them. Most satellites just doesn't have a camera. You can like check the specs, and when you check the specs, it's just a bunch of infrared sensors. They don't produce imagery without their
No, but
software processing.
that's not true though, brother, because all the sensors are doing is they're picking up radiation, right? That radiation is then converted into electrical signal and run through algorithms that reconstruct it as
Yeah, but they put in
images.
a software which predicts it's a ball. They just take up some light sensors from like green light, blue light, and they combine it into a ball. It's not really an actual image. Never.
They combine it into a what?
They combine it into a ball, like a composite render. So it doesn't even have to be a ball. Even the colors are not real. If like the colors are
I still
not real,
can't.
why would the shape be real?
I apologize, but I still can't make out what you're saying. Into a
Said the
what? What's the
colors
next word?
into a ball. So he's
Into
saying
a
they're
ball.
taking the
Yeah.
radiation pictures and
Yeah,
they're
yeah, yeah. Yeah, that's if you heard what I said at first, like I'm not talking about the full shots of these things, because those, like I said, I did look into that, and those are getting run through um, a model, right? So they're being modeled, and they do have a sphericity in that model because they're using the ellipsoid. So that I understand. Each planet has its own ellipsoid. So if we're getting full shots, I don't trust any of the full shots. I'm talking about specifically about uh, land shots. Like if you're just hovering over one square of land and you take a shot of that land, you're not getting the whole shot. You're just getting a close up of the land. So there is no sphericity there. You're just seeing like a sand dune or a crater or a couple craters, going off of the page that you're looking at, right, of the image. And our technology is perfectly capable of making images like that. So I don't see the discrepancy.
Well, you know where the discrepancy happens when you look at Earth, and the horizons that you find in NASA gallery, you can see a lot of distortion just from comparing lens, So basically, the pictures they take are very likely probably real, but they are all taken with such lens that are not purposely fit for such distance, That's why they show curvature, which folks think it's curvature, but it's just distortion, It's never real curvature, because when you compare same location with same camera and two different lenses, the horizon is different. And so, it's not really curvature, So basically, they all just distort photos that are actually happening, but they never really show us the real deal. You have to know exactly what lens, what camera to look at, just to find something that's not really distorted. So they purposefully use cameras not meant for huge distances because they know it produces distortion. So they can take a picture of a horizon. It's not real curvature, it's just distortion, So it's real pictures,
Yeah,
but
I
it's not
understand what you're saying. I understand what you're
really
saying,
done
and I
wrong.
I agree. But we're talking about, that's not what I'm talking about, brother. I'm talking about over land shots, not looking at the horizon, looking straight down at the surface of an object and taking an image.
Yeah, you never see curvature in those shots,
That's not what I. So all right, you keep referring to courage.
That's for
I'm
people that won't
gonna have
question
to
it.
stop you there. I'm not talking about curvature. I can't be any more clear. I'm not talking about curvature. Let the curvature go, brother. Let that go. That's not in the conversation.
Well, we see
I'm
the
talking
luminaries.
about
What about the luminaries we see through telescopes behind water? It's like somewhere along the line you got see. That's not for the people who are going to question. That's people who question nothing. It's by definition fake to me.
what are you talking about? Yo,
The luminaries,
Proud,
the
help me out.
wandering
What is?
stars, the luminaries.
I was building with Proud. Well, come back,
Yeah.
Proud.
I think if you're talking about, the shots of Mars, you're probably talking about pictures being taken by the various orbiters that have been there over the years, of the landscape.
Right. Do you?
Also,
So, for example, Axel, do you believe in those images? Do you think they're legit, or you think they're not legit?
I think they probably are legit. Who knows if they're airbrushing out all the aliens or something? But I think in broad scheme, I think they're probably right. I will say just real quick about Jupiter. There might be a rocky surface down there somewhere, but there's no real way for us to tell.
Exactly.
It's a giant ball of gas that has enormous pressures, so it's probably we won't be able to build a probe to get deep enough to really figure out what's going on, although who knows, perhaps
we probably could.
Elon
could do that eventually.
Yeah.
But so all right, we can see the moon's surface from down here. You get a telescope, you look up at the moon, it looks like craters and sand dunes. Not so much of the sand dunes, though. Not so much of the sand dunes, just a little bit of that, but mostly like craters and like flat crustiness.
Well, there's no atmosphere on the moon to Mars doesn't have much of one, but it has one. But there's no atmosphere on the moon to blow dust around.
Right. So I don't know what to make of that, because a lot of people in this community feel like the moon is not a physical thing, but we can take actual photos from here that if you get zoomed in close enough, it looks pretty physical. Now that could be,
Oh, y'all.
it could be, you know, it's just our eyes fooling us. That could be the case.
I
But then
wholeheartedly
we have
and
images of Mars where we're seeing sand dunes. So
I think the idea that the sun and moon and planets aren't physical is a sort of, I think it's, I mean, I don't know for sure, but I think it's part of sort of the modern flat Earth
Well, I'm pretty
mythos.
sure the moon is just like some optical phenomena from the sun, you know. Even the sun is not physical, it could just be like a projection from outside the dome, you know. Just thinking it's physical because you can see like some shadow doesn't mean it's actually physical, you know.
hold on, actually, I just got through saying this. Some of the planets are not physical in your model, per your model. They are not physical. They are gaseous bodies. Okay.
Gases are physical. I mean, okay, if you want to say all the planets are balls of gases, I would, okay, sure, why not? But I'd still call that physical. I mean, I guess that was the other question I was going to ask, is when people say, you know, these things aren't physical, I'm a little unclear what, I mean, you know, the sun, I mean, what limited things are directly observable about it is that, like, you know, it's very bright, it emits a lot of electromagnetic radiation. You know, it heats things up. And so if you want to say like a, I don't know, a portal to some other dimension that emits a bunch of light into our dimension and heats the Earth up isn't physical. No, I guess I'd agree. A portal's not physical. Just what it's seeing through is physical. But, you know, I don't know how much, I don't know really how different that is than it's a, you know, giant fusion explosion.
Nah, you guys
I think
argue
in
that
this
these are
community,
physical planets. These are bodies, and we are a body. Why are we spherical if those are spherical? That's the argument that the globe earther side pushes on us. The globe earth says, hey, all the things in the sky are physical bodies, surfaces that curve at a rate like we do. That proves that
right.
we are what we are. So
That
it
would
can't
make my
be a
floor a light bulb.
discrepancy, it can't be gray area as to whether these are physical, tangible surfaces, because Jupiter is not a surface, it doesn't have a surface. Can you stand on it? I don't believe that these are things. So it's like a smoke cloud. Like, you're not gonna make a smoke cloud with a hookah vape and then call it a planet. So it's like I'm intrigued by this course of conversation, because if these things that are being forced upon us as they are like us and we are like them aren't solids, that's a lot of stretch, in my opinion.
That's the
I mean, in
problem, the
that
Okay.
stretch.
sense,
Like, well,
I think to answer your question before, I think what most people in this community say when they mean not physical, they probably shouldn't say it's not physical. What they mean is it's not solid, as in like it's not a space rock, you know? I think that's what they mean. So it's something there that is physical, but it's not a space rock that you can stand on, you know? For me, I'm starting to really question what is out there, because we have images, and I'm not the type of person that doubts basic images that aren't going through any funny algorithms changing everything. And
Regarding other planets, lots of ancient weather sources predicted like there's a dome, spherical dome between each planet layer, you know. So basically, it's not just like why we can't go there, but they're kind of every planet. It's like responsible for producing some part of our reality, you know. That's why they're named after elements and gases, you know. So
I'm talking about
they're like
nebula.
connected through spherical domes, but it's like globe stole all of that, and people thought it was like spherical planets when it was in fact spherical domes. Even Ptolemy, the Greece guy, he predicted spherical domes, and most globeheads gonna share it off like as if it's like spherical Earth. So it's all just basically every planet it's in its own dome. There's more than one dome, you know, around us.
so Axel, I'm on the flat side. I don't think we are what is up there. I think we may be different, and it seems to be flat to me. But at the same time, I'm on the side that some things out there are actually physical because we see them that way based on the images provided. So I wanted to know how the other flat folk feel about that. Proud says you're not really on board with the physical thing, huh?
This is the first time I'm actually questioning it with a full train of thought, I guess. Like before I was, like
Mm-hmm.
you said, like I was more so like they're probably solid, bro. Like even if they're solid rocks, they still don't hold life, so it's irrelevant. But now,
Mm.
like, wait a minute, am I really questioning what they're calling not solid objects? They're calling gaseous bodies. Like, hold on, that red flagged me because it's like a truth. It's like a truth in your core.
Right.
They're telling you something disguised as, but these aren't. But then these all 6 are. So it's just like, But I was gonna
Right.
say I never questioned the moon. I always thought the moon was sus, but I was still leaning towards solid to some degree until I got a
Right.
telescope. Until I got a actual telescope to be able to view the moon up close, that's when it became like sus as fuck to me because there's a ring around the moon, and I know they said that that's light optics, and I've heard it all before, but there's a ring around the moon. We still haven't gotten an excuse for the lunar wave. And it's just like when you look at the moon up close, something about it just gives inverted or reflective and like holographic. And it's like only now that I'm zoomed in on it. Like I know you're looking at the craters, it looks like dimension,
Mm-hmm.
but nah, looking at it closer actually made me question it more. And I thought like all the Globers, oh, look at the moon, you'll see with a telescope that it's a sphere. And it's like, nah, that made it worse.
No, that's an interesting observation, though. So you're saying like when you look at it through the telescope, it actually gives you the vibe that it is something perhaps non-physical, like you're not going to be able to go land on it.
Yeah,
Yeah, because it's vibing, you know, it's like
exact.
vibrating when you look at it.
It looks
And only when
convective.
they
It
do
looks
like composites,
projected.
it's like a still shot.
That's interesting because I figured if you do that, it would more solidify it. Like when I watch guys zoom in on it with their telescopes, you know, and they put the videos on YouTube or whatever, and they show what they're seeing through their telescopes, to me, it looks substantial. It looks like something we can go land on. I don't believe we ever did, but but I think we can if we chose to. Huh.
Hey, Vincent, welcome, man. How's Argentina?
But yeah, if you don't treat gaseous bodies as being physical, then yeah, mainstream science agrees with you. You know, let's ignore Pluto because everyone does these days. You know, Mercury, Venus, Earth, and Mars are sort of rocky planets. The other ones are gas giants. I guess for completion's sake, Jupiter, Saturn, Neptune, and Uranus. And yeah, the sun isn't. You know, the sun's a giant ball of gas. Probably isn't anything. I mean, there can't be. It's way too hot for there to be anything rocky in its core. But I guess that's just the way the galaxy works. I mean, some things are just big balls of gas. Nothing wrong with the big ball of gas. I mean, there's a lot of Jupiter is very massive. I mean, you probably, if you could survive and you went there, you'd eventually the gas would be dense enough that it would support you. But like, you know, they're not made out of I guess like carbon and silicon and primarily like the Earth is.
Yeah, I don't mean to cut your wisdom, but we got a hand up, and then and Wits is also here too. And I know everybody would love an update from Wits. Who we got Universal.
Hey, yeah, just super quick question. I just got in here, but I heard Proud saying that for the first time, she's considering, you know, the solid, I guess, objects or, you know, something in space, I guess, and wanted to see if there was some like new release of information that sparked that, or if that was just from like the discourse in here or something.
It was like, how long ago did I get my telescope? I got my telescope like at least a year ago now. So yeah, once I first got that telescope and I cracked it out and the moon was full and bright and I got to see it like during several different phases of the moon up close, like with the 10 millimeter, that's probably not accurate, but both lenses, I got to see it with very, very like close up lenses. It wasn't like, it's not an electric telescope. It's not $700, but it did the trick, and it definitely changed my view of what I was looking at. I got a closer view of it. I got to take pictures. I got to use my iPhone and zoom in to the lens of the telescope and then show the moon and, you know, iPhone quality. Like, I got a really good look at it. And yeah, it just doesn't look the same. It doesn't look as believable. Like I was saying, the edges of it, the actual moon itself, like the phenomena that they're calling the atmosphere in between the moon, like the medium, aside from the lunar wave, like it's just now there are more discrepancies and phenomena and variables to add to it. And I'm like, damn, I have to consider it solid. I think the main thing is for me, though, that it looks convex. It doesn't look like a sphere projecting outward. It looks like it's like we're viewing it in like the inside of a dip. It's odd.
Well,
I
thanks.
just
Yeah, I
posted
appreciate
the
it.
time lapse in the replies, you know, so it basically, when it goes at the horizon, it just compresses totally flat, you know, even when it's a full moon in daylight, it just doesn't act like any sphere would, you know, it just goes flat like a disc. So I would basically assume the moon to be a disc as well, if
Yeah,
anyone
we're
asks me.
Got you. What up, Wits?
but we just boarded. We're about to take off. I don't know. I might have
Okay.
Wi-Fi on the flight. I don't know, but we are in the plane. It's pretty surreal. We have the whole 757 to ourselves, basically.
Yeah.
You have a compass?
Yeah, I'm
Yeah, of course.
excited.
Sir.
Back, set up all the equipment.
Yeah, man. I can't wait to see what you guys do, bro. This is it's really exciting.
Yeah,
Yeah,
man,
you
it's
know
gonna
what
be cool.
surprised me? To see all the Globers say like sun setting south proves the globe, but they don't even know what our model predicts, you know, because even in Shane's model, the sun sets down south even at your location, you know, so it all just adds up perfectly fine.
Hey, yo, Wiz, how was your first flight, man? I heard you were a little sleepy and stuff. You all right? You holding in there? Hanging in there?
Yeah, well, last night I was up to like 3:30. I had to wake up at like 6:30, but it's our first flight. You know, we just drove here. I'm good.
Okay, okay. Yeah, man. Have a safe flight. We'll see. We'll see what happens, bro.
We're y'all see you're sitting next to Jaren and Elizabeth, or y'all spread out?
Yeah, Joel, Jaren's right. Jaren's right behind me. Liz is across. We all have our own row. And we, you know,
Facts.
but
Liz,
Big
what up?
chillin'. Yeah, make sure you take pictures of the out the window.
I can tell her to
Yeah.
try to jump in.
Sacred, where you at? We got Wits on the line, bro.
I think Sigurd just went AFK.
Yeah, I think Sacred has some questions for you, Wits, or something, but maybe he's out for the minute.
Hey, what's up, everybody?
What's up?
What's up?
Dustin,
What's
if you're
up,
trying to speak, I
child?
can't hear you. I'm gonna drop you down and bring you back up.
All right. Are you saying you can't hear me, or because if I need to drop down, I will?
No, I can hear
I'm
you. This and
driving.
that. You're
I'm
good.
driving, so I apologize for the noise. But I'm so excited for Austin. I sent him a pretty long wall of an email, but I also want to shoot this out there for all of you. Depending on how Austin's trip goes, and as long as his schedule holds, I have Ashton scheduled for January 5th. Okay, it's going to be the very
Fire.
first episode of 2025, and I'm hoping Austin can make it. If there's some sort of a hiccup, or say Austin takes longer, I'll probably reschedule it for that next weekend. But I want to make sure both of those are there. Both of them are there at the same time. And
Nice.
yes, and I went ahead and ordered Austin's book or books because I told him I'd give him more on the podcast. And Ashton, both a copy of the Universal one by Walter Russell. They both will have that by Christmas. So hopefully that's another topic we can talk about because Ashton's never even seen the book. When I showed him pictures of the book, dude, his mind just went haywire. Like I don't think he's ever read the book, man, because I was sending him pictures of my copy. And he was like, whoa. It's like, he's like, is this Walter Russell? I'm like, yeah. He's like, absolutely, man. Send it. And I was like, will do,
Hey,
man.
yeah.
Yeah, dude.
There
So I'm
you
so
go.
excited about this episode, man. I can't wait. I'm like, I hope Austin has like the greatest time of his life, dude, because so many people have been wanting to go down there,
Yeah,
and
man.
he's gonna get so. Hopefully, he gets a shit ton of footage,
Fact.
and I just can't wait, man. I can keep talking about
Me
this
too.
forever, but yeah, I'm just
Yeah.
excited for him, man.
Yeah, man. We're vicariously living this through you, bro.
Facts.
This is awesome.
What time is it right now?
I don't know. Is he connected?
He is on the plane, or they might tell him to put it on airplane mode.
Yeah, he might have to
Yeah,
disconnect.
he did say that he was unsure if he was gonna get Wi-Fi when they took off.
Yeah. Yeah, he might not even be here. He's just showing as a glitch.
Well, I haven't been on a plane in a while, but don't you have to put your phone in airplane mode until you get to a certain elevation, and then they allow people to turn their phones back on?
Yeah.
That's what I was
You're
thinking.
supposed to. Some people still like they'll wait like until somebody actually comes over and tells them, bro. It pisses me off.
Yeah, because it messes with pilots' radio, so it's really like
Exactly, bro. Like this is not a game, bro. Planes go down, bro. Like I'll be ready to actually stand up and say something. Like yo,
wait till after they
yo,
hit
bro. I'll be on
altitude.
a plane looking at dudes like, yo, they already said 3 times, put your shit on airplane mode, bro. What's up?
Yeah, we can hear you.
It was weird. I was just saying hi and saying hey to everybody earlier, Witsit and Jaronism and everybody. I guess I missed them, but this is fun. It's too cold for me to go to that place, but it's funny we have to go to the ends of the earth to find any evidence for a globe, right?
Yo, what's there? Are they giving you the
It's pretty
tutorial
funny.
for what to do with
They're
your life
desperate. Yeah, I mean, they're so desperate at this point. I would have given up before I would march off to the frozen hells at the end of the earth, but yeah.
Well, you know what it is that they're confident that this will be the end of flatness. That's what they're gonna tout it as if they get the observation they want.
That's just it. I don't think that's what they
yeah.
want. I don't think truly the powers that be want this to be the end of quote unquote flatness. I think they want it to continuously be an argument.
I'm frankly worried they're going to take the plane down because so many of our leaders are there, and I hope they don't have any jab
They would have to
pilots or anything.
sacrifice
And I'm
their
praying
own. They would have to take McToon ass with them.
they don't care.
If they really wanted that, they would not care.
If they traded a McToon for a Witsit, the deep state would be laughing for years to come. I mean, I pray protection over this whole.
Everybody send Witsit.
Facts. Everybody,
virtual heart.
believe it or not, send a prayer for the
virtual
safe
heart,
flight and all that.
virtual hundreds, virtual prayers because they up in that area. He dropped.
Oh, you mean they have to share a plane, McToon?
That's why I said they have to sacrifice their own. There's no way they could do that. They would make all of them martyrs.
I'd probably jump out of the damn plane.
And then on top of it, if the globe earthers, God forbid, oh my God, this is so bad, did survive, and it became like a situation where only something happened to the quote unquote flat earthers, the globe earthers would not be able to come back with a positive experiment. It would be tainted. Nothing they say is valid because what the fuck happened over there? And if they're not gonna tell, then it's like fuck the experiment, fuck the observation. Like nobody wants to hear what you got to say, bro. Like something happened and y'all not releasing that information. Y'all knew y'all were over there. Y'all the only ones came back. Like nah. So it's like really, I think I spoke on this already. Like it's a really bad position for all parts, but they would be dumb to make this a martyr moment. Like this would be the worst mistake they ever made.
Yeah, my concern is
with the people.
Yeah, go ahead.
No, go ahead. No, go ahead.
I just want to say my concern is more geopolitical. I see outside of the flat Earth and what I call biblical Earth, globe Earth, whatever communities. This is heating up politically. The war is coming, and even in the best of times, like a journalist, a reporter, someone telling the truth, whatever, a truther during war times is kind of a dangerous job at best of times, and this is not the best of times. I think they're going to make a move on truth voices everywhere soon, like a Night of the Long Knives, Order 66 kind of thing.
Yeah, he's got a point.
It would be Globers outraged too to lose McToon and whoever else is over there, the best. Like, you know, it wouldn't just be flat earthers. It would be even Globers who were looking at this like, hold on, they just took all of them. Like they would also be enraged that their leader and savior is also on that plane, you know? So they're looking at it too from a standpoint of like, yo, don't shoot the plane down.
Yeah.
I mean, to be fair, I have no idea who the globe earthers are on this trip. I only know that Whitsitt and like another flat earther is on it. So, I mean, if they did take the plane out and those globe earth people, I'd be like, who are those people? I never heard of them. So I'm not sure that calculus really works.
Well, they may not take them out, but what if they MH370 their asses and they just poof? It just they just get teleported. You know what I'm saying?
To be fair, I think plane crashes are very rare, and I think it's probably something we don't really need to worry about here. But
they
no,
were
not plane crashes. Not plane crashes. I'm talking about the teleportation. If you're familiar with MH370,
I am, but those are even rarer.
Yeah.
Well, we have all the false alien invasion stuff happening right now too, but I'm more worried about like a pilot and a suddenly, like traditional. Like it used to be safer to fly than to drive, but since COVID, that's maybe not the same.
Hey, yo, Proud. That's why being king flipped. We got all the fake alien stuff happening right now.
You think he got excited?
It's all been. Yeah, he's. That's what it is.
They're trying to distract us from the evidences.
What? Where are they actually staying at? Are they going to Antarctica, or are they just going to like the southern tip of Argentina?
No, they're going to Antarctica, as far as I'm aware.
Yeah, both.
They're flying on the coast for like a few hours, and that's it, man.
But they're spending 5 days in Antarctica.
We might get the.
They're spending 5 hours maximum.
I think it's 5 days. We should have asked him when he was here, but he'll come back.
Yes, please. Let Richard
What
have
he
the
told
floor if
me,
he can speak, guys. This is our only chance. We got brief opportunities, okay? We got small windows.
Right.
He's back.
Yo, can you hear me?
Yes, sir.
Do we have to whisper?
All right. Sorry, I got a phone call. Yeah, it's gonna be surreal, bro. So, yeah, it's about that. So,
How
when I
long are
jump
you there?
off, like 3 days, dude. When I get off, I'm gonna say one step for man, one giant leap for flat Earth.
Fire.
Get it recorded.
Yeah,
Oh,
for sure.
yeah.
That's what I'm saying. POV and from the outside. Yeah, it's
Nice.
gonna be crazy. We're gonna try to film. So if it's clear, we're gonna film us coming in, right? So hopefully we'll get like shots of any type of ice shelf or anything like that, depending on our entry point. And then we're gonna have infrared trying to catch, off in the distance in the landscape. Then we'll have, I think, like 2, 3 other cameras also filming. We're tracking the sun on the way as well. So just
Nice.
before we even get there, we're gonna see lots of stuff. It's pretty cool.
Yeah, I love the fact that this is going to be kind of a data-heavy observation that you guys are doing. It's awesome.
Sorry, have they told you anything about the Wi-Fi? Supposedly there's Wi-Fi. I don't know if it is actually going to work there.
Sorry if everyone knows this, but where are you staying in Antarctica?
Union Glacier Camp, 80 degrees south latitude.
80 degrees. What?
Sound crazy.
Word.
Yeah,
But this can only like debunk the globe. It can't like debunk flat Earth. If it doesn't work, it debunks the globe.
Oh,
of course. I mean, it can debunk the globe in lots of ways.
What time is it? What time is it? What's it?
So for me, it's 10:38. So we're 2 hours ahead of Eastern Standard Time. Same there.
Cool.
Bro, I can't believe this is really happening, yo. This is wild.
Yeah, so many people had doubts, right?
Dude, I had doubts.
Yeah, I think everybody did at one point.
Oh, here we go, bro.
Yo, this is a
I'm
legendary moment.
gonna lose you guys. Yeah, man. What's up, Sacred?
What's going on, brother? This is so dope, man. Take y'all
So I'm gonna try to
screenshots.
get on Wi-Fi. Obviously, bro, if I'm able to get Wi-Fi in the air or there, I'll jump in here. When I'm there, if you're still here, I'll jump in there. Or I'll
Nice.
also be checking in with Discord, right? So you got like Earth Awakenings and Ether Cosmology on Discord. if you guys are
Yep.
done. And then if we have good enough internet, I might try to host a space, do a couple live streams, et cetera, et cetera. So either we're gonna kind of go dark and you guys aren't gonna hear from us except for like an audio message a day, and I have a satellite phone, or we're gonna be like actively relaying information in live time and uploading all the observations to the cloud. Like
Nice.
at least I'm gonna try to do that. So
Witsy, watch your back out there, bro.
we'll see. Yeah, for sure, brother. Yeah, it's got me, brother. It's all good.
Facts.
Indeed.
Hey man, if you see 3 orbs circling the plane, bro, let somebody know before you disappear.
Okay.
Sure.
I had to throw that out there. I had to.
Yeah, they don't like the name of Jesus or Yahweh, Yeshua, all that stuff either.
Oh, it's not even going to be that cold there. You guys will be fine. Have fun on your free vacation.
Yeah, all I know is that sun better be at the exact elevation angle it's supposed to be. It better have the exact orientation of sunspots it's supposed to. It better not dip below the degrees it's supposed to.
Word.
I mean, it better have the right thermal distribution. It might better have the right lux reading. You know what I'm saying? So we're gonna see. It better have the right shadow distribution.
What are your thoughts on 2 suns, Austin?
I just think that there's a sun, and then there are apparent suns. You know,
I was
the
just
2 sun
curious.
thing. I don't know.
Yeah.
I don't know. I mean, maybe there's some type of effect that makes that happen, but I think there's an apparent sun for each individual observer. So yeah, that's why I want to go. I'm excited about going because it's like I want to know what happens out here, so I can get a better grasp of
Yeah.
maybe how everything's working.
Yeah. Total picture. Big picture.
Breadcrumbs, right?
If you
You're now
can,
making a joke. We're like I said, if we don't believe something, then I guess we just get free trips there. So I don't believe in space either. I don't believe that you can circumnavigate. So tell them get on that. I'm gonna need to go to space. I'm gonna need to circumnavigate.
bring a penguin back with you, bro. Come on.
Dude, you can't bring like a drop of water.
Yo,
back.
I was just saying that. Like, I wonder if we're gonna get like
Yeah, I know.
a vial of ice, glacier ice.
Right?
Yeah, dude, like 30 people have asked us to do that. Like, we'll see what happens.
Why can't you bring like even an ice sample back? That's crazy though.
I don't know. I mean, they don't even, like, dude, when you pee, they bottle it up and they fly it off the continent. You know what's so crazy is the
Whoa.
water that we're drinking is all from like Antarctic ice. So we're gonna have like some of the best water ever, bro. I mean, it's, you would think, right? It's like pristine.
That's
pretty incredible.
That's something I would love to try.
Old water.
Yeah. Your DNA might come back changed.
I would like Ashley to ask that you keep an eye open for anything that's occult or symbolic in nature while you're out there, because we know there's the overlap. I mean, we can find additional evidences for that maybe while we're there. I mean, these guys are into all kinds of occult secret society stuff.
Something man-made.
Okay, we're actually speeding up right now, so.
Alrighty.
You should pull up some balloons from your pocket and send on drone cameras on the balloons while you're there, man.
Let's go.
Okay, I can't hear you. It's super loud.
Let's go. Let's go.
LFG.
Level heads in the air with it. Miss Wits in the air with it.
Let's go.
Much love, brother. We'll be praying over you.
Yeah, man. Peace.
Love you too, Austin. Bro, excited as shit, man. I'm gonna be geeking for like the next week and a half.
Facts. I'm right with you, bro. I'm looking for every little peep that they said. If they can upload, bro, that's gonna be so fire. We're getting like real time data. This is dope.
Oh.
I just hope when both him and or Ashton are on, that's like the first thing that we talk about is his trip, because I don't even think Ashton even knew he was going.
All I want to see is the McToon and other Globe Earthers cope videos. I'm not actually even interested in our side's videos like that much. I love our side, but I just want to see them cry.
Hey, what if
you want to see the mental gymnastics?
What if Wizard drink that Antarctic ice water, come back a superhuman? Can you imagine, like, a superhuman Wizard on flat Earth? What? Oh my!
Nice.
Super
Dude, that
Saiyan
ice is so old. That ice is so old down there, dude.
is about to unlock his Saiyan powers, bro.
Feel me? Off that mammoth juice.
Man, now you know what's gonna happen. The memes are gonna go wild with Austin and Gohan. I swear to
Yeah.
God.
Sure, man.
Word up.
What up, JT?
Hey, morning, fam. What just happened right now? The timing of it is just crazy. I'll tell you about it. Let me let this car pass. Stay over here, kids. Um, last night I was listening. Everything was great. I fell asleep with y'all. I woke up at 5 a.m. Y'all are still rocking. I was like, oh shoot, I got to take out this earbud, which I didn't want to fall asleep with it. But anyway, my wife just left for a run. I hadn't even turned on Flat Earth Friday yet. And she said, hey, if you want to get the kids, there's a snake in the road. And I was like, yeah, let me check it out. She sent me a picture and I looked it up. It's what is it called? It's a speckled king snake, which they're commonly known like as a chicken snake. Its habits of sneaking into hen houses and devouring eggs and baby chicks. But it's cold. It's in the road and it's cold and it can hardly move. I don't know if it's even going to make it. I don't know if it's got run over, but just it's so weird that the timing of this trip and it being cold and there being snakes trying to get to the eggs and it just to me, I'm just like, oh yeah, of course. But on
Snakes
the
in the
real,
garden.
what?
Snakes in the garden.
Snakes in the garden, man. So, our boys and girls need to keep their heads on a swivel. What I love about all this is how much intense love is flowing towards Witsit, Jaron, and Lisbeth. Like, you got the Clubhouse, you got the X Spaces, you got Ether Cosmology, all these different groups of people who are deep in the trenches of studying, researching, looking for truth, not being scared of the enemy, literally. And now we got our people up next to some kind of, I don't want to say demonic, but some definitely confused people. So my prayers go out right now with y'all. Any one of y'all that do pray, it's just lifting them up for a safe flight. And like Dustin was saying, keeping their heads on a swivel and being aware of occult symbolism and not just taking pictures of the sun, but just taking pictures of everything, because I don't think they can get away with tricking us that we live on a ball earth anymore. And they're just pissed. They can't hang on to the ball and it's coming crashing down. But yeah, much love, y'all.
Facts. I would love to be recording 24/7.
What up, everyone? Yeah, what I missed? Did you already not see it or what?
You just missed last update from
Like
Wits.
2 days early.
He's in the clouds, man. Oh no, there he goes.
He's on the Witspedition, bro.
That dude hasn't slept since he started, I think. You sleep yet? Anyone know?
He got a few hours, he said last night.
Nice.
I never heard him so tired last night.
I don't think I've seen him so excited as yesterday.
Oh, did y'all know Bruniverse is showing what's his name? FTFE and McToon on the Bruniverse right now, premiering.
Why?
Well, he was like, I barely started the episode, and he was like, we had Flat Earth Dave on, and it's great to hear people talk. I like to hear people's stories, but when he was getting into the numbers, he just loses the numbers, and I wanted to be fair, and I want to hear both sides. And Craig here is going to come on and prove the globe today, but I don't know how it's going to turn out. If he's going to have some hard questions for him, or if I'm hoping that he basically shuts down some of the nonsense. I'm hoping, and I'm kind of wondering if FTFE can stay calm and not like lose his crap. But I don't know, man. It's getting on big platforms, all this stuff.
History says no. But
you're right.
I mean, I thought I had respect for Jim, right? I guess he's doing that. I guess what happened is his fans probably were like, "That's so unfair. You had Flat Earth Dave. You're a shill," and he was like, "Fine, I'll have the other guy on."
Yeah, I think you're right, dude. Because we know he's flat as heck. I'll post a link though for y'all to watch later.
What platform?
Sorry, it's the Bruniverse, Jim Brewer on YouTube.
I think public debate as entertainment product is its own sort of genre, and a lot of people don't take to it well because it's not easy to do in a way that's entertaining, and in a way that allows you to. I mean, a lot of also, and I'm as guilty as this as everyone. A lot of people really do, can get angry at stuff, and obviously you can't do that if you're producing a public entertainment product. You can't have one of your guests just getting mad and unhinged, and I think, so I just think it's a difficult thing to do in a entertaining way.
Yeah, I hear you. That makes sense. Just to give you feedback, Proud, Jim Brewer is on Half Baked, major Hollywood comedian, actor. I mean, you probably know of him. He has 352,000 subscribers on YouTube. And, you know, I'm just like starting to understand what Witz is saying. Like, this is getting under the spotlight and more attention. And it's not near as taboo to say, like, hey, I think the Earth isn't a globe. It used to really trigger everybody. And now they're like, you know what? I've heard that. That's going around. Let me look into it and all the. I mean, like people can get $300,000 worth of Bitcoin for one globe proof, and no one's presenting anything because it's all just nonsense, and that's what makes me laugh.
Yeah, I mentioned that earlier. I think either way this goes, once everything comes back, all of them who are there are going to be a bit more famous because they're gonna, whatever happens, the videos are going to be everywhere. Their names are going to be everywhere within, at least within the groups who discuss this stuff, right? So it's going to be very interesting.
Yeah, you're right, D3. I'm gonna hop off and get the kids breakfast. But to your point, D3, y'all said it already, but for new people that are here, they're going to be like, oh, let's talk to the globe believers, and even if they do a hit piece, but they're going to say like, hey, Whitsitt, Jaron, Elizabeth, you guys were there. Can we get your opinion, or can we get your take? And that's when he's going to just ladle gravy and lay it out there. So this is all good. But y'all have a good morning. I'll be listening.
Appreciate that, JT. You guys know how long ago it was since Jaren's experiment? I don't remember how long ago that was. Since the hit piece, the last hit piece.
Not sure the exact date,
Behind the
but
curve.
I have a playlist I'll drop in the purple pill that kind of is him defending. But yeah, I'll
Behind the
drop that.
Curve, 2018.
2018, okay. Yeah, it does seem like the way that flat Earth is being pushed right now, like it's a big topic. Like the powers that be probably want to do something to it, but it wouldn't
but
surprise
that's
me to keep the conversation a question, to keep a questionable air about it.
That's the thing, though. Like, what do they do about it? If they outright censor it, it blows up, right? That's the Streisand effect. If you say you can't know it, people will all over the world immediately start to look for it. So they have to do this, like, white gloves treatment where it's like, actually, it's not safe for you to know this, and we'll just chalk it in with conspiracy. When that video of them admitting that they were going to censor it on YouTube hit, like, the internet, people were, like, astounded, right? They openly said, well, it's not wrong, but we're going to put this caption to combat misinformation. We're going to let you know and direct you to Wikipedia, right? That was their current right hand solution, and that is not working anymore.
Now imagine the impact when they come back from Antarctica and it's still not definitive. It's still questionable. The Globers who are waiting on this, frothing at the mouth right now, stayed up 72 hours waiting for flat Earth to be over. They come back and there's nothing to prove that. Like they did what they said they were going to do. You know how many people are going to be pissed off and they're going to have their mind open to the fact that like it's 2024 and they couldn't definitively prove to these people that flat Earth doesn't exist. Now I have questions. Like imagine that outlook on the rest of 2025.
They were making fun. They were like, all right, no flat earther will say that if they make an observation, it changes the model or whatever they were saying. Then it's like, what we all said was that we'd wait to see the observation and then try to explain it if we needed to. We were all open to it. What we weren't going to do is dismiss the whole idea because of a single observation of the sky. And it's funny that they would, because their whole idea model is based on the sky, right? Everything they know is based on the sky. Nothing about the globe is based on the ground, as hard as that is to understand. So that's why they were all so willing to dismiss it should they make a sky observation of the sun setting, right? I just want to point that out because they turned that around on us. They were like, none of you are willing to, see reason and change your idea. And it's like, no, we were all you once. Knock that off.
I got
But it works in your model just fine, everything. That's why that thing is so good, because it shows you like how our sky works, the spherical cup, and you don't have globers having like any model like that at all. I can't find any globe model showing me moon's position, sun's
What up, y'all?
position.
Peace to the
Like
room, man.
we
It's my
have
first
that.
time on It's my first time on Spaces. Good to be here.
But
This is Jamal from Clubhouse, by the way. What up, Shane? What's up, guy?
API?
what up, man? Did you not hear Flash though?
Did you hear Flash?
Oh, no, I didn't. My
No.
bad. No, I just switched off my Wi-Fi. My bad if I
No,
cut somebody
no, you're
in.
good. I could bring you back up in a second so you could hear everybody.
I gotta drop too because everyone sounds like they're in the Tron vote now for me. I don't know what's going on.
Uh-oh. I got you guys.
Well, everybody sounds good to me.
Right? Where's my mic? Welcome from Clubhouse also.
So sometime today we should be hearing about the sunset in Antarctica.
Welcome from Clubhouse 1. And I don't know, it depends on which side tweets about it first. Like, I don't necessarily believe what the Globers are gonna tweet to their followers or, to get to their people, but Sicker was on TikTok and even Globy McGlobeface was trying to say like, oh, let me give you guys updates from McToon. Like, so everyone's communicating with their side, talking about it.
No, well, it ain't gonna matter what they say. It's gonna matter what they can show. If somebody's saying, "Hey, it's midnight and I've got the sun to the south of me," it better come with some damn video. You can say whatever you want. Seeing's believing.
Yeah, facts. I can't wait to see what they see through the solar filters.
Did you guys hear what's its plan to take the sunspots or whatever? Did he talk about that?
Oh, share.
So like he was trying to predict if there is a reflection, how would you tell? And the way he came up with was the sunspots, which seem to rotate and move on the surface of the sun, would be inverted should it be a reflection. So he's trying to get camera evidence of that or whatever.
Like moving in the opposite direction?
Yeah, right. Because that dude who made a model, I forget his name. Damn, was it JT? Help me out.
Oh, so you're talking like the firmament would be like a mirrored image.
Yeah.
Therefore, a reverse image. No, that's smart.
Like, so if that is what's happening, then that would be an aspect of it, I would think, right?
Yeah, the sunspot
It'd be
will be
weird.
on the other side of the sun.
Well, no, it'd be like to left to right and right to left, right? So like how they move and rotate, they're identifiable and they're tracked daily or whatever. There's sunspot trackers all over the world, so like it would be easy to see. Now the only thing that we couldn't figure out is what the proper orientation of the sunspots would be when viewed from Antarctica.
You know what I noticed in your model, Shane, that South Pole probably is not like at 90 degrees. It should be like a little bit closer because we can see full moon, a lot of it from it. And when you like put it at 90, you can't really see the full moon, So the South Pole must be like 85 degrees or something, It's not like a deep bare edge, but it's a little bit closer, probably.
Could be,
because you
man.
can see like tons of full moon from its cameras, but the model does not predict the full moon like at the 90 degrees barrier.
Yeah, I wouldn't trust anything past that like 70 south though.
That's another thing I wanted to ask. Do you guys know the last time he saw the moon?
Yeah, I
Yeah, they
seen it
sent some
yesterday.
pictures last night that they took off, and they said it looked really squished up. It looked kind of weird, like there was a bump on it, like someone kind of smushed it horizontally, and it's like just a little bit distorted, so it looks like a little elongated.
He posted them?
Yeah, I got some pictures. Lisbeth sent them to me.
Do you know how to DM yet? Yeah.
Definitely not. I'm booming out of control right now. I'm trying to figure it out. I'll get there though.
He only knows how to use Clubhouse, he says.
DM, my DM's not open, or your DM's not open. So if you look at the bottom of the screen, you'll see the little chat bubble. They say 120. And then if you click it, it'll let you post a tweet or a text or a tweet or like a picture or anything. And then I could pin it to the top for you. And that'll just be lesson 1.
Now I'm really curious because somebody was showing that Gleason map, like the original or something, and it had something on Antarctica about the sun, and it actually said that at 80 degrees south there is no sun. I don't know if it was like for part of the year or what, but it was saying that at 80 degrees south there is no sun, and that's where he's going, is 80 degrees south.
Yeah, it's way out there, man. Most people, we don't have any real data from there, I think. Like everything that we have is just assumed inverted northern stuff. We have very limited southern data past that point. And then like, never mind extreme south. And of course, 90 is a joke. So I'm interested to see what they see for sure, man.
Yeah, so they're like, theoretically, they're 690 miles from 90 degrees south. I just keep thinking about those people that say that when they're taking pictures in Antarctica, I don't know if it's got to do with the cold or the humidity or what, but they say that they can routinely with cameras see like 200-300 miles. So I'm kind of curious as to what they can see from where they're at.
Did I see Dustin Emos up here? Where'd he go?
Did I do it right? Is that where I was supposed to put it?
We open mics, JT. Go ahead.
Okay. The clubhouse lad asked if he did it right. I don't know if you heard him about posting in the purple pill. Did you hear him, Sacred?
Oh no, we
Yeah.
got Clubhouse in here. Shout out Liz. Who's in here?
Perfect. You did it right. I
Jamal
posted it
here.
in the top for everybody.
Okay, but you couldn't hear Jamal, Sacred?
Oh, Jamal, what's up, man? Shout out to
Peace, what up,
shout out to
man?
Flat Earth Gang.
Been funny
Yes.
seeing the two universes kind of collide a little bit and just seeing like a parallel universe, a lot of the same dynamics and shit playing out on another side.
Jamal, did you hear what I said a second ago about like the energy and love for like Elizabeth and Clubhouse and
Yeah,
Witsit?
I did when I first
Man,
came in here for sure, man.
I'm telling you, a lot of what I'm feeling is not nervousness about what the outcome is going to be, and it's not nervousness about what the Globers might try to pull. It's just pure excitement about these 3 communities that are combining forces. You know, it's like a Dragon Ball Z scene to me. Because truth, man, truth is so powerful, and love, and like I hear you guys communicating in love and giving space for other people to speak. Now I know it gets toxic when people come in and just slinging fallacies and bringing bad attitudes, but there's powerful stuff going on in this movement, and it's not just about the shape of the earth. I mean, it's about everything that human beings are seeking, like how to be healthy, how to be connected, not disconnected. So, I tried to speak a second ago, and I think my mic was not working, or somebody couldn't hear me. I wanted to say last night, Joe was mentioning how, like, if somebody a little bit higher up was facing south and somebody was in the south, like where they're going to land facing south, when they look up at the sunspots might be um, the same. Or if the reflective dome, inverts it like a funhouse mirror, it would be, he was given his layout of his two possibilities of what he thinks they'll actually see. And my main point in this little rant is we are more close to the way it should be with science, with being curious about the sky, because dude, man has never understood how it does, what it is, what it's made of, what temperature is it, how far is it, if it even has a temperature. The whole thing with the heliocentric model is man didn't like that they didn't know, and they didn't like the fact that it showed that we're in the center, so they made us often obscure speck of dust, accidentally here from the Big Bang. But Joe's work and everybody here that has a curious, open mind, that's wondering what it could be and what might happen peacefully, that's the way humans should be about the heavens. That's the way we should be, not programmed to believe we know it all, because that's just prideful and ego. Anyway, that's my little rant on that topic.
Joe, that was who I couldn't remember. Thank you, Joe. Joe made the model. So yeah, he showed that like the celestial heaven with movement and just a little bit of reflection could show the inverse and perspective induced counter rotation, right? And he showed it with stars and at night, but I didn't see his daytime demonstration for the sun part. I think I missed that.
Hey, yo, Atheop.
Yeah, you could just say Jamal. I forgot that was I only really use Twitter. I forgot that's my director name.
All right, Jamal, what's up with did I miss something? What's up with the 4 pics of the moon here? Because I was talking about the moon
I
earlier.
posted them in the chat.
Oh, I was just on we was on a FaceTime call when they were on the beach, and they mentioned how like everyone, even the Globers, they noticed that everyone kind of when they stepped down and saw the moon, everyone noticed like, oh, that looks really weird. It's kind of like a bump, like if it got got hit on the head and got a bump on top of it or something. It's kind of described it.
The shape.
Yeah, the shape's like a little bit elongated and like an egg shaped a bit. Like I to me it looks a little. I get what they're seeing, but I guess probably in person it probably looks a little bit more pronounced. But I did hear everyone kind of just going on and on about how squished up the moon looked.
Yeah, man, them optical illusions, bro. They be getting us.
That do look crazy though.
Right.
And man, shout out to them for going out there, man. They crazy as hell for going out there. As
It
curious
look
as I
like
am, I don't
the
think
way
I'm
the
going.
light is hitting it though.
That's what I think. I think it's just like it's just an illusion of how it's coming to us.
The last one, I definitely see the titty shape at the top, but like that's from afar. Like the
Yeah, like we had
bottom
a cheap
right corner
basketball and
is
got a
like
titty on it.
fading.
Yeah.
It's a wild
It is
discrepancy.
definitely. It appears to be misshapen for real.
No, because when you look at it on like the whole page, when you look at all 4 pictures, that one, I don't even know if you see it. That one all the way at the bottom corner look a little titty shaped. I don't know something about that one, but when you click into it and then you zoom into it, you could tell that it's like the way the light is concentrating at the top. I
Right.
mean,
Man,
It changes like
that is Mother Moon, right?
it does change though. Like if you look at them all from the what do you call it, the thumbnail, and then you zoom into it, it does change.
But let me go look at my photo because I posted a picture of the moon and I had conspiracy capper in my fucking mentions talking about those were fake and edited. Like, yeah, supposed to be the conspiracy. So I want to see where the crater is on my pictures. Gotta go get on.
But yo, Jamal, I heard that PhD John likes to taunt Witsit and then run whenever Witsit shows up. Is that an accurate statement?
Oh man, it was hilarious. Who was in there? I think it was Allen. He ran from Allen. I think he was supposed to debate Allen. He ran from Allen. He just with the weirdest excuse that he doesn't debate anti-science. He's you missed it the other day. Then Whitson came in and they started talking about angular size of the sun, and I forget exactly what it was. Something they got into, and he just completely ran. But we have that legendary clip. I think when I don't know if you were there, but Alan was there, and he came in with his chest up like, well, I'm rather an expert in relativity. Got anything you wanna? And then fast forward like 3-4 minutes later, he's like, well, I just came to say my brain hurts a bit, and he's like, if you want to call that a win, and he left.
Yep. Yeah,
That's
yeah.
just Steve, though. That's what he does. He just, it's like one-way traffic. He just wants to evangelize and just talk about his belief, and that's it. Short
Yeah.
circuits when he's challenging.
Well, Elizabeth comes into Ether College. She's like, John's hanging out, it's like, come talk. And by the time anyone shows up, dude's already gone. Like, cartoon, like Speedy Gonzalez took off in the side street. We're like, oh, where'd he go?
That's PhD John y'all was talking about?
Yeah.
I listened to him talk to Wizard on not Ether Guys, on Earth Awakenings. That was
Embarrassing, right? Like if that were you, you'd be embarrassed, right?
Man, if I found some of my clips with me and John over the years, man, I got some of the greatest content and sound bites out of him. Like, walking him down to a corner where the other day, like he just had, all right, look, Jamal, let me tell you, this is what we do in science. In science, we make toy models. He said toy models, right? He said toy, literally. I don't know why he chose. I think he's trying to be coy or like honest or something. But
Like how there's
we
two
make
things
toy
synonymous.
models. Yeah, and he says we even we tell ourselves stories about these toy models, and whether it's true or not, and what's real or not, it's not really what we're concerned with. I'm like, oh man, well,
Dude, that's the
thank you.
most
That's
honest thing
kind of
he's
the
ever
whole.
said.
That's what it
Yeah.
is. I'm like, well, we finally are in agreement. That's all I've been saying this whole time is you guys have a toy model, and when it disagrees with reality, you ignore reality and keep working on the toy model.
No shit, dude. That's amazingly honest, right? That's exactly the globe model. A complete model that when it doesn't work, they just add obfuscation layers, right? Add a new neural network iterative layer over it to cover it up. Everything still works. Everything's fine, And he just admitted that when you got him down to it, he's like, listen, well, it's just a model. I don't appreciate you making me uncomfortable by poking out the holes in my model. It's just a model, okay?
Yeah, I mean, I don't know. I think I know why you ran from Alan on relativity because the way I've cooked him on relativity, I'm a fucking, noob. I'm like, just kind of been absorbing shit over the years in this conversation. But we got to talking about muons and, the sound bites. I'll find them eventually since I'm already teasing them when I go back in the crib, I'll find them. But he's like, I didn't say time slows down. Well, maybe I did, but I shouldn't have. And then continues to say it like 4 or 5 more times because that's indeed the position. Like you're saying, time slowing down.
That's crazy. Dude, relativity is a retarded position. Anyone who defends it with intellectual honesty doesn't understand it, right? The people who do understand it admit that freely. It's pretty funny. And then it just comes down to, would you get on the train, bro?
Well, it's a theory. It's a theory, which means it hasn't been proven.
Which is why I want you guys to talk to Hanson. He's a little bit more forthright. He's he's a Yale PhD theoretical physicist, but I think he knows his bullshit because he just went and got himself a nice finance job.
Dude, a theoretical physicist and doctorate in literal nonsense, little guesswork and bullshit. I'm a professional bullshitter. That's what. Oh my god, I can't believe our society holds degrees like that in such high esteem.
Yo, there's a author, William E. Burroughs, a professor and like in journalism and award-winning publications on space exploration. He writes science fiction books about space exploration, and he said that religion and belief of space is like tied; they're hand in hand. I posted it in Jumbotron, but yeah, he's literally going on. It sounds exactly like what what's his name? Ethiop was just saying about
Jamal.
that. Jamal.
It's just Jamal, guys. Everyone's freaking out.
Oh god. No, that's cooler. That's cooler. That's cooler. We're gonna learn it. Ethiop. But it sounds just like what you were saying, John was saying, like basically that they just sit in this imaginary land and they pretend it exists until it becomes a possibility. And they were like, yeah, we need the fiction in order to, drive our imagination to build these machines to take us to space. And it was just like they were dead ass, yo. They were dead ass.
Bro, you just said science is fake it till you make it, essentially.
Yo, that's what
Yeah,
that's what the author said. That's
Yeah,
like
Linnell
what the
Jumpy
author
said.
said. They had to fake it till they make it in order to get the science tech that they need. Like they need the morale basically, and so they gotta fake it to get the morale to build the science techy shit.
That's hilarious. Imagine being a doctored expert in a theoretical, pseudoscientific background with no scientific method. Like the whole field is looking up and guessing, and no one can check your bullshit. But you're a master in it. Okay, cool.
D3, I sent you other pictures of the moon that I took.
It's crazy
Compared
because I
to
never thought I'd be here. I took two of Michio Kaku's classes and aced them. I used to be at an apprenticeship at the Hayden Planetarium with Neil deGrasse Tyson, and
You personally?
yeah, me personally.
Damn.
that's how I be feeling when I look back at the NASA photos, me going to the Kennedy space station. I'd be like, damn, I was right under their nose, young.
I took astronomy courses in college, dude, but I sucked at them and I didn't know why. Like I was doing well in all my other courses, and then I took these two courses and I got straight C's, and I was like, but why? Like, and then I just couldn't absorb the nonsense, I guess, right? They were like, so a star burning hydrogen, helium, iron gets heavier into the. I'm just like, oh yeah, I'm into it. This is great. And then I try to really like dissect it and regurgitate it for the test with like an understanding, and I'm like, now wait, why does it burn the heavier before the later, and then it explodes and causes everything? Hold on. This doesn't. And then I just couldn't do it, dude. So I don't know why. I blame it on that. I blame it on being.
Yeah, nah, I definitely took Michio Kaku's final out the room around the corner and just Google all that shit and walk back and hand it.
Straight A's, love it. Dude, that's the best regurgitator.
Yo, but I mean, I wish I had the context for this conversation back then, because he definitely used to. I know you probably heard that infamous clip where he talks about no one in my field, none of my colleagues use the scientific method. He used to go in on that. He was very forthright about that.
Yep. And now it's like they have literal fields of science called, what do they call it? Theoretical physicists, right? Who just, based on a theory from your couch, you make wild guesstimations of what you think the science fiction world would unfold like, and then you call it science, and everyone's like, applause, give them an award.
You know,
Give it enough
to that
years,
point,
and NASA will say that it is real science, and I'll give you a fucking headline about some nonsense.
and to that point, when we were talking with Franco like a month or two ago, and we kind of pressed him on some of that, what he said was, you know, as long as it works, that's all we care about. And so that's the thing. Like you sit on your couch, you come up with a fancy equation, and you plug it in somewhere, and it actually gives you what you were hoping to get. Then it works for them, and then it becomes adopted science. So
And that's what
it's
John
not.
said. It's like, as long we don't care if the stories that we make up about our toy models are real or not, as long as we get predictive ability. I'm
That's
like,
it.
well, that's ridiculous. So then I could just sit here
Yeah.
and I could just change the unit of mass to each, let's say, gram is a fucking little blue-eyed angel. And I could just tell a story about the love and attraction that angels have. Is that science? Am I doing science now? Because I have the same exact predictive ability as you.
Does it work?
Yeah,
Can you predict with
I think it
Works
becomes science.
exactly just as good
You're
as
good to
yours.
go.
Dude, if you say the sun runs on love and it actually sets because of the attraction of the angels, and then tomorrow when the attraction is stronger, it's going to rise. That'll be a prediction, and then it's science. I think that's how it works.
That's how it works. And they run with it. And the thing is because that's the problem though, right? You can't convince them of otherwise because it works. So they get to the point where they're like, well, it must be because it works. Like, no.
Then what else could it be?
Exactly.
But we've been schooling them on the epistemology and like, listen, there's two sides to this coin, and they just refuse to look at the other side.
Yeah, well,
they can't. They got to do mental gymnastics,
dude. Even when they live in models, right? They live in model. Even if we were to make a model and say, hey, look, actually, if a pendulum were to precess, right, we could say this mathematical model based on, I don't know, the sidereal rotation above us and a transfer of motion down from the sky would make this a Thermachian principle, would make this a mathematical example of how the translation of motion would affect the pendulum, theoretically. And you can present that to Globers and like, that's bullshit. Well, what's a model? It's got predictive capability. It does all the things. It's got math. What are you talking about, bro?
Hey, what did you guys think of? I know this is kind of old news, but what did you guys think of Terrence Howard's explanation when he was talking about how him and his friend were able to create the planet Saturn without using gravity through a simulation? Did you guys see that clip?
Yeah, I'm a fan, honestly. I think I think that if that was ever proven true, then the flat side has a serious problem.
Not only that, but there's that will tell us all that we really don't know shit.
Well, yeah, there's that. But I think we already know that. It's just the scientific community that hasn't really caught on yet. I think I really like his the way he goes into how things progress. You know, in line with what Walter Russell was saying, and then his outward in approach, which is what you're talking about, how he makes the universe. But I would like to see it demonstrated more. Like we've only seen it with that one Saturn example.
Well,
Before I would.
I think we'll see that more once Billy Carson and Terrence Howard start their new show this in 2025.
Good. I hope so, because I would like to see him do it with Earth, right? Like I want to see how you're developing a surrounding structure of tons and tons and tons of water pressurized in like that to where it just stays around a spherical surface. I still don't know if that's it, because you know Saturn is a whole different ball game, right? Earth, we're dealing with these physical. It's a rock. It's a body that's here, right? So I don't know if he's going to be able to succeed in that, but maybe he has already. I don't know.
Yeah, I don't know, but that's the one thing I'm kind of stuck on, because it does make sense when he goes into the explanation about the outward in instead of the inward out, because the inward out doesn't make any sense. But when you have the negative pressures pushing in, it makes a whole lot more sense. And then you span that over a long period of time. It's just, I don't know. It's just, to me, it clicks a little bit more than
Absolutely.
all the other explanations.
Yeah, I'm with you on that. I think so too. The outward in would also correspond to the downward pressure we can measure, right? The downward vectors that we measure. So everybody in here is always saying, you know, how do we have pressure, you know, without a container? Well, there's the containing mechanism there. His model has it. The standard model does not.
That's what I'm wondering, if Terrence is ever going to, because I'm definitely excited about this new show on Forbidden Knowledge TV. And I'm just wondering if he's ever gonna dip his toes into the geocentrism or the flat earth community, because he's like right there.
I think if his model shows that he can't model Earth correctly or something like that, I think he would have no choice. But if he's already got Earth modeled and his thing works, then he's gonna stick with that. You know, I don't see him changing. If his model works, it works. Same with the other guys. You know.
Well, yeah, he's already like the outlier in the science community because he's not a scientist. And those of you that saw the episode with him and Brett Weinstein on Rogan, they were talking about, they had a little argument about how the whole 1 × 1 doesn't equal 2, but I still kind of think Terrence is onto something there, because he never would have came up with tangential flight or any of that. He never would have come up with the linchpin invention, none of that, if that 1 × 1 did in fact equal 1 and not 2. But that's another conversation.
Right. It makes a lot of sense, because what you're doing there is you have a rule set that doesn't apply to the first quantity. You know, and so it actually doesn't make sense. It makes sense for the base 10 system and dealing with normal counting, but not in like physics. Not the way it's presented. Doesn't make sense. If you're multiplying a quantity by a quantity, let's say like an energetic unit, something has to happen. It doesn't just remain the same.
Right, like when you multiply, it's supposed to make more, not the same. Period.
Yeah. If you there was a really good interview he did. I posted it last week. You find it on my page. I forgot who the hosts were. It was 2 people though, a man and a woman. Really good interview, and he said it was going to be his last podcast. So, check it out. It's on my page.
Well, it might actually be his last podcast because of the whole him and Billy Carson partnership.
Yeah. Right.
Honestly, yeah. And I'm really excited about that. Like, I know there's some people who don't really like Billy Carson. He's a little on the outside, but his whole iteration with the Emerald tablets and all that shit is like on point, 100%.
Wait,
I love
Terrence
his work.
Howard doing a deal with Billy Carson?
Yeah.
Yeah, Billy Carson and Terrence
What?
Howard are teaming up to have their own show on Billy Carson's Forbidden Knowledge TV. This was posted, I think, like a month or two ago.
Yep.
But yeah, it's definitely happening.
I don't know
It'll
about that, y'all. I ain't gonna lie.
it's just
Is it because of Billy Carson?
Yeah.
yeah.
You think he's controlled opposition? Because I've like part of me kind of leans towards that, but like when you hear the guy talking about some of the topics, it's just like, wow, man, like, and he's not the only person who has said this stuff. Like, I'm more leaning towards the Emerald tablets, the pyramids, things of that nature.
Nah, he was just
But
talking.
yeah, he gotta talk. My bad. Go ahead, bro.
He was just talking shit about flat Earth, but it's okay. We know exactly how to get to him. He was claiming that the flat earthers he ran across didn't want to talk about physics. So when we hit him with the physics, I don't want to hear a peep. I don't want to hear a tear. So
Well, so
yeah,
I
we
didn't know
know.
that. I didn't know that he had said anything about the flat Earth community. I hadn't even seen a clip of him even talking about flat Earth yet, so I'm kind of curious about that one.
Yeah, he's mentioned that, you know, he pulled that kind of, oh well, that this was the case, and you know, and everybody then believed the earth was flat. You know, we now know that's not true. He's done that a couple of times. I haven't heard him say anything like straight up derogatory about flat earth, but he might have, and I just haven't caught it. But
Well, I
Sacred,
mean, there's two sides of the coin. There's two sides of the coin. There's the ancients that concentrated on the celestial movements. That's been proven. So there's a reason for that. But then there's also ancient civilizations who did both. They kept track of the celestial bodies, and they thought that the world was flat. Like ancient Mesopotamia, for example.
yeah, I think you know, Sacred, I think don't judge it. You know what I mean? Like I love his work, but I'm not a fan of him as a person. So really, because of some of the ways he presents his work, it's just like he presents it as too factual, you know. And
There you go. Yeah, D, can I say something real quick?
what's
Like
up?
patronizing, like a little patronizing.
Yeah,
No,
go
well,
ahead, Ghost.
I was thinking, the whole 1 times 1 thing. The thing that people don't understand and they're not looking at it is he's saying it in using kind of not confusing words, but the way he's saying it confuses the way you're supposed to look at it. It's not 1 times 1 is 3, which he's got a lot of people understanding. It's 1 times 1 set of 1. It's 2 times 1 set of 2. 3 times 1 set of 3. Now, if it was 3 times 2, it would be 3 times 2 sets of 3. So he's saying it wrong, and people are just going with it.
Exactly.
So
No, you're right. He's
like you
saying it
said,
wrong.
D, he's saying it wrong, and people are like, "Oh my God, he's right, he's right, he's right," and you're not right.
Yeah, he's saying it wrong. But the girl in the video, she checks him about that too. She's like, "Well, that's not it," and they get into a little. But then he pulls out a couple other situations that tie into it as well, with the squaring of 2 and a couple other things that he threw in there
Yeah, the
that are real
square root of 3 and
conundrums.
all that. That
Yeah,
shit makes a lot of sense though when you break that out into a calculator and you do it as he's saying it. It
right.
blows your fucking mind.
Yeah, the loop thing is pretty strange to me. But I'm not a mathematician, so maybe they understand it a little better. But the whole one of one thing, you can't multiply something by something and not have something else.
Reminds me of that M. Night Shyamalan movie where the aliens came and told them that the problem was that their whole system of math was wrong. They changed a couple digits on the board.
Yeah, I posted this like last week sometime. Like, I'm not sure why we use base 10 for all of physics anyway. I think maybe we should use something that just starts at 1, because there's always one thing there. There's never a time when something comes from nothing. So I don't know. I don't understand why that is, but we've been
Yeah,
using
like
it for a long
I have a
time.
question. Yes, I was about to say that. I was like, I don't understand 0. I don't even understand how 0 is even a fucking number. That
Like
boggles my
it
mind.
makes
Like
sense. it makes sense in like normal day every life. You know what I mean? Like if I don't have any apples, I have 0 apples. Yeah, that makes sense. But like from a physics standpoint, where you're talking about the creation of the universe and what, you know, all reality is, it kind of doesn't. You know, it's so strange that we use that.
Negative apples don't make no
Absolutely.
sense either. You can't have negative apples
Yeah.
and negative numbers. But they would say like, oh, well, you owe somebody. You technically owe somebody.
Yeah,
I mean,
makes sense for banking.
yeah, I was gonna say I understand when there's a negative balance in a checking account.
Right, but that ain't
Right.
necessarily a good thing.
Well,
No.
it's definitely not physics, right? I don't see that, so it's strange.
Sacred, you can drop me, brother. I got to do some plumbing.
Beat up. You gotta do plumbing.
Yep.
All right. Thanks for dropping.
Yeah, thanks for the breakdown, Ghost.
Def.
Later, Ghost.
Dude, sacred, proud. I think I'm a regular now, man. I've been trying to come in here like every weekend now for like the last 3 weekends. Now that you guys actually show up on my Spaces screen, there for like the longest time, you guys would never
Oh, we
show
show
up.
up finally? Yeah, shout
Yeah,
out to
yeah,
this
I
and
see you
that, man.
guys. Yeah, I see you guys every Friday now and every Saturday. I pop in, not Fridays, but I definitely pop in Saturdays. You guys are awesome, man.
Nice.
I'm sorry, but it's not just flat Earth that you guys talk about. It's all the other stuff I'm interested in, man.
Yeah, we get into a bunch of stuff.
There's a lot
Sacred,
of
what's
cross sections and common grounds, man.
Yes, sir.
piqued your interest most lately, Sacred?
What piqued my interest most lately? Like out
Yeah,
of all
like
these
something
conversations we've been
somebody brought up in the last few weeks that you were like, I need to think about that.
I need to think about that.
What else, Shane?
Dude, there was someone that brought up something when I was talking about meteors, and they were like, they brought up from their own research. That was something I had completely never thought of. That completely complemented what I was thinking of, and it like worked to a greater whole. And I forget what that was. It was something about the density of the top layer of whatever, meaning that the elements are actually produced there instead of like in space, and then literally matter falls from the sky, meaning meteors, and that's what meteors are. I was like, that makes a lot. Well, it makes way more sense than everything exploded into nothing, and then nothing falls down to Earth occasionally.
Good one.
Hey, Shane, was it Joe talking about like the firmament shedding or oxygen or whatever the composition up there has cyclical like things where things fall and that I don't know. I think it was Joe that was talking about that the first time on Discord.
No, Joe was really recent. This was like weeks ago from a Flat Earth Friday from a while ago. But Joe said some super interesting stuff too. Although I don't think I'm on board with the superfluid part of what he proposes. I think I'm on board with all of the other things though, like the observations that he makes.
Yeah, I thought about the superfluid, like when you see Musk's rocket scraping, they say scraping across the firmament. I don't think it's the actual crystalline hard structure, but it's the superfluid layer that they can't penetrate. There's one video where it looks like he tries to penetrate straight up through it and he's like getting stuck. The other one looks like a boat going across water. And so I'm thinking about if there is a dome of any shape and this superfluid that's very like it goes up, it would fill everything above us into a flat layer. So like the ground is level and the superfluid is level as well. That's kind of my thought between the Gaussian surface, but I could be wrong, but I kind of imagine it like that.
Dude, have we ever talked about those on Flat Earth Friday? The rockets that appear to like scrape water along the edge of nothing or whatever? Has that ever been a topic?
It needs to be.
It's probably like episode 22.
Oh, damn. Okay.
Yeah, I was gonna say I haven't really heard. I've heard it mentioned, but I haven't heard anybody go into it and like show videos of it and stuff. I'm not too big of a domer, so to speak. I don't know what's really going on with that, but it is interesting that you see ancient depictions of domes all over the place, and like not only just one, like a layered type of system in many depictions. And then like in the Bible, I think they said something about like a third heaven. So it's really interesting. I wonder what is going on.
It's all fascinating. Some people say even 7 layers, with certain luminaries like the sun and the moon being in the 3rd layer and projecting in. Or like, we have our azimuthal grid of vision. And if the sun and the moon circle in the 3rd layer, like the source of them, their energy, and then it somehow comes into our vision. I mean, all we're doing here is talking about what's the truth? What is this place really? And I like it when people don't get triggered when, there's hypothesis, or they'll say conjecture. Oh, you can't say that, you can't prove that. But, when we were little kids, when we were little toddlers, they told us the heliocentric model was as real as, our bodies. Like it's tangible. Oh yeah, we know, we measured it. And we're just trying to undo years of programming.
Yes, sir. I see Flat Etheric with a hand up. You got your hand up, bro? Flat Etheric.
Flat Earth Eric or Flat Etheric? Ooh, I like it. Are those the same?
Yeah, I don't know which one it is. I guess he can answer that if he's on. Maybe I'm glitching. Maybe his hand's not really up.
Morning, Flat Earth Eric. Can you hear us? You can speak if you got your mic going.
Did we lose Flat Etheric to the etheric wind?
I'm here. I'm here. Let me know about the audio if it's bad. I got one question. I gotta go.
What's up? Oh, yeah, he didn't have time for his question. He's like, I got one. I gotta go.
How dare you directly address him after he said he had to go?
No, he's a caregiver for his wife, and she needs him pretty bad sometimes. He's a beekeeper as well, so sometimes he waits and waits, and right when he needs to speak, he can't. Like he's got to go help her. So that's what's up.
Yeah, makes sense. Beekeeping is cool, man.
Yeah, bees are cool. How they levitate.
Yeah, absolutely.
Dude, speaking of rockets hitting whatever, I think I just put a video out there. I know I had a couple of these. I'm gonna put it in the.
You put one up?
Yeah, I'm just gonna put it up in the nest right there or whatever.
Yeah.
Because I never really, like back in the day, right, before I became a flat earther, the very first thing that I saw that gave me pause was like SpaceX rocket hits firmament on like Facebook. And I wasn't a flat earther, and I wasn't anything, right? I was a truther. I knew COVID was fake. I was under the government. I was suspect of people sacrificing kids to ball in the woods and then running the country, right? I was in the conspiratorial frame of mind, and I saw that, and I went, "What the fuck is that?" Like, okay. And then I brought it to like Globers. They were like, duh, that's like, a fuel tank exploded and it's hydrogen and it's leaking. And I was like, yeah, but why is it scraping like on a pond, right? Like, why when you skip a stone is it making ripples and what is not there behind it? And they were like, you're stupid. And I was like, okay. All right, well, that's suspect, right? And then I saw like 17 more of those and I went, what the hell is that? Right? And I'd never have gotten an answer to it, dude. And people just blow it off. And it's it's kind of one of the weirdest things about the sky. And it happens like all the time. The other thing that like breaks it down is, that, what's that? The rocket that went the highest, the Go Fast, the 2014 Go Fast rocket that like everyone says hit the firmament.
Mm-hmm.
Yeah, that just deployed that actual yo-yo D-spin that you can see the stuff. So it actually sprays out wings to slow the rotation and it doesn't actually hit anything as far as I can tell. And I was definitely pushing that one. So that's not a good example. But things in the sky hitting visible waves and then water like emanating waves behind it until it stops rubbing against it is very perplexing to me to this day.
So what do you think it's like a different density of air maybe, or a different density of something that's behaving with the fluid dynamics of water?
Yeah, yeah. I think it's, as Witsit often says, it's not like a hard, quick barrier. It's a layer of escalating or probably de-escalating density to a point of tenuity where speeds are increased with least resistance. So therefore, it's just a pressure gradient that at some point you would start to impact things, and there would be maybe a heavier resistance. And I think that's what you see is heavy resistance, right?
Yeah, I can get on board with that.
So then it's like, well, how far is that? How far is that? Like, do they always hit it at the same amount? Is that why that they all arc? Is it because that one arced too much and they went, fucked up the calculation on the trajectory map there. We scraped against the upper limit of the thing that we're not supposed to hit, right? Like, that's kind of what I think happens. Like when amateurs do it, or when they're like, oh, did you, what was the angle when you launched it? Like, how far was it going? You're like, oh, no, you got to lower that bitch. Well, I'll go into space. Yeah, but we go to space parabolically, right? Like, we got to go with the motion of the Earth or whatever.
Yeah.
That's all game to, like, pin it so that it stays under the upper limit, I think.
Do you think we'll get to the point where we don't need to launch that way, where we can just, like, go straight up?
No, they'd be doing that already, dude. Like, it's purposely not that.
I think we can get there if we can change, if we get some type of new technology for flight instead of just basic propulsion.
You mean like how all those drones over New Jersey right now that are definitely aliens and electrogravitics?
yeah, something like that. Yeah.
Hey, I gotta drop down or leave. But I posted the Falcon 9, one of my favorite rockets scraping the superfluid layer, whatever, where the newscaster is like baffled in real time, like he just can't understand what's going on. So check it out, and then I'll catch y'all next time around. Much love.
Alrighty, bro. Yeah, I'm gonna take a look at these real quick.
Nice. Let me steal JT's.
Shout out to Presidente. Proud. I hope you don't have your hand up because I don't see it.
Nah. You remember what I said I wanted to build a life-size version of? Or like at least my size? I don't know about life-size.
A vacuum.
I didn't want you to say it out loud. I needed a code word for it.
Y'all didn't hear that.
Yikes. Okay, I'm gonna text it to you, D3, but don't say it out loud.
Did Flat Earth Etheric want to chime in again? Or is he still running around?
Yeah, I'm back. Sorry.
What up, man?
It's all good, brother.
Let me know about the audio if it's bad. Two things. I noticed last week that when a speaker wants to drop, if they go to the menu button at the top corner, it gives them an option to drop back down. It took me weeks and weeks to figure that out, but I have this question for the people that hear Billy Carson. I'm wondering if they hear him fussing about Jason Bashir's. That's the whole question right there.
Fussing about who?
Archaics.
He was fussing about Archaics?
They're having a beef.
Are they?
Yeah.
Hey, I like all of their work. Archaics is he gets deep into some stuff, man. I like Archaics. What's their beef?
Archaics, the best I can remember is they were collaborating, and then Billy turned on him and helped get him locked up a while back. And there's a whole lot of detail to it I can't call right now, but it's on account of Billy sort of stabbed him in the back and then went for the throat. Allegedly.
Okay, so it's nothing to do with science or anything?
I believe Archaic thinks Billy Carson has stolen all his material from watching YouTube videos. I can't confirm that that happened, but he's highly disparaging of Billy Carson.
I don't think he's stolen anything from Archaics, to be honest. I mean, even if he did borrow a couple ideas or discoveries or whatever that he made, he's not really like come on. Everybody's been having their theories about these ancient books and stories for a long time.
Right. I agree.
And they all overlap, so it's like
yeah. I agree that completely, but not stealing from Archaics, but getting all his material off of just watching videos and not doing any actual research.
That would be hilarious, right? Because he built a whole brand off of what he claims he knows.
Yeah, if that happened, Billy Carson didn't do it by himself. He's like the turtle on the fence post. He didn't get up there on his own.
Yeah, well, I mean, nobody really does, right? We all got to refer to whatever someone else before us has laid out there, and then we can draw our own conclusions. But
yeah, I'm actually talking about Archaics has expressed the opinion, if I'm not mistaken, that Billy is a front operation for folks that we wouldn't like, people behind the scenes, maybe government, who knows?
Yeah, who knows? That's with any of them, right? Any of these famous people doing different and sometimes opposing, points about the same topics. You never know who's doing what. The government is our government, the American government is every freaking where, bro.
Right. I'm not pumping for Archaics or anything. I just wondered if people knew about this beef. That's all.
I didn't, so that's interesting. I didn't know they were beefing. Do you like either one of them?
This not the same. My bad. This not the same beef from the debate that Billy Carson had, did he? Like, is it?
Nah, that's a different dude. I'm aware of that one.
Then he beefing with the whole.
That dude, I think that dude was Jewish, and he was beefing specifically about. I don't know if he's Jewish, but he was beefing specifically something about the Bible. If that's the one you're talking about, it was recent, right?
Yeah, they were saying Billy Carson got exposed or something.
Yeah. It's all over the place. Cause this guy, he's a Bible scholar, and Billy is always quoting from this document and then that document and saying that they're the same thing or they overlap or whatever, or they're related. And this other guy, he's a biblical scholar, and he was breaking down some things that really, shed some light on what Billy was saying, and Billy didn't like that at all. And his rebuttal, he did a whole rebuttal video, not addressing the topics, but just addressing like other shit that had nothing to do with the topic. So it was real weak. If you haven't seen that on YouTube, he did a really weak rebuttal video, not like kind of like how Globers do, where they won't address the actual thing. He pulled one of those.
Not a good sign.
Not a good
like
sign.
Well, Archaics came out in defense of Billy Carson because of that thing, that dispute. He was pointing out that the Christians have set up an arrangement to go after Billy Carson, that Billy's not a biblical scholar and he's not prepared or trained, and they brought in this big gun to go after him with all kinds of hermeneutics and stuff, and it was a setup job against Billy, and apparently he didn't have enough sense to avoid it. But that's real recent, and this other stuff is because Archaic's point of his research is that standard establishment archaeology is completely fraudulent, and he's exposing them. He claims he's exposing all of their failures and frauds, and so they they put Billy Carson after him.
Yeah, I think it could have been a setup. I mean, whatever the case was, the guy definitely had a, whether it was people behind him setting it up or if he just himself really wanted to go at Carson. Um, but Carson in his rebuttal video, he was like, you know, we were friends and blah 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 blah. So, but again, he was addressing stuff that had nothing to do with the topic. So it was a weak rebuttal. It could have been targeted. Who knows? I didn't like what the guy was saying, to be honest, though. After watching their debate, I thought the debate that the guy was bringing, the Bible scholar, I thought it was weak, in my opinion, because it's one of those things where you're just so into the Bible you can't see outside the Bible. And Billy is known for being outside the Bible and like piecing things together from all different books and scriptures. So
What was the debate about? Because I thought it was about the Bible. So it wasn't about the Bible.
Yeah,
It was more
it was something
generalized.
about the Bible. Like Billy makes claims, right? Like he makes claims like, you know, this over here in the Sumerian text is the same thing as this over here in the biblical text, and he'll point out a couple things, but you know, like he's not like a biblical scholar. So this biblical scholar dude was like, no, that's not the same thing, and here's why. And you know, he went through a few different points on it, and you know, he pulled out a couple, you know, citations and stuff on him, and Billy wasn't really ready for all that. And he kind of seeded a few times, but at the end of the day, I still think like, okay, well, this dude is just Bible focused. Like he is never going to admit a correspondence because he's a Bible everything guy. So I actually stopped watching it at that point. When I reached that, I was like, yeah, I'm not really feeling this dude. And you know, I don't believe Billy wholeheartedly either. You know what I'm saying? I love his work. He's done a lot of good work, but he makes far too many claims, I think, and presents them as fact. And I think that's where this dude had his problem with him too.
Yeah, but they said Billy walked off stage. They said he left.
Yo, it
early.
was. I didn't get there. I didn't get to that point, but it wasn't pretty from what I got to. He was, like I said, he had already seeded a couple things by the time I tuned out. So yeah,
My bad, y'all.
homie G
All I
checked.
know is the gossip. I don't know the details. That's why I'm trying to get the details. So I only know a little
Yeah,
bit of gossip.
I can't remember the details of what they was talking about, but the dude, I remember the dude pulled out a couple of things. He's like, "Well, hold on, because you know I've researched that very thoroughly, and I deal with this every day, and we'll look at this and this and this, and it was like just shots. They was landing too. They was landed. Billy couldn't dodge none of that. But I think, like I said, Billy comes from it from a totally different perspective. You know, this dude is all in Bible. Whereas Billy, so you can argue like certain things all in from the biblical perspective, but that doesn't mean what, you know, that they're not linked to something else. And that's what kind of like what Billy was saying. But
Yeah, but if you said that during his whole damage control reply, he ain't even address none of it. It should have been easy to address.
yeah, that's the thing. He wasn't. It was like somebody showing up to battle wits and just not really having anything to go on. Like they had their ideas, but like they couldn't pull out anything. Like, you know how wits got that memory, right? Dude remembers a lot of shit, bro. So you pull
About to
out
be
one
on super
thing,
timing once he started drinking that Antarctica water.
yo, once the saying come out, it's a wrap, bro. But that's how it was. Like Billy was not ready for it. I feel like he should have came more prepared. But the worst thing about it
I
was
thought
the
that's what he
rebuttal.
do. Ain't this his whole lane? Like, don't he do like the whole ancient history research?
Yeah, that's what I'm saying. Like in his rebuttal, I felt like in his rebuttal, he should have attacked what dude was saying. Like because the dude pulled out, you know, A, B, and C, Exhibit A, Exhibit B, Exhibit C, and in his rebuttal, he wasn't really pointing out no flaws in the exhibits. he was talking about a whole bunch of other nonsense that had nothing to do with Exhibit A, Exhibit B, or Exhibit C. Like and it was like a 30-minute or something video. Like it was a while. Like he spoke for a while, and he didn't address none of that. Sacred, do you watch Archaics?
No, I'm probably subscribed though.
Yeah, you got to tune into Archaics.
I started watching it
like
recently, very beginning.
Yeah, he's got some stuff. Again, he makes some claims. He makes some wild claims too, but he gets deep. Like he pulls out a lot of references, man. I like Archaics.
Is the other guy blanking for a second? Well, is he seem like just a straight like anti-flat earther?
Who are you talking
The
about?
guy I forgot his name. The guy who's debating Archaics.
No, nobody was debating Archaics. I think they was talking about
the one that showed up unprepared. You said.
Yeah, that was Billy Carson.
Is he just an anti-flat earther?
He's pretty anti. Like he doesn't, as far as I can tell, he doesn't even want to talk about it. Like he feels like it's stupid. Like he doesn't want to talk about it.
I say he's anti because he misrepresents flat Earth. He'll say things like, "Oh, flat earthers don't think the atmosphere is real," or weird shit like that.
Yeah, he'll come out with little one-liners and shit. I don't like that either.
Well, and this goes back to the final experiment. Like there could even
Well,
be
hasn't
such a thing.
Austin said that just the term flat Earth has been pretty much demonized in kind of a retarded way?
Well, because yeah.
To where, like, if anybody brings it up, you get that eye roll without actually doing your research.
Right,
exactly. But that's their problem. See,
So, like, even I know that when the term was first said to me, I definitely did an eye roll. I'm not gonna lie.
We all did.
You know what? I don't think I ever heard it until like during COVID, and I saw a video. So I don't think I was ever really exposed to it in person. But I would probably have the same reaction like back then. If somebody said that, I'd probably like, what are you, stupid?
Hell yeah, I definitely gave it an eye roll until I came across Crow 777's Lunar Wave recording, and I was like, "What the fuck is this?"
Word. I think it was either Dubé or Flat Earth Dave. One of their videos in the beginning caught me. Like probably one of the zooming in on the ships thing. It was probably one of the first things that made me like really think like, hold up, what's really going on then? Because I was told that's going over a curve.
Well, it's assumed that it doesn't mean literally flat. It's level. And then they'll go along and they'll suddenly like play dumb and say, "Oh, it's not literally flat." Like, come on, guys, are you serious here? Or are you gonna play dumb? You know.
So I got a question for the panel. What do you guys think about nature not really doing straight lines and then claiming that this is a plane?
What about
That's a good
fractals?
question.
What about like snowflakes?
That's a really good question because there's no
crystals?
straight lines in nature at all, and all lines are curved.
Right. I mean, at some points, I guess things do intersect and overlap to a point where it does create something straight, like in crystals and stuff like that. But there's really not. I mean,
it's perceptually straight,
exactly,
straight, not actually straight.
Exactly.
Yeah.
Once you go down into it, it's not.
Or define nature like
reality.
gargantuan timepieces don't create and assemble themselves.
Physical reality.
Well, it's not just that. It's the fact that when you look at like all the old architecture, right? They never ever built anything in straight lines. It was all cymatics. It was all curved. It was all frequency based, which is crazy that we don't do any of that. Everything you see now is a right angle.
Yeah,
literally everything.
Yeah.
Are there? That's a really good point. Are there plants that make straight lines when they grow at certain stages, like trees? Some trees may be a straight line, some weeds maybe.
Yeah, yeah. But then that's what we were saying though. Like once you go down, for example, if you looked at them under a microscope, those straight lines are not actually straight. So like the end product is straight, but the development of it is not. So that's what I was saying. Like, do we think so? As a plane, would we be the end product? I guess that's the only way it would make sense, huh? Proud Sacred, what y'all think? Oh,
well, they said the whole
there
universe.
is.
They say the whole universe is flat. Although I did see a physicist that said the other day that the universe is spherical, so like I'm a little bit confused about that.
Yeah, interesting.
But it don't gotta be perfectly flat though, in order for it to like have a level.
Mm.
Well, see, I have something like, okay, so back in the day, like all the ancients, they kind of had a geocentrist idea of the plane that they lived on. But if you go like when the church was established, like the Roman Empire, like the Roman Catholic Church, they changed everything. Like this is bringing up Terence again, but Terence talks about how before nobody even thought of straight lines like we do today. But they said that because of the cross of the right angles and because of the power that the church had, that they changed the whole ideology around. And from that point on, straight lines were in everything, architecture, everything. Before that, it was completely different.
Does the pyramid have straight lines?
No. No, there's actually 6 sides. Is there 6 or 8 sides to the actual pyramid if you look at it? Because the angles aren't 100% straight.
It's 8 sides. They're mostly straight though, as far as I know. I don't think there's no curve in the pyramids, right?
Well, not a curve, but like a point on the sides itself that makes it 8-sided. Does that make sense?
Yeah. I know it's 8-sided.
Like a slight deviation.
Yeah. So that the difference is that
Yo,
the
Jamal, you hot
pyramid.
mic and Jamal.
Oh shit! I don't know what's up, y'all.
Yeah.
I don't understand how this shit. I'm not even touching this phone.
Nah, you good.
AI, son, you got your AI on. It was like, hold up, you need to hear this.
You turning up. My Shazam real quick.
It's anything man-made or whoever built the pyramids. That's us, or that's an entity here doing that. That's they didn't just spring out of nature themselves.
He was mentioning architecture. I think it's a real good point that we use all angles, and what Terrence Howard might have said about the cross and the straight lines. And I know the Egyptians had the ankh, which is a loop on top of some kind of cross, and there's the swastika. When you're talking about icons or architecture, that's a really good point of view. But I think there's straight lines on the pyramid. I could be wrong.
Yeah, I think there's straight lines there. I think straight lines go back as far as the study of geometry. So I don't connect it exactly to the church like maybe he was doing, the Howard was doing. But there are like establishments, right? There are establishments that control education and things like that. And there are scientific establishments that get in their way of doing things, and that's the way things need to be done. Right? So that's what I feel like he's alluding to. Like, we know straight lines go back, as far as our history goes, essentially. But he probably means like there was certain mechanisms in place that made it more prevalent. I can agree to that.
There may be examples from the Roman Empire before Christianity. They were pretty big and they were all over the place. They had like the Greek architecture. There's a lot of straight lines in if it's true, the supposed Greek Parthenon and all that stuff. Stairs require straight lines, and the Romans got everything they had from the Greeks and expanded on it. So that's an opportunity to check, but makes a lot of sense, although it's unconfirmed.
Yeah, straight lines.
Yeah, it's like it's pure speculation, but it does make a bit of sense though. Like we don't try to build anything like that anymore.
Right.
Like we don't. Like we don't even try. Everything's dormers, gables, eaves, all cookie cutter shit.
Maybe only bridges, right? I guess because we have to use because the bend creates certain tensions and stuff like that. So I think we use it in bridges.
Yeah, we use that because the whole stress management, the dispersion of
Yeah.
stress, so the whole bridge doesn't come collapsing down.
Right.
Railways and runways.
Like, what are your thoughts on like on some of that? Like,
I think
like the cymatics is crazy when you look at the old architecture.
I think there's a gap in history where we lost our connection to whatever body of knowledge that stemmed from. Either that or those people are no longer here, whoever they were.
Oh, canals.
There's different groups, right? So you have like the people who built in stone that was just super massive. Now I don't know if they're all the same group, but to me it seems like different groups because like the supermassive stones, they never have any decoration on them. Right, the pyramids themselves, there's no decoration on them. They're very mechanical, very plain. But the temples all around them, that's either a different people or a different, they're just doing it differently. Those all have endless artwork on them and depictions of things. You see the same thing in like India, same thing in Asia, like same thing in what you just mentioning, Rome. Like some of the buildings that are built on top of the really megalithic structures, the megalithic stuff has nothing on it. Look at Peru, right? Machu Picchu. There's really no decoration on any of that. But then you go to like the cymatics and who was doing that, there's decoration everywhere. Everything is decoration and maybe some type of acoustic function, like you were mentioning the cymatics of it.
Well, I mean, just look at Angkor Wat.
Oh, bro, it's crazy.
For example.
Yeah, it's crazy.
Yeah, explain that shit to me.
You know what's funny about Angkor Wat is that so it's surrounded by water. And then the Beijing complex that the people don't really think about this, but the Beijing complex is built in a similar fashion. But the water isn't there, as far as I know. I gotta check that again, but I think the water was taken out. Yeah, they were doing something with water, whoever they were. They built these places, connected them to water. The pyramids were the Nile used to flood right up to where the pyramid causeway was, and the bedrock underneath the pyramid is known for having water and a particular type of stone where it has a piezoelectric effect going on underneath there. So you see the same thing with star forts. All the star forts that have kept their water, you see the water in these star patterns around the city built in the center. Whoever they were, they knew about water, and it was a really integral part. Do you think they knew something more about the universe than we did? And our ancients were kind of stupid about that?
I think our modern society is stupid about that. I think they knew all of that thousands of years ago, and then something happened, and either someone or a group of people suppressed it, or a whole civilization suppressed it, or something cataclysmic happened. Because there's a huge, like, if you go, like, say you go 10,000 years ago, let's just go 10,000 years ago, and you look at the architecture, and then every 1,000 years up to the recent, you notice that the buildings, the architecture is more mundane, bland, no emotion, really, like nothing. Like it's not beautiful architecture, if that makes sense. You don't walk around anywhere now, and you're like, oh, that's a really that's a really nice looking skyscraper, or that's a really nice looking office building. No, the only buildings that stick out are the ones that you know exactly what I'm talking about. That's in the middle of nowhere. Or like not in the middle of nowhere, but like in the middle of the city. Like
Oh,
it's like a courthouse, a
bro.
school, something like I know quite a bit about that, but it's just like the fact that not a lot of people even think about that when they're just driving or walking or whatever. They just think, oh,
Yeah.
it's whatever. And it's just like, no, we have to get back to that.
You know,
I think
there's one in the heart of New York City that many people don't think about. Anybody who's in New York City, go take a real close look at the central building there, the what's it called? Uh Jesus Christ, how can I forget the name of it?
Not the library. St.
Grand
Patrick's
Central Station.
Cathedral?
Not library. Grand Central, bro. Go to Grand Central and look around that motherfucker. It's amazing. Grand Central Station is amazing.
Yeah, that really even occurred to me.
It just, I don't know. And I know this is completely off topic, but the fact that I know a lot of you guys actually know about this as well, but people, they make that excuse that that using granite and quartz and all that stuff is too expensive, doesn't make sense, it's illogical now because we use steel, cement, so on and so forth. But our buildings aren't going to last 100 years without some sort of human intervention.
They're avoiding,
like nature will completely destroy all of
they're
that.
avoiding
But then you
truth.
look around at all these other buildings that have been around for at least 1,500 years, even hundreds of years, and you can walk in them.
So do you think the original, so like the megalithic builders, like the people who built the pyramids, because they have astronomical alignments and things like that, they were into astronomy and astrology, whoever they were. So do you think they thought this place was flat, or do you think they knew it was round, but humans, the normal folk, thought it was flat?
No, they
Do you
knew
think there
it
was a
was.
different? Do you think there was a difference in the knowledge there?
I don't think they learned the knowledge by just stumbling upon it. I think they were told the knowledge by some sort of, I don't know, interaction with something that I probably can't even really describe.
Yeah,
Whether
whoever
it
was
was physical
building,
or
right? Whoever was doing the building, whether it was us, a different us, or someone not exactly us but like us, right? Whoever they were here building stuff.
I
Maybe
think
they
there were
built the
definitely
whole
two
planetarium in the
groups.
firmament.
Kind of like what you kind of see in society now. You have the haves, the
Yeah.
have-nots. You have the people who know and people who don't know. Think
Right.
they know even, but really don't know anything. Definitely. 100%. Yeah, I don't think it was. I think the only way that civilization or those civilizations or whatever even knew how to build like that, they already knew how the universe worked.
Yeah.
They already knew cymatics. They already knew about frequencies. And if you know about frequencies, you know about sound and light. And if you know about both of those, then you can manipulate matter.
Yeah.
I think they knew all of that because if you look at some of these buildings that aren't just in a city and what looks to be sculpted by rock, but you see the buildings that are like carved into the side of a mountain, and that shit is smooth as silk. There are no chisel marks, and it goes into the mountain.
Yeah. I know what you mean.
Like into the mountain. Yeah, and some people say like, oh, the upper half was melted. I don't know about that. I mean, it could have been, but why is the lower half still there in perfect condition? You know what I'm saying? Like, it's just they don't do that. Like, I don't even think we even know how to do that.
Funny thing about that is I have a bizarre theory about that. I think whoever they were may have known how to create what we call stone. Because when you look at some of these places,
like materializing it?
Yes,
Like
I think they completely
Okay.
knew how to materialize stone, because when you look at some of them, you see like it's just like a glob of stone. Like some people, like you said, say it looks melted, right? There's like a glob of stone here, or like a cliff face here, and then this thing, but it's there, but it's perfectly carved. Something is perfectly carved into it, as if it was done when that was like softer or something. So I don't know. Maybe they had a way. Like, look at Petra, for example, the city of Petra. You know what I'm talking about? Remember the Indiana Jones movie where he goes into that temple? That was
Oh yeah.
That's Petra. It's where it's in the middle of I forget the exact place it's in, but it's in like a very dry place, and there are these massive cliff faces of stone, and this thing is just like laser etched right into the stone. How do you do that? All right.
We're figuring that out actually right now. There's like tons of videos online about people using lasers and carving it into rock, like small rock. And then they're comparing that to what I just referred to earlier about yeah.
Because there's things that make no sense. Like in India, you have the I forgot which temple it is. It's one of the famous temples there, where you have this temple created in stone, but each pillar rings at a different frequency, but they're all in the same scale.
They have moving parts too, and it's all white.
Yeah, exactly. They have
yeah. You can like spin the pillars. You can like it sends out certain frequencies.
Yeah.
Oh yeah, I know what you're talking about. How did they know that? Huh? What? How are they smarter then, and we're so stupid now?
Yeah, so
You know?
that's what I was saying before. Like, so those people may have existed in a time that's not on record, and then everyone after them may have believed Earth was flat. But what if they didn't?
Well, how far back are we going?
That's the thing. Like, because I feel
Pre-flood.
Well, yeah. Like
The Chaldeans.
like what you said, civilizations that are not on record.
Yeah, it's crazy. I wonder what they all thought. I wonder what they knew, man.
I don't know.
They'd be able to clear it up for us. They'd be like, "Yeah, it's flat, bro. You didn't know that?"
Well, you wouldn't.
Well, no,
you wouldn't think
there's
it was a globalist. You know,
that
if you weren't
book
told it.
that I've referred to before to a couple people. You can find it on PDF, but it was written by a Herman Weiland in like 1917, roughly around the same time Walter Russell, but he was from Germany, and it's a book on Atlantis and the Bible and what he describes as the Ada, and it goes through like it talks about like the possible civilization that's like 200,000 years old.
Yeah, makes sense. That's about the time our genus is supposedly appearing in the record, right?
Yeah.
If there's any truth to any of that, which I don't know, but if there's any truth to any of our aging systems, you know, if we're at least in the ballpark, then we're pretty old.
Well, I think because I do think Atlantis was a real place.
Me too.
And I think and there's a lot of theories and a whole bunch of different locations that people think it was. I think once we find that, which could be in Antarctica, honestly, Austin could be walking and then just go down, like just fall through the snow.
Dude,
in
I
this
hope he
huge ice
sees
tunnel.
something.
And like, yeah, and then like these beings are like, Austin, we've been waiting for you. And then
Bro, wouldn't that be a story for the cast, huh?
Well, no, it's just I think he's gonna see some shit down there.
I hope he does.
Like I can't say that definitively, but I think that a lot of the proof that both sides are seeking, we'll just know. I think we'll just know for sure.
I hope he does see something amazing, dog, and because we're gonna have access to it, you know. So we
I don't
can
know
never
if they'll let
see
him near anything if that's worth seeing. You know what I mean? I don't know.
Yeah.
I've been dying to ask you guys about the whole final experiment thing. Which is that even a thing? Is there such a thing as a final experiment to science? That right there for me is a non-starter. I mean, I don't know.
I don't know about the final experiment, but about the Antarctica, I think like it's so cool that we're gonna have access to some just normal videos from people. Actually, not even normal, like really nice videos and stuff, and data points taken from these guys. You know, like we could never go back and see what General Byrd saw, you know, and verify his account. So this is probably the closest any of us will ever get to
Well,
verifying that.
that's the thing, though.
Yeah.
This is the thing. When what Admiral Byrd described of what he saw, it's described in that book I told you about,
Oh, interesting.
and it's described as pretty much Atlantis, because they say that all the buildings, they weren't made out of metal. I mean, they were, but it was more crystal, gold, silver, and gem oriented, like gems, like rubies, sapphires, stuff like that. Um, it was known as like the Crystal City. So it's kind of weird that Admiral, unless he read that book before he went on his flight, but I doubt it. Um, what he described like completely matches it. So that's kind of like a link there. But again, speculation, honestly.
You led to my next question about videos from down there. If we were on a spinning ball, if I was real, their model and indoctrination, all that, there would be videos on a regular basis, and we see it all the time. We see videos of the sun from Antarctica. They wouldn't have to fake them, like that one going around the Observer. They wouldn't have to take down real video from Antarctica of the sun passing by. It's a tiny little arc, you know.
Yo, can you guys hear each other?
Well,
No, I can't. I've just been listening to dead air for the last 25 seconds.
Oh,
damn it, you didn't hear any of that?
Libra's been speaking. So, Libra, can you hear this and that?
I can hear you. Yeah, I can hear. Yeah, this and
No,
that.
but you can't hear the other guy speaking, right?
I heard him. I heard him speak.
Oh, you did hear him. Okay, so
You said
this
you heard
you
nothing
can't
for
hear
25
Libra.
seconds.
No, I will drop down and come back up.
Alrighty. Yo,
What do
Sacred
you think?
Proud. You guys think? Oh, I'm sorry. Go ahead, Libra.
No, I was asking you what you think of. I mean, we see that all the time, and the last thing I said, they wouldn't have to take down the genuine video from the Antarctic of the sunset in quotes or whatever you want to call it.
What do you mean? I don't follow.
Well, they took I seen the video. The last genuine video that I'm aware of was taken down from YouTube in like 2016, I think, maybe 2015, from the sun from Antarctica passing by, as if it was our shoreline only. And why would they have to take that down if you know we were in their model that was real, indoctrination was real? They would, you know, it wouldn't be a big production. It wouldn't be a stunt. The final experiment, you know. It's like it's confirming that it is flat and their model doesn't exist. You know,
we'll see what the observations tell us, right?
Yeah.
That's what we're all waiting on, and I'm excited about it. So I wanted to get the androids' opinions, the cyborgs' opinions on prehistoric people. You do think they thought it was a globe, or you think they thought it was flat?
They weren't.
What do you guys get from their architecture? Look like the cyborgs are down for the moment.
They don't know. They know it's not going to work to just blow off ancient civilizations as ignorant and stupid.
Go ahead,
you know,
Bongo.
because they thought it was flat.
Hello?
Yes, sir.
Hey. So thanks for letting me speak here. I won't take too long. As far as just a blank yes or no, I think that if we're just going to imagine ancient people, they had to think it was flat, because when you hold a glass of water, it lays flat, and they would have looked at that, or like a bowl of water or a lake or a bathtub or whatever. And they would have looked out at the ocean. You know, when you look out at the ocean from a cliff or whatever, it looks flat. So just like an uneducated person from ancient times would have just blanket assumed it's flat.
I think so
That's
too.
not an assumption. Like,
Now,
why say
what do you think
unexcavated?
about the people who built megalithic structures and aligned them to the stars, though?
Well, so I just posted 3 or 4 videos in the chat there. You know, like
Okay.
whatever that. I don't know where it goes. If you can see it, it's the little white button in the corner that you post underneath on the Twitter.
Okay.
One of them is called "All the Ancient Mosques Point to Petra." I don't know if you guys knew that.
Whoa. No, I didn't know that.
In Islam, there's a big problem in Islam, and it's sort of an open secret that what is Saudi Arabia, wherever they have Mecca, is not the real Mecca, because all the oldest, there's like 12 or 13 of the oldest mosques in the world, and they all point to Petra. And Petra was a bustling city, and if you read the legends of Muhammad, he came from a bustling city of trade and all that. And why would there be trade in the middle of a super hot desert with nothing around, which is, if you're familiar with Mecca, it's like out in the middle of nowhere, and it doesn't make sense. Sort of like the whole problem with Atlantis of it being way out in the Atlantic Ocean instead of, Jimmy Corsetti was doing those videos about how it's the eye of,
the Ricot structure.
Right, which makes more sense because it would be hustle and bustle. That's a great place, a great look. They say in real estate, location, location, location. So the other one I posted, if you scroll down there, it's wave guides in ancient structures. And I don't know if most people are aware of this or what a wave guide is. It's
No, fill me in.
A wave guide is something that is used like when they build amphitheaters or in speakers. It follows the path. If audio waves or sound waves or light waves or anything, if they were all visible as like a squiggly line, you would build a structure. It doesn't have to. It could be little. It could be
following,
big.
like kind of following it.
Yes, following the wave. Yeah, and so you can use this to make like a natural amphitheater, or to increase or decrease a wave, and think about like those Bose speakers, like the little tiny.
I know what you mean.
Yeah. Those are all wave guides. So anyway, if you watch this video that I posted, it's called "Wave Guides in Ancient Time." This guy breaks down how all these structures that have been standing there in plain sight, all these ancient like megaliths and whatever, if you actually like scan them, they're all wave guides, so that what they were sending, whether it was like power or electricity or sound or whatever, they're all mathematically perfect wave guides for sending energy. What the
in which directions?
Yeah, that's I don't know, but if you watch that video there, you'll see they show it. It's basically mind blowing. And then
because the interesting thing about that is, like, NASA came out, I think it was a month or two ago, and they said that they've detected plasma in the upper atmosphere above the Great Pyramid of Egypt. And so we all know, we've known for a long time that there's some type of transmission happening from the top of the pyramid shooting straight up.
Yeah.
Some type of frequency. So I had a theory a long time ago that whatever the people were doing building these things, I always said maybe they had something to do with contributing to the expanse that we call the atmosphere. But I don't know if, I have no way of verifying that. That was just my own speculation.
Yeah. And then the other one is, I don't know if you're familiar with the channel Land of Chem.
Yeah, I've seen it before.
Yeah, this guy, I posted a video. It's this guy Jeffrey Drum wrote a book called Land of Chem, and he's like a chemist or whatever. and he breaks down how the pyramid complex, because they're all connected, was a giant alchemical factory that incorporated electrolysis and chemical production to make fertilizer and acids and paint and all. It was basically a giant chemical factory, and his channel is freaking mind-blowing. And once it's sort of like flat earth, that once you like go down the rabbit hole and really start listening to what he's saying and how he breaks it, like there's no turning back. It sounds crazy at first, but so I posted an interview where he did on this podcast where he gives like an hour-long presentation.
I think I've seen it. That he makes a lot of good points. I just don't know if it. I don't know if that's the only thing that they were doing with it. But it could be. But I don't think so.
Well, have you seen that? There's a guy on Twitter now. I forget what his name is. I think it's like Marcus Foilet or something. But he's been experimenting with natron, water glass, and lime, and like casting stones from scratch, basically like concrete, and his theory is, and wood ash, and his theory is basically that one of the reasons why, I mean, the cataclysm probably took place, but the desertification of Egypt was caused by deforestation because they were using so much wood ash in their concrete mixtures. And so they would basically clear cut and burn everything and collect the ash and put it in their concrete, which makes limestone. And then you mix it with like wood ash, water glass, natron, and powdered limestone, and then you cast it. And he's been successfully he created granite from like ready mix granite, and he's been pretty successful. But it makes sense if you look at like why Egypt is a desert, because they went around clear cutting everything to make their concrete.
Well, that makes sense if you look at it in isolation. But when you zoom out, you see the bigger picture, right?
Of the cataclysm?
The desert does not start at Egypt. It starts way over in the Gobi Desert of China.
Yeah.
And swoops all the way across the top.
To me, it looks like it goes from Africa into China. Like that was, and then the wave sort of dissipated in China.
Exactly. Or the other way. Whichever way, whether it was east or west, whatever it was that entire sweat.
Yeah.
Like
here's the kicker though. If you actually zoom out, it actually looks like it starts in America in what would have been a glacial ice lake, and then goes through the Grand Canyon. There's a place in California on the border of Arizona and California called Glamis.
Yeah.
It's like a giant desert in the middle of, like, I think they filmed Star Wars out there. It looks like the sub-Saharan desert. I drive through it all the time. It's huge, like 300-foot sand dunes and stuff.
That's crazy. Yeah. Something just swept across, man. It looks
right.
When you see it, it looks crazy.
Yeah. So
what the hell could that have been, bro?
Well, my theory, it's not my theory, but the theory I believe is the channel UAP, Dougie. There's a guy named Dougie. I think he runs it. UAP is the name of the channel, but he does all kinds of. It's not UFOs. It's just all kinds of stuff. But he had an episode where he was exploring the possibility that there was a giant lake, like Salt Lake City area, huge, massive glacial lake. And at some point there was an earthquake and the lake broke free. And when I say lake, what I really mean is like an inland ocean named like Lake Gargantua or something, like bigger than all three of the Great Lakes put together. And that could have been the cataclysm, because if something that massive just dumped, and it would be above sea level, like maybe in the mountains a little bit, and there was an earthquake, and one of the one of the sides of the lake broke free, and all that water came spilling down across southern United States. That would like the great earthquake of 1812 supposedly made all the rivers run backwards. Well, earthquakes don't do that unless the whole content shifts up, which nobody thought that. Because then if that happened, then everything would be like the Great Leaning Tower of Pisa, like all the buildings would be like that. But that's not what happened. But what if a giant lake broke free from the mountains, a giant inland ocean, bigger than all the Great Lakes combined, and came down into the ocean and then swept from, what America from the west across the Atlantic, giant tsunami tidal wave over the African part, which, by the way, we don't even know how tall it is, because like there's parts of California that sink like over a foot a year. So Africa could be way higher now than it used to be. It could have been down low, like Florida.
Yeah,
Well, I have a
it's
question.
all
I have a
crazy.
question
What's up?
then about that. Do you actually think, though, that much water would create tsunami waves that high to be able to do that much damage? Because that's a lot. Like you're talking like waves probably have to be at least a mile high, at least.
Right.
And that, I don't know if that's going to be caused by a giant lake, because it's going to dissipate over a long,
Well,
over a far area.
the tsunami wave doesn't have to be a mile high if Egypt and all that was down low like Florida. Like Florida's like 10 feet above sea level. So if a giant storm, and have you seen like the hurricanes and stuff, like storm surges that are only like 10 feet above sea level will sink the whole freaking coastline. And you can see like the ocean comes in with a moderate hurricane. And that's with all the advances that we've built now. If it was ancient times and Egypt and all that was like basically sea level, and a 20, 30 foot storm surge wave came in, yeah, it could easily. And if like Jimmy Corsetti says, according to the legend of Atlantis and all that, it didn't actually go beneath the waves. It was like in the muck and in the mud. It was flooded and it was impassable by boat, but that doesn't mean it was like 100 feet underwater.
Yeah, I don't know, man. All I know is that we have the remnants of some type of cataclysm that happened. We have great stories of floods, and or stories of great floods, I should say. And
yeah, and I mean, I've seen those videos about how like I'm in Arizona and there's that crater out here, and I don't think it looks. I believe the fountains of the deep. And
my big geyser. Yeah.
Yeah, the geyser explanation, and that could be. I don't know. It could be. I mean, if the problem is that if we are in a flat Earth environment, then that leads itself to the overlords, archangels, the watchers, whatever you want to call it, that we are like rats in an experiment. And
why?
We're quarantined. I mean, it feels like it.
Because it is what it is. I mean, it is a level stationary environment. There's no getting around that.
Yeah.
You wouldn't, if you weren't told it was a sphere, you wouldn't think it was a sphere.
No,
wait, hold on.
No.
Flat Earth Eric? He had his hand for a while.
Yeah, I wonder if I can drop this about architecture. I live in North Carolina near the state capital, Raleigh, And my town has a very large population of Hindus from India. There's 4 or 5 different temples in this area, and one of them real near me brought in a couple of hundred masons from over there, and they built this huge architectural temple tower thing, and it's very ornate. It's got a lot of carving on it. And these guys showed up, and the stone came from India, and they carved it on the site and erected it right there. It's a very recent, in the last 3 years, 4 years, construction, and it looks like something from ancient India. So folks want to look, maybe they can Google Hindus, North Carolina, or Hindu temples, Cary. It's just something to consider. I'm pretty confident we could build anything today that ever was built, except for instance, like the pyramids, which I think are probably supernatural. But regular cathedrals and stuff, you know, if the economy favored it, we could do that. And anyway, look up the Cary, North Carolina Hindu temples, and some of them are just warehouses that are converted, but this one was built from scratch, and it's got the carving, the deities all over it, and all that kind of stuff.
Yeah, no,
That's
no.
it.
I think the carving technology we could definitely do, and on a softer material for sure. But I'm talking about the stuff that you're seeing on like granite, you know, quartz, some of the hardest materials on the planet or on the plane, whatever. Sorry, it's habit. Yeah, because if you could easily carve it out of like concrete or plaster or even limestone. But I mean, like granite's a whole nother conversation. But it is also uh, good that you said that they brought their engineers from over there to build it. Do you know?
Masons.
Yeah. Do you know of any?
Masons.
Do you know of any practices that they may have had that's older knowledge?
No, I'm not that close to them. I've been on the property, and it's right next to a old state highway, so it gets a lot of traffic. It's an urban street now, and when they built it, there was a forest in front of it, and after they got done, they chopped the forest down so everybody can see it. You should probably try to find images of it online. It's Cary, North Carolina Hindu temple, and I don't know why you thought it was something soft. I'm pretty sure it's not soft material.
I was just curious. Do you know the material that they actually used?
I can't confirm that, but I assume it's granite.
I'll definitely look that up. I just like seeing architecture like that. I think there was something to it then.
You guys, one of the craziest things in the ancient times are the connections between cities and certain buildings and stuff like that. Under pyramids, under all these structures, like vast places. Just how do you do all of that? It's crazy.
Was there any do you guys or have you guys talked about like ley lines? Do they have the same significance on a flat plane?
That's a good question. Shane, have you ever looked into ley lines if you're here? Shane, because Shane works a lot with the maps and things like that, so he might be the best one to speak on that.
Because I'm just curious about that because
Yeah,
there
hold
has
on.
been talk about like lines through the earth that have like etheric or energetic connections when connected across like straight lines?
Well, so we would need to map them realistically. All I've seen is people draw what they think is a nice geometric web and then have that web projected differently over different projections,
Right,
right?
right. I've
So
come
like
across that same stuff.
I don't know if the actual turtle shell thing that looks so pretty is the actual where the ley lines are, or if it's this. I've seen like other interpretations of it too. So does it make more sense? I mean, we'd have to see. Like ley lines themselves are kind of iffy in my mind, right? Because like
Yeah, yeah.
I'm not even sure if they're
That's why.
real.
Well, that's why I thought I'd ask because there's a clear connection with water. Like they knew something that we may not know now about the whole connection with that because it's been proven that water does have memory.
Yeah, I'm not gonna fight you on that one, dude. That's the first thing I noticed way back when, and people would doing experiments, and it would freeze, and it would form like a picture underneath it, and it would use like shadows to recreate numbers in different fonts and transcribe things that were written as notes.
Well,
no one has any explanation
yeah.
for any of that shit, and that happened. So,
Well, it's not just that, but they were familiar with crystals too. Crystals also hold memory, and if you see some of the architecture, especially like the Middle East, Russia, not Russia, I don't even know why I said that, but in the Middle East, you see that there's because like quartz and granite, aren't there some electro properties to both of those?
yeah, our friend Piezo Etheric or whatever came in and told us all about that. It's his favorite topic. If he was up here listening, he'd probably educate everyone on it. Yeah, he's all about the etheric. What is it? Electrodynamics of the etheric crystal or some sort of crazy shit.
Hey, can I just pop in 1 second? You know the earthquake guy, Dutch and Sense on YouTube. He shows that earthquakes follow the ley lines, and that he thinks that's how they use the HARP technology to run the charge or whatever they're using through the ley lines to target specific sites. So if you're not familiar with Dutch, I highly recommend you subscribe to Dutch Sense on YouTube, and he's like the earthquake guy. I'll pop
Oh
off.
no, I've seen him here on X. No,
Yeah.
some of the stuff he's come up with is pretty remarkable. Like he follows all that.
Yeah, and he points out how ley lines actually transmit electricity, and also how like ley lines run through star forts, and how the U.S. government like co-ops star forts and builds their military bases on old ones, and so yeah, there's something to that there. And I'll jump back off.
I bring this up a lot, but I'm wondering what the hell is underneath us, man. Like a mile or two under the ground. Like have any of you guys ever thought about that? Because obviously we can't. I mean, there's been no concrete proof that we've actually gone up in space ever. Okay, so I'm curious. Like, what are your thoughts on like like
Well,
kind of
we
like
know
not
we've
what
only
we
been able
see,
to,
not what we see. Yeah, go ahead.
right.
We
We've
can't
only
go
been
there.
able to get down what's 7.5, 8 miles as far down as we've been able to get.
Even in the
Warhol,
ocean,
Russia,
right?
and the Mariana Trench are both the same depth.
But even in the ocean, they reached that density layer where they can't pass it. The submarine tried to go through it and it bounced them right off it. And they were like, "Oh, what's that?" Boom,
Yeah,
boom,
didn't that guy
came down.
die shortly after that?
I don't know about that.
Yeah.
But yeah, there's definitely a boundary to the top and the bottom that people just evade about, dude. We can't go further down. We can't go further like passed out.
And
Like,
whatever it is, it eats up the drill bits. It just eats them up. They can't get past it.
but like the people who control this world are trying to like devote their lives to getting out past that on both ends. They keep trying to get out, and it's such a weird mindset to be like, "Oh, look, you were created and put in this perfect place where everything you need is here," and they're like, "Fucking blow it up, let me get out." Fuck God, how do I do it? And it's like, oh, that's a different position than I would take by default. You know what I mean? Like, wait a second.
You might be able to just walk through it. Maybe you might be able to just walk through it.
Well, I have a question. Well, this
You
brings
know?
up a question when you guys are talking about like trying to get out. Do you think that maybe our attempts to get out might cause a cataclysm?
No, I think we can't get out, and I think probably
At
God would be
all?
amused by us trying. Yeah, like literally, like we have natural
I
boundaries
think
of
they did.
darkness and impenetrable awfulness. Like you can't go past there. There's no sun. There's no light. There's no heat. There's a natural boundary that will make you not go there. It's not gonna like. I mean, you can kill yourself running out there, but there's no like. No, I think it'd be
Well,
funny.
yeah. Well, I just want to make a
They-
statement. My questions don't necessarily reflect my opinions or my actual beliefs. They're just questions.
So that's cool, man. I just like the Operation Fishbowl when they tried to shoot nukes up at the firmament too. They were like, "Oh, is there a barrier? Let's try to blow it up." Like that was their first inclination, right? Hillary Clinton made obvious references to that, trying to detonate the glass ceiling. However she put it, like
Well, she was she was talking about something else that the glass ceiling was how they described women not being able to get ahead in the executive culture.
Yeah, I'm familiar with the context. I think the innuendo stands.
She's so self-centered. She would think, because she didn't win the election. It's like, oh, we're gonna get there, but women. By the time she was rejected in the election in 2016, that wasn't an issue anymore. Women were in the executive culture, CEOs, CFOs, that type of thing. So this is a complicated bird. But I mean,
think,
it's kind of in your face too. It's firmament.
To answer your question, for me, I think it's possible that it could cause a cataclysm if there is some type of barrier and we figure out how to say pierce it or something like that or break it. If there's a way to pass through without that, I don't think will cause anything. But if we have to, like I said, pierce it somehow, we don't know what's on the other side, and we don't know what that piercing would cause. So I think it is possible to have a cataclysm caused in that manner.
I think it
depending
happens.
on what's on the other side.
Yeah, I think if they could have, they would have already. Right? These are intent.
I think they did. That's what they warned Adam Bird about. I think they did it, and their punishment was their success. Hold on, Lynn.
Yeah, they didn't pierce anything, bro.
Yo, on a different topic, have you guys ever seen time zones in
Well,
Antarctica?
I didn't necessarily say pierced. You could have brought it down.
I haven't.
It's kind of ridiculous. It's the most ridiculous thing I've seen today, and that's saying a lot because I was looking at some crazy globular theories earlier. Dude,
I'm looking at your post right now. What's up?
Look at this picture. I'm trying to figure out and speculate why it's like that, right? If you put it out on an AE projection, and it's obviously the different time zones are all around the outer edge of Earth, and how they're saying that actually at the bottom, it's the same. It's different all the time, I guess. Dude, that's the craziest thing, except for UTC 0, which actually owns all of the South Pole, if you didn't notice. So it's like all of the geographic South Pole is UTC 0, which is what is that Greenwich time? So like Greenwich time extends all the way down from the Royal Society where they built their observatory, where they first did it in 1700s, all the way down through the circumference of the geographic South Pole and through their own little slice. And meanwhile, everyone else owns a slice or whatever. So it's like 9 time zones down there.
Well, isn't the UN map, doesn't that show a flat Earth map?
Well, maps themselves aren't really arguments either way. It's just projections of a coordinate system based on angles to the stars from geographic. Yeah, so that's just longitude, latitude. But I'm just looking at the time zones, which they often argue are political, and I'm just figuring what's the political explanation for this bullshit.
Well, some people think it's to hide the time
aliens,
zones,
bro.
to hide flat Earth.
Like their argument is like it's just political, bro, and it's like, boy, our argument is that it should be geographic, determined by the sun. And if that was the case, Antarctica wouldn't look like a fucking pizza zone or whatever, all sliced up like this.
Yeah, that's an odd image there.
Set her hand for a while. Lynn, you had your hand up.
Yo,
I was just going to go back real quick to the rivers running backwards and earthquake and the New Madrid quakes. There were actually 3 quakes within a 2-month period. They're estimated to all be between 7 and close to 9 point. So I would have been terrified if I would never live there again. But anyway, so my let's see, my husband's like second, third cousin up the line lived through that. and we have her, childhood and adulthood memories written in a book on Texas history because they ended up in East Texas. But anyway, she just made, and I don't doubt that the rivers ran backwards. There's a lot of reports of that. But they lived in almost right on the shore of the Mississippi River in Cape Girardeau, Missouri, which was 40 miles north of what they think was the epicenter. And her only comment was, in January that year, the earth shook. And you would have thought that, 40 miles would have been close enough, it would have shook pretty hard. And that she would have commented on the river going backwards, because I have seen the family cemetery on Google Earth there, and it's like kind of in downtown, Cape Girardeau now. It's not that far, their land was not that far from the river. So anyway, I thought that was interesting. That now maybe she was just a child, and so that's what made an impact on her, or that's all she remembered. But she just said, she was just kind of going from year to year telling what happened. And in January of that year, the earth shook. That's all she said. And I just thought that was funny.
Well, I, for one, am pretty sure HARP causes earthquakes, right? They can use that to harness, to direct the energy, to just cause the resonance, to resonate downward. Like, I think they picked that up a long time ago. I put a video out just now on HARP and earthquakes. Everyone should check that out. It's a pretty easy one. They talk about it all the time. Remember, like a couple months ago, they happened in like Romania and Turkey, and people all of a sudden nowhere. And there's always political events going on in the background and stuff like that happen. So it's definite grounds for abundant speculation on employing earthquakes as a weapon and using HARP to do it.
Oh, just like the hurricanes. I totally believe it.
Hurricane, definitely with the hurricanes. I guess it's almost the same exact technology with earthquakes, right? They just figured out how to direct it, and they upset the natural balance, and the natural balance is the earth sorting itself back out, and then you get earthquakes.
And yes, somebody mentioned Dutch Sense. He's a good account to follow. He doesn't claim to predict earthquakes. He says he forecasts them, similar to weather forecasting. And he teaches people who follow him how to do it. He says, and you watch him and you can kind of, okay, I've got a good idea where, about how strong it's going to be, where it's going to go, because they follow the, what are the plate boundaries, or the craton boundaries. In the United States, we have a very large craton that goes like kind of through the Rocky Mountains and down into Texas, where the fairly minor quakes are, but where they do all that drilling, and then back up through Oklahoma, and then kind of right across New Madrid, and then up into the northeastern states. But he's an interesting one to follow.
What's his name? Dutch what?
DUTCHSINSE. And he may have a copycat. I think he has a blue check mark. I'm not positive about that. But I think it's just Dutch Sense. I'll get back on if it's different. I'll go look it up.
Dee, I had a question. You were talking about Terrence, modeling Saturn. Can you expand on that a little bit? Because I didn't see that.
Okay. No blue check mark, but it's at Real Dutch Sense. And there are 2 or 3 Dutch senses, so be sure you get that one. And when he figured out this method he uses, it was like, I don't know, 10 to 15 years ago. And if my memory serves me correct, he tried to share it with with the USGS or whatever, not keep it just to himself or anything or make money off of it. And I think they ended up, they tried to sue him or something, because I think he showed the USGS logo and something he did, and they tried to, ding him for that. And he's somewhat paranoid, but just because you're paranoid doesn't mean that
they're not after you.
that they're not after you. Yes, and so many. He has had to buy so many new computers and new set up new Wi-Fi. A lot. He has so much, and sometimes he just says, I can't handle it anymore. And he just quit. He won't do it. He'll just talk. He'll talk about other topics, but he won't talk about earthquakes because it seems to, weigh very heavily on him. Like I said, who knows? Who knows if it's real? I kind of believe him that it is, but you never know.
Oh, there we go. There's my ley lines. So I found it. I found the map of what's supposed ley lines, and then I just quick converted it to AE, and that's what it's supposed to look like, and it is like the perfect flower of life. But they would have to prove that the ley lines that I mapped out on the first one actually exist that way. I'm not sure what determines that. Sorry, I was still thinking about it for a while. I think if you do like the megalithic structures, they seem to be on certain like lines and parallels, but then that's just the only way to judge that is based on the stars, right? Because a parallel itself is a declination of latitude of a celestial object in the northern hemisphere in the first place. So like if they're all aligned on the same declination, that's speaks definitely to coordination with the celestial objects, knowing when they would be for eternity. But does that mean that that's a magnetic ley line, meaning that's where actual energy passes through, like a vein through a body? Like, I don't know about that.
I just remembered something else that Dutch Sense discovered. And he had mentioned this before this year. He says that the Doppler radar are not, their primary purpose anyway, is not for showing where storms are moving. He says they're for creating the storms. And there's another guy that you could follow on Twitter, and his account is Into Thin Air, and I think it's IN2 Thin Air. And so both of those two guys have shown on the radar where some kind of energy is coming through, and one of them says and I think it's Dutch Sense, there's a 50-mile radius and maybe 100-mile radius around each of those radars that you see on the map. And he says those storms nearly always start at that 50-mile mark. And they've both observed energy going from those and through those areas, and then here comes tornado after tornado after tornado. And one of those, I think it was this last spring, or might have been the spring before, here in Texas, in the kind of northern, toward the Red River. I can't even remember if it was Abilene or a different town. It was right across where Red River divides Oklahoma and Texas, and there was just storm after storm after storm after storm that came through, and you could watch it on the radar. Yeah.
Imagine them
Boston.
using that. Ooh. Yeah, go ahead, JT.
No, yeah.
I think somebody had their hand up a second ago. I'm going to give them a second to speak if they're in front of me. Go ahead.
I can't see any of their hands.
Okay, I'll go. Lynn, that's cool that you brought up Dutch Sense again. I think we had spoken before about a video that I'd love to find where he collaborated with, like, I think 2 or 3 other streamers, and they were talking about star forts, and they were looking all over they use Google Earth, but they were looking all over where these are, and it was amazing. He's a great guy to watch. But I mainly popped back up because Joe sent me a text. He said last night when he went on his phone, he just ended up creating an account at Joe K. Hanvey, and everybody kind of started giving him a follow. I put it in the jumbo. If you'll unfollow the Joe K. Hanvey and just follow the Joe K. Hanvey FE, and I put a link to the actual account. That's the one that's tied to his verified email. The new one, I guess he should have just logged in, but he just quickly created an account so he could come on Flat Earth Friday. But that's basically it. Just follow the right account. Thanks.
Thank you for the clear up, JT. I tweeted something. I might have to change my tweet, but
yeah, I don't
all
have
good.
premium because if you have premium, you can edit your posts, right? Because I tagged him a bunch last night, and I guess those are just going to be wrong.
Me too. It's always good to have a backup account. I don't have one, but
that makes sense. And then, Lynn, are you in Texas still? Because I'm in Texas, right? Born and raised, and spent most of my life here in East Texas.
I was born in Flat City, otherwise known as Lubbock, Texas, and my parents lived near a little town called Levelland. Yes,
Flat City and Levelland.
Yeah,
that's funny.
Yeah.
Lubbock is where Texas Tech is, huh?
Yes.
That's where my wife went to school.
Really.
Yeah, small world.
My daughter went to law school there, unfortunately. That's another story. But yeah, and my husband went there a short time.
Nice.
But yeah, now most of our married life, we were not in Texas. We've lived all over, including Alaska. But we came back here when our parents were getting older because we knew we'd be needed, eventually. So we just found a spot, where it'd be quick to get here, and then we ended up moving here when my mother needed us. So.
Yeah, that's awesome. Yeah, my wife's from El Paso, and I'm on the opposite end. And then, she was in med school and in the Air Force. So the Air Force sent us to Northern California, Washington, D.C., Nebraska. And we kind of came back because my dad, he's not that old. He's like 76, but he's still living. And we're back to my hometown. And it's great, man. Texas is great. But if I could really land somewhere, it would be Colorado. And I'm not talking about the political scene. I mean, like just the mountains.
The beauty.
Yeah, the beauty.
And the lack of heat.
Exactly.
And sandstorms. If this weren't home, it would be the last place I'd live. But my sister was born in El Paso when my dad was stationed there during the war. So
that's awesome.
Yeah.
I got a side question for Sacred for anybody watching their watch. How long was the flight from Punta Arenas to the runway strip? Like, do we know if they're halfway there or almost coming in for a landing? What's the deal?
Oh, you know what? I didn't keep track. I did put out a tweet, but it was like a little bit of a time after they took off. I want to say like maybe 15 minutes, 20 minutes after.
This is all so exciting.
Sacred, it was you that I'm pretty sure that I heard from you that the moon disappears for 1 week out of the month, right?
Not 1 week. I think it's just 1 day, right?
1 day? Yeah. Somebody was he wouldn't believe me when I was saying that because he keeps thinking the moon's disappeared. That was gone for whatever time. A couple of weeks back, I'm like, no, I'm pretty sure it's gone. I heard from somewhere it's gone 1 week out of the month or something. So all right.
Yeah, Joe was talking about that, and he calls it no moon. It's where you can't see it at all. No one can find it whatsoever, and it's not a full week. It's only a particular amount of hours, or I can't remember if it's a day and a half. So sorry, but it's interesting. And he was explaining how the full moon is, I guess, what opposite to the sun when it's full, and when it's closest to the sun, it maybe I have this backwards, but that's when there's no moon, and it's all to me the moon charges and discharges its illumination rates, and that's kind of what makes it full and all the way down to a sliver and then gone, which to me is fascinating.
I'm just doing moon measurements right now, and I'm just looking at its position, if it actually changes, from where you observe it, and it actually does change by the angle, I went like half a mile, and the angle really changed.
Well, there's one thing that I did that was interesting. At my home, the moon was coming up or appearing to rise, and I snapped a picture. And then 8 hours later, it was about to quote unquote set, and I snapped a picture, and I saw just how much apparent rotation it had. And one of my questions was, is this item rotating? Like, is it rotating, or is it just an optical phenomenon? And this is me working with my P1000, and I'm no pro like Joe, but I noticed that when I look to the east, things move from the middle of my LCD. Like if you look at the left side of my LCD, and I have something coming in right at the middle, it goes from the middle left to the middle top. And if I turn 90 degrees, it will go, all the luminaries will move, and even the moon will move directly flat across the top of my LCD. And then if I turn 90 more degrees west, it will go from the top of my LCD in the center to the right of my LCD in the center. And it's just basically, to me, that's just the way that all the luminaries appear to move in our grid of vision, which has all been fun to play with, but y'all can probably explain it better than me.
Hey, did I say what up to Ken? What up, Ken?
What up? What up?
I thought he had more. Dude, I put Joe's video up here, JT, and I didn't just link to YouTube because I don't know if you know, but people are super lazy, and unless the video plays immediately in whatever platform they're natively viewing it, nobody's gonna watch it. So I stole it and put it on Twitter so for the Twitter lads to watch it. And also, I gotta watch the sun part of this because I only watched the stars part. And I think I tagged his proper handle. Thank you, JT.
I think I'm the only person that hasn't seen any of this guy's stuff.
Yeah, perfect. So for people like you, Ken, that's exactly why I just posted it up there. Also for people like me who only watched a snippet of someone else talking about it, and I'm super lazy, so I should watch it myself.
Ken, I'll probably DM you the first one to watch, and it's his Truth and Freedom presentation. It was a biblical cosmology conference where everyone there, is biblical cosmologist, and it's pretty fire. That's a good intro video to his stuff.
Didn't you just do like an interview with him on a Q&A? Let me get that.
Yeah, he came on my channel and we talked for, I don't know, what was it, like 3 hours, and Dave Weiss came on and a bunch of other legends rolled through. It was epic.
Yeah, let's post that too then, obviously.
Thanks.
Damn, how far behind am I? You got a channel, JT?
Oh man,
Right?
I've got 1,200 subscribers, which is pretty epic or exciting. And then I've been doing live interviews. I've had some people on just telling their story, and yeah, I'll post my channel too.
Yeah, please do. Nothing like advertisement there, bud.
Sorry, I don't talk about it much.
Yeah, it's okay. He's got to be prompted by his boys, but we do pretty good pre-dunks around here, so it's cool.
Yeah, under the video section, there's a lot of clips. So there you'll find Flat Earth Fridays on there. You know, I think I have Witsit versus Franco. I think I've got Piezo. You know, I just got different hot moments. I haven't caught up. I have 30 clips that I haven't messed with just because it's weird. Like just staying live in real time with what's going on takes up a lot of the time, and it's hard to actually work on stuff. Y'all probably know how that feels.
Well, if you got clips of Piezo, I'm going to tell you now, I'm going to steal them.
Do it, yeah. Hey man, share, repost anything I ever post. Y'all can do whatever you want with it.
Goes without saying, but with real truthers, dude. When I first met Witsit, I think he tested me out by stealing all my stuff and using it on globe busters immediately, and to see how I would react. Because the first conversation I ever had with him was about like black sun and deep electromagnetic shit and toroidal stuff. I was like, come out of nowhere in left field, needed some validation from somewhere, because he was like, yeah, all of that plus this. I was like, oh, cool. And then all the stuff that I given him, he just like was like, well, I wasn't gonna do a presentation on this. I'll just use all this. And I was like, neat, that's awesome. And then we became friends, right? Because I was just like, oh, you're using the things that how I wanted to depict it, and you're further explaining it even better than I could. Oh, that's fantastic. And that's the proper response, not, oh, you took my shit, and you give me my channel and mention buy my t-shirt or whatever the fuck most people do. You know what I mean? Like, most of us don't have that attitude at all. So everything that we use, share, post, everyone else is usually free to take. That's how the good people do it, I think.
Yeah, 100%. You know, Ben from Taboo Conspiracy says repost, share, whatever. Like, just go with it, man. And I think that's the vibe of anybody that's pursuing truth for real. So yeah, I love that.
You know what a good example is? Conspiracy music guru Alex. Didn't you have him on too? Maybe at some point.
Yeah, I had an interview with him and Blair.
Yeah, you're a legend, dude.
Blair wrote a song, and got conspiracy music guru Alex to come on, and it ended up being great. Just a fun talk. And then I'll drop a little sneak preview. I've talked about Dr. Stephen A. Young. I call him Steve at this point. I've emailed him a few times, and he wrote the book of Fool's Wisdom, which is just freaking great. And Mark Gober, those two are going to come on my channel with Witsit and talk about the ether and everything. I mean, alchemy, the stationary topographical plane Earth that we live on that's enclosed. And I mean, that one's going to be, I'm just going to be like quiet. I'm just going to sit there and smile.
Nice, man.
Hey, when's that happening, Ron?
It's gonna happen after they get back from Antarctica. So he's gonna have to come back and let all the dust settle. There's no like set time. We were gonna squeeze it in before, but we didn't nail down a time. But we've been emailing, and they're super based. And then our own Taylor, right down there in the listener, she's gonna talk with Pitch Lumen, Nathan. Just because I think that they are almost on the same frequency and vibe of truth thinking. But yeah, this is just fun. Like, I don't have an agenda or a plan. It's just sort of like, who do I feel would vibe well with each other? And I need to get all the Ether Cosmology boys on one at a time, probably, or even as a group, just to talk about their own journey. Because a lot of people know that you guys are legends and have, these obsidian, maps of all kinds of information that you found. But, people also enjoy hearing your personal story of how you woke up, even though that seems like old news to you. People probably like to hear it, so that's what I'm all about.
Yeah, your interviews are awesome, dude.
Oh, hey, did you hear?
You give the best.
Go ahead, Shane. I'm sorry.
That's all right, man. Go ahead.
I was gonna say, Ron, did you hear about the episode with Ashton and Austin?
Is it pending? I didn't hear about that one.
I got a hold of Ashton Forbes and Austin Witsit, and so far, as long as everything goes good with Austin's trip, January 5th.
Man, that's great news to hear. And if y'all don't know, This and That had Witsit on, and it was electric. I mean, it was great combo, back and forth, great audio. I heard it live, and if you could share that to the space, you know how to throw something up in the jumbo. You should do that.
Yeah, I will. I'm driving right now, but he was hinting. If anybody who hasn't listened or has listened to the episode, he hinted throughout the whole conversation on like several times about giants, and I never picked up on that shit. And I had to send him that in email because I was like, I cannot believe, because I listened to it, and that's one big topic I want to bring up again at some point in the future with him.
Yeah, bro. It sounds to me like there was definitely going to be a part 2 with y'all. That's going to be fun.
Oh yeah, yeah. The Ashton and him will be a completely separate one. That's just to start off 2025 with a banger.
I can't wait for that.
Dude, it's gonna be awesome. This is why I'm hoping Austin's trip goes okay. Something doesn't get postponed because he's got a family and like holiday. That's like a kind of a tight schedule. So we'll see. If I have to reschedule, I have to reschedule. No worries.
Speaking of giants, it was I don't know if it was Brian's space recently or someone else's. Ken, are you there? I had a question because in one of the spaces, someone said that Jesus at one point said we're on a corpse, like the planet. Well, the plane is a corpse, like meaning dead bodies. I think was the implication, and I mean we know these things are all over the place, corpses, the giant elephants, the titans, So I was wondering. I was asking about that quote. I don't remember who said it though.
Yeah, I don't know anything about it being a corpse. I mean, I've heard the theory before, but I can't say I've heard any scripture on it.
Oh, okay. Thanks.
Dude,
well, corpse or dead? I don't know what terminology is used. Thank you.
On a completely different, unrelated topic, if you guys are down with the black sun model and conception of the sun, our boy, God, I can't pronounce his damn psycho, some corpus from TikTok did like a nice 10-minute video on his Antarctic sun thing, on his explanation. I think he went pretty in depth. I thought it's pretty cool. I think I shared it up top. He does this like, I don't know. I got to ask him how he uses it because he uses the Flat Earth app, the Pro app, but he gets multiple domes in it, which I can't figure out how to do. He can only gives you one dome on perspective, which is a pretty good tool. And he puts like all the domes he can fit around the outside edge and models it, and it makes a lot of sense with what he's talking about. He also uses this other app, which I'm trying to get a hold of, called Firmament Trackers, from that dude Geocentric Journal of Earth, I think, from YouTube. He put out another app for tracking all the stars and the celestial objects, very much based on the personal dome model, like just using a different underlaying thing and then using some actual stellarium data. So it's an awesome app. And then this dude who uses both of these apps together to explain the phenomenon in a sort of convincing way. Just saying, it's really worth the watch. Also, I got to figure out how to use multiple observers on these apps. If anyone knows how, D3, looking at you. It's also including like what is the sun, right? That's what I titled it. It's mostly about Antarctica, but he gives a pretty good explanation on the black sun model, electromagnetic, manifestation of, how you see a personal sun everywhere, because the corpuscular ray will reach from, the sunlit link to your feet, not to your neighbor's feet, and not vice versa. You have a definite personal view of a celestial object, and then what you think that means, and then how is that produced is all tied into how we think the realm works.
Hey Shane, I was sharing some of your stuff on TikTok. It was loving it.
I got a question that you brought up Antarctica. Has anyone seen these videos? Maybe older. I just want to see if there's any truth to them. Like there's these 3-pillar structures. They're like black. They almost look like platforms, but they're huge. Do any of you guys know what I'm talking about? Take that as a no.
Well, I'm not sure about.
Was that a resounding no? Sorry.
It sounds
Yeah,
familiar.
well, these videos, they show like an orb in the center, right below the 3-pillar platform. It's like a tripod. So imagine a tripod, but it's massive, and it shows this this orb going into this beam of light at the top of the platform, and then it goes into the sky. I've seen a couple. They're grainy, as they all are. But I was just gonna kind of see if any of you guys have seen those videos and what your thoughts were on those, on the validity of them.
Well, my feedback, Josh, would be as you were speaking, my mind went to Sean from Kingdom and Context. He has stuff on the cube and Saturn and orbs, and basically like a cube with an orb in it. I don't know that he showed what specifically you're talking about, but they're obsessed with orbs and cubes.
Well, like when I say like massive, I mean like this platform is so big, you almost think that it's like a support structure. And the pretty much the way the video was going and how the guy was explaining it, that because there's several of them, it's not just one, it's several in Antarctica. And he's saying that they are like a almost like a support for what you would consider to be like the firmament or the dome. Again, this isn't my beliefs, but this is kind of how the video was going and what the explanations were and what I was reading in comments. This was on YouTube
Okay.
or TikTok, I believe. But Zach showed it to me like a couple months ago. So when he's on today, because we're doing like a random episode today before we do David Halco tomorrow, I'll probably bring it up and see if he can't tell me, and then I'll just post it.
Cool, man. Thanks.
Yeah, Mike. Well, there's video out there of a lunar eclipse from an airplane, but you don't see the moon. You just see like a shroud going in front of the sun, like it's black light or something like that. So that really piqued my interest a little bit more about black cubes and black suns. You know, it was a really good video. I'll put it up in the chat maybe, but. Yeah, post.
Yeah, but isn't there a connection between Black Cube, Saturn, and Satan or Lucifer?
Yeah, for sure. Or Nimrod, so much of it is occultic.
Something about the cycle of reincarnation and rebirth, and something I think is Saturn. Is that the arc? Egyptian. I don't know.
Hey guys, I'm just gonna jump in. I gotta go back inside with my fam, but been waiting for a minute. Just wanted to say, love you guys. JT, Shane, what's up? You're cooking on the maps, man. Much love. I gotta go. Thanks,
Yeah,
guys.
much love to
Sacred,
you.
proud. Much love to space. Just please, episode 150. Let's go.
Nice. What up, man? Nice. Thanks, bro. Welcome.
Absolutely, all
I'm
comfortable
just
on the
gonna
mic
drop
now.
down. I gotta go in with the kids and stuff, but excuse me. Yeah, just getting in with the kids. I get nervous on this mic on this space every time. Brian, much love. Lynn, oh my God. Levelheads in the house. D3, what's up? Okay, I gotta run. Dropping down. Keep it up.
Nice.
Have a blessed day, brother.
Do you guys feel like we've conquered maps? Because I feel like that. I feel like I wanted to challenge someone and then everyone disappeared and it's been crickets for like months now. Do you guys feel like we conquered maps? Because nobody brings that shit up when we're around now, right?
Yeah,
Well, there's so many different iterations of maps throughout the hundreds of years that we have them, or even a couple thousands of years. They change.
Well, the ones that we have today are specifically exactly one coordinate system. And if you look back through Wikipedia, it's the same coordinate system, even projected
That is true.
supposedly through 1700s, where they suddenly switched to a double orthographic projection of what would be conceived as
Oh
a
no, I opened
hemispherical
up a
thing.
can of worms, bro. You've been waiting for this.
Well, I
It's
mean,
so
like,
bad.
I love people. Like, that's cool. It's cool. Like, specifically from 1701 to 1799, they have only this orthographic double hemispherical projection of maps that seem to exist, but is in fact projection of the very same coordinate system that everything else is allowed. Right? We're only allowed the single projection of longitude. Damn it, Libra.
So I'll never talk about it on a mic. Never.
Stop echoing everyone, man. It's super annoying.
So you're pretty much saying that the maps have changed just due to exploration.
I'm saying that they've almost never changed, dude. First of all, historically, if you look into it, they first explore more of the sky, more of the stars, and then they find more of the map. So like it's always been, oh look, we mapped more stars. Then oh look, then later we found more land. They've only been able to map the land as according to the stars. If you think about it, makes sense. It's mostly water. It's not really a lot of land. It's only been mapping the stars. So that's historically. They've only ever mapped the stars, then the maps. Its first map ever was a star map. We were written on a cave in a wall way
Bro,
back
what
when.
coffee are you drinking right now?
This is just how I speak normally. I don't know if you've heard.
Oh, fair enough.
Sorry. But yeah, no, what does it end up with? Maps are cool, but they don't prove conclusively the shape of the Earth at all. They're actually not much tied to the Earth. It's tied mostly to the sky and large from angles to the stars, which is the geographic graticule, right? You get longitude and latitude. That's what all maps are projecting. Almost very little tied to the ground. The way they attempt to attach it to the ground is through surveying. They use geodesic surveying, but it's actually through astrogeodesics, which is how they use the combination of the God damn it,
Do
Libra.
you know who quoted this? This is like this isn't word for word, but something along the lines of, in order to map the land, one must map the stars.
Hold on, it's me. I'm trying.
Do you know what I'm talking about, Shane? I can't think of the person who quoted that, but
What? Sorry, all I heard was a bunch of echoing.
in order to map the land, one must map the stars. Do you know who quoted that?
I don't know if that is a quote, but so it starts off, I'll tell you right now, with Ptolemy and the Geographia, which is supposedly the oldest book on mapping. And what the opening statement in the preface reads is you have to accept the significance and this, like, they're synonymous of the terrestrial and the celestial spheres, where he pretty much maps out exactly what I'm saying, that you have to have the globe, which is a 1-for-1 map to the stars. Suspiciously, he has in his book, written before time and is the oldest existing book that exists, a combination of long latitudes written in terms of stadia for all the historic landmarks of the age and the time and places and mountains. He wrote literally the GPS coordinates in his book. That's what most of the book consists of, let alone it's written in incoherent, different mindsets from different perspectives, always construing different timelines, almost as if thrown together, written from different people. But that's only if you read it in Latin, right? But what that says,
Elon,
it's
Elon, if
always
you're
based.
listening, you need to add the fire emote, okay? Just so you know.
It's all been based on the celestial down to the terrestrial. That's how that's where the globe comes from. It's literally created as a model from the sky, and everything about it is based on the sky. As I was saying before, when they were trying to disprove it with a single observation of the sun in Antarctica, that's only because everything they know is based on the sky. But I'm telling you that inherently it's been that way, and like historically it has to be that way. It's synonymous with the astrogeodesic. That's what I was saying before, where they combine the geoid with the celestial. It's an actual practice. That's what surveying is used for. The only thing that ties surveys to the Earth is with the datum. The datums that we know in our WGS 84, WGS 83, NAD 83, NAD 84, those are spherical datums where they go out to measure the Earth and they do planar measurements and they adhere to, guess what? The same spherical coordinate system aligning to the stars. They do astro alignments. They do alignments to longitude and latitude. They get updates. They swap out, spherical models when they're making the measurements. If they were actually measuring a spherical Earth, there would be no need for a reference ellipsoid making these measurements, and then there would be no need for any of the models in the astrogeodetics when they try desperately to conform their planar measurements back to the sphere based on the coordinate system to the star. So that's the whole thing.
Do you think that a lot of our beliefs, a lot of the things we do, that there's a correlation possibly with the sky or the stars?
Yeah, man. Like everything, like astrology. Imagine how significant astrology becomes if it's not just random balls of gas and rock floating around an
Well,
endless universe.
because I was gonna bring up like your birth date, your birth time. Does that have any strong correlation with the alignment of the cosmos, so to speak?
In astrology, it certainly does, right? It's everything. They go through those signs, those waves. They give it your birth sign. They ascending and descending goes back to the nodes, and when they have absolutely the cycles of the sky are tied to definite birth months, all sorts of things, right? But that's only if you believe in astronomy, and now they've replaced that with astrology, and they've replaced it with astronomy.
Well, the billionaires and the trillionaires definitely believe in the sky, so
Yeah, but only the astrology, right?
right.
Yeah, man. So someone got me going because they talked about maps. Yeah, maps. I think maps are an
I can
important thing,
tell.
dude, because we conquered maps. Because I looked into all this, and then I tried boldly to like challenge any of these globers who had been saying for years that maps are hands down incoherent, like proof of the shape of the Earth, right? And I started spewing this stuff, and silence. Nobody wants to step up. Nobody has a debate. Nobody has a thing to say except what I get is comments that, well, clearly a debate isn't needed because it's already known and we know it and you're stupid. That's the only
Convenient,
thing
right?
that I get. It's the only thing that I get. And it's not like I was trying to like I want to challenge someone to openly like defend the position now that I've researched on it and I have a well articulated thing to stand on. And then it's like all I got was FTFE showing up and acting to gaslight me and say that actually no one's ever said that, right? Everyone's already known it's been a coordinate system based on the stars, you silly flurf. I was like, no way. Is that the position now? It's so anyway, what I said is we've conquered maps, I think, as flat earthers.
Although they'll say we don't have a map, it doesn't exist, but meanwhile it's living rent free in their heads, and they talk about it all the time. You know, they have the burden of proof, and then the map is one of their favorite red herrings. You know, to avoid talking about the actual shape of the Earth. You know,
Which is why there's very little actual Earth shape involved in maps, as I went over pretty specifically, right? It's all based on the sky.
that's why they wouldn't talk to you. It's oh god, we got someone who really knows about maps, and it's like no, we won't debate that.
Yeah, they immediately just took the position, which means it's absolutely right, and they've been misusing it or abusing it this whole time, either out of ignorance or, much more scarily, could it be understanding and malfeasance, right? Like, oh, I'm going to weaponize this knowledge against you. Now, I don't think any of our so-called groupies are capable of that because that requires, emotional intelligence, and I don't think they have that. I think that they just realized their position was stupid, and they don't want to talk about it when I'm around anymore.
Oh, they talk about it privately or without using your name. I just pulled out of my notifications today a response to someone about you know some of your work, but what they did was they just took like a screenshot of something that was talking about you and your model, and they sent it to him, and I just happened to look to see, well, what is he sharing here, and it's about you. I posted it in the
Nice.
purple pill and hit you up on it, so you should be able to look at what it was being shared.
Flat Earth Eric.
Oh, Eric the Camel, I couldn't see. So his argument is maps definitely prove the shape of the... No, they definitely don't prove the shape of the Earth, but look at this model that also proves celestial phenomena.
Hey, thanks. Let me know if there's a problem with the audio. I got two things. I'll be quick. I like to encourage humor as a force multiplier for our outreach. And so I'm going to tell a joke. Probably everybody's heard it because I stole it from Witsit. And I'll follow up with another thing. Is what do you call a bear that spends the winter in the north and a summer in the south? It's a bipolar bear.
Do you guys know that a bipolar sphere doesn't actually exist anywhere in nature? No one's ever seen one.
It's a joke.
No,
Hey,
I know. It's funny. I laughed, and then I moved into the next.
Yeah, it's a joke. Yeah. Now, point number two. I see we've got a new listener here, Jan Toskov. He's a guy I've been engaging on Twitter. He's a friendly glober, and if you would just say hello to Jan, maybe he'll say hi back.
Hey, Jan. Yeah, I dropped you a little message in Eric's timeline. You grab a mic if you want and come up, ask any questions you want, or just visit. We're friendly to our globe friends.
Yes, thank you. Hello, everyone.
How are you?
How is the audio?
You sound very good.
Okay, thank you. So, first time for me participating in any such discussion. My background is engineering. I've been studying mechanical engineering. I was engineer on board of chemical and oil tankers. I have traveled all around the world. I have been studying additionally general and special relativity. And I'm curious what the incentives behind the theory of flat Earth are. And what is, I went to with our friend, we were discussing, and I asked him, I understand why some people are suspicious about the moon landing. There is a clear incentive over there that during the Cold War, if one side fails, they practically are losing the race. And the side that succeeds is actually the superior power. And if the USA faked the landing, I think they landed, but if they would have failed, better to fake it in order to prove superiority. My question is, what is the incentive here? In order to maintain Y that goes for centuries, there should be some very strong incentive. And I don't understand, I don't understand this. For instance, right now, there are tons of YouTubers that are having cameras all around SpaceX. They record everything. There are tens of thousands of people working for SpaceX, and they send rocket up. On the rockets, there are cameras that are showing live and at every second of the launch. And this should be some grandmaster why. I don't understand what is the reason for those people to lie.
Why not?
That's my question.
Yeah, I'd like to respond real quick. You have kind of a mixture of questions and feelings going on right now, and I'm not a debater. I'm not going to try to like slam you with tons of facts. I'll let the other guys get into that. I'll just tell you personally, my incentive and my motivation is to seek and find the truth, because I think we live in a realm, like we live in a place that there are many, many deceptions. And you kind of touched on the moon landing, might have a few odd things going on, or the ISS footage might have some strange things, don't make sense, or even like the China space station footage versus America, some inconsistencies. And I'll just say, my journey started when someone told me that outer space, as we were taught when we were kids, is not an actual place you can go to, that it's a man-made invention in the mind, and it's based on philosophy. And so that got me digging into, well, what is true? What is real? And my incentive is because I have 3 small children. I don't want to just tell them what was passed to me when I was a kid. If we're not on a spinning water planet orbiting the sun, if we are a stationary topographical plane that's enclosed, I would much rather know the truth, or at least pursue the truth honestly, intellectually honestly, and open-mindedly, than just being crammed and force-fed what the consensus and the masses believe. Because I honestly believe that the heliocentric theory is one based on materialism, and it pushes any metaphysics out or spirituality out. If they can't measure it, touch it, and see it, it doesn't exist. I now believe in the ether. And yeah, it's been a long road, but if I'm wrong, I'll say later, oh my gosh, I can't believe I got tricked by flat Earth. That was so wild. But if you really, really dig into it and you take your time, you'll see that it's band-aids on band-aids, and there's no unified theory, and it's all just conjecture. And it's pretty lame when you really look into it. But welcome, ask any questions you want. There's a lot of great people on the panel that can answer your questions.
Thanks, Run Boston Bear. Jan, I've got a short answer for one of your points was about the Cold War. Is the audio good?
You sound great.
The audio is good.
All right. We've heard Jaron say this, and other people have explained it, that the Soviets claim to their population, not the Russians, the Soviets, that they were first in space and first woman and, first man and all this. They had several firsts, the United States gets to tell its population, hey, we were the first on the moon.
Mm-hmm.
And so both sides win. And that's the story I've heard. So maybe keep an ear out for that and see what you think of it. That's all.
Mm-hmm. Okay. So, from what I know, I was born in Eastern Europe. So, from what I know, there is no any discussion, there is no argue between the versions that are known in Russia and are known in the West.